Hey Nick, what's with the green box around your head?
What green box?
The one that's currently around your head?
They're on to me. Just kidding. If you want to be able to detect just about anything using Tensorflow Object Detection, this is the course for you.
What's happening, guys? My name's Nicholas Renat, and in this video, we're going to be going through the full-blown object detection course. So whatever object detection use case that you wanted to tackle, you'll be able to do it after going through this course. Now, we're specifically going to be going through 4 different use cases, so you'll be able to repurpose the code that we've actually got to be able to specifically detect the exact objects that you want to use. And it's all done using open source tools, mainly Python and TensorFlow Object Detection. Now again, this could be used in a whole different range of use cases. So say for example, you wanted to detect a person's face, or if you wanted to do sign language detection or face mask detection, this is the exact same code that you can use. Now the nice thing about this as well is that we'll go through all of the setup, all of the installation, we'll show training, we'll also show exporting, which is a really big part of being able to build object detection models. So we'll be able to export this to the Tensorflow Js format as well as TFLite. So if you wanted to run it as part of a web app, or if you wanted to even use it on a Raspberry Pi, you could. And we might just do that in one of our projects towards the end of the tutorial. So without further ado, ready to do it? Let's get to it.
Alrighty, what's happening, guys? Welcome to the Object Detection course. Now, this course is intended to take you from being a complete beginner when it comes to object detection all the way to being fully proficient and acting as a practitioner. Now, again, we're going to take this step by step so you'll be able to walk through at your own pace and be able to learn and leverage the technologies. So let's take a look as to what our actual game plan is for this. Now, there's going to be a bunch of stuff that we're going to go through. So ideally, this course is going to be fully comprehensive. So you're going to need you're going to have everything that you need to be able to get up and running. So there's 8 key parts that we're actually going to go through. And each of these key parts are pretty important when it comes to building object detection models. So first up, what we're going to do is we're going to install and set up everything that we need to be able to perform object detection on our local machine or PC. Now, in this case, we're going to be using the Tensorflow Object Detection API, and we're going to be doing that mainly using Python. Now, the reason that we're using the Tensorflow Object Detection API is that it has a whole bunch of additional capabilities that make it a whole heap easier to be able to build object detection models. So if you've ever looked at a real-time object detection architecture or model before, there is a bunch of stuff that you actually need to build in order to actually get one of these up and running. There's pre-processing steps, there's post-processing steps, there's visualization utilities. Now, again, if you're not familiar with any of these terms, don't fret. We're actually going to take it step by step and walk through each of those components. Just know that building this from scratch takes a lot of effort. So using TensorFlow Object Detection speeds this up a whole heap. So what we're going to do is we're going to install and set up the TensorFlow Object Detection API. Then what we're going to do is we're going to collect images and label them. So in order to do that, we're going to be leveraging our webcam. So we'll leverage our webcam to be able to collect a whole bunch of images to be able to label our objects. Now, you're probably thinking, Nick, what the hell is labeling? Well, ideally, what you want to do when you're building an object detection model is you want to be able to label or identify the objects that you want to try to detect. So say, for example, we were building a face detection model. Well, I might use my webcam to take photos of myself and then draw a label around my face. So that what I'll then do is I'll take that trained image or that image which has been labeled, and I'll leverage that in my trained object detection model to be able to detect that in the future. That brings us to our next step, training the model. So again, we're going to be using the TensorFlow Object Detection API, and we're going to be passing through both our images and our labels or our annotations to be able to train this model. Now, there's a whole bunch of different types of models that you can actually leverage there, and there's a bunch available through the TensorFlow Object Detection API. So we're going to be using a mobile net architecture, but again, I'll talk about that a little bit more once we get to it. So we're going to be training that model initially, and we'll be able to leverage that throughout the process. Now, if you're not sure what training is, so when it comes to traditional programming, you typically have data plus rules. So think of your data as the feed that you're effectively getting, and then you pass it through some rules or some logic to be able to get answers or an outcome, right? So say, for example, you get, so somebody sets a color variable, for example, so the color is red. You might then take that variable and go, if the color is red, then do X. If the color is not red, then do Y. So that if statement, think of those as those rules. And effectively what you're doing, that action is your intended consequence. Now, when we actually train a deep learning model or an object detection model in this case, we're not actually specifying those rules explicitly up front. This is the beauty of machine learning and deep learning. So rather than defining those rules and defining what to look for when detecting a face, we're actually going to do it the other way around. And this is normal when it comes to machine learning. We're going to give it data plus answers. So our data is our image and our answers are our labels or our annotations. And we're going to train our object detection model to learn the rules to be able to detect faces. So machine learning sort of flips traditional programming on its head. So rather than starting off with data and rules and getting answers, we're starting off with data and answers to get rules. So it's a slightly different paradigm, but it ideally gives you a really cool output. So once we've trained our model, what we're then going to do is we're then going to start detecting some objects. Now we're going to do this in two different ways. So we're actually going to detect the object using an image. So say for example, you had an image and you wanted to be able to detect different objects in that image. We're going to be able to do that. So this is normally known as static detection. So you're going to be grabbing a particular object from over there or over there and being able to grab that image, pass it through to our model and detect an object. But then where I think the real good bit is being able to detect objects in real time. So we'll be able to take our webcam, face it towards a particular frame or a particular thing, and we'll actually be able to detect objects using a real-time feed. Now, the beauty of this, and particularly the beauty of the model that we picked in step 3, which is a mobile net model, is that it's going to be super fast. So we'll be able to detect objects in real time when we've got a computer or a GPU-powered machine, and we'll be able to detect those objects in real time. So we can do a lot with that because it is fast. Now, normally there's a trade-off between speed and accuracy, but again, we'll talk about that in performance tuning. All right, so in detecting objects, we're going to detect stuff with an image, and we're also going to detect stuff using a real-time video feed. Then what we're going to do is we're going to learn how to freeze and convert our model. So whenever you're building models, ideally what you want to be able to do is save down that model and maybe give it to somebody else. So if you're part of a software engineering team and you're the data scientist, what you might want to do is you might want to export your trained detection model, pass it through to your software development engineers or your machine learning engineers to then be able to go and deploy that model. This is where freezing and conversion comes into play. Now, again, with TensorFlow Object Detection, you are able to freeze down your model. Think of freezing as saving it. And then if you wanted to, you can convert it into different formats. Now, in this course, we're going to cover how to convert it into a TensorFlow Js format, and we're also going to cover how to convert it to TFLite. So those tend to be the two most popular formats that people leverage when using the TensorFlow Object Detection API. And we're going to cover them both. Now, I normally get a lot of questions on this. So performance tuning. So we're now up to step 6. So we're going to be covering install, collecting images and labeling, training, detecting, freezing, and conversion. Step 6 is a lot of the time where people come undone. So being able to performance tune your model is so important. So say, for example, you use your webcam, you go to detect some stuff and it sucks. It's really, really crappy. And it's not actually detecting the objects that you want it to detect. Well, what are the steps that you actually go through to be able to improve the performance of that model to then be able to accurately and effectively detect those objects? So we're going to cover what to do when things go wrong and how to actually performance tune your models and improve that performance so that you can get back on track. All right, so that's step 6. Then what we're going to do is we're going to learn how to train on Colab and a cloud instance. Now, the beauty of this and everything that I cover in this course is that all of the code and the full walkthrough as well as a guide is going to be available on GitHub. So if you go to the GitHub repositories that I'll show you later, you'll actually see that there's a written guide in terms of how to do this as well. So I've written a really big README and a step-by-step walkthrough to actually get this up and running, as well as a couple of extra bonuses to make this a little bit easier on you. Now, in step 8, this is where it all comes together. So we're going to be doing 3 different projects. Now, and again, these are projects that I've really wanted to do for quite some time, and we're going to be doing them in real time. So the first project is actually going to be one that I've always wanted to do. We're actually going to be using this microscope, which is a USB microscope, to be able to detect defects in particular or small pieces. So in this case, I've got a couple of LEDs here that I pulled out of my Raspberry Pi kit. So in this case, it's really, really small. Let's see if we can see that. You can see that right there. So it's a really small LED, and you can see that this one, there's no issues with it, right? But then this one, I've obviously got a bent pin. So if I bring that a little bit closer, you'll see that this particular pin is bent, right? We're actually going to train an object detection model to leverage this microscope to be able to detect those bent pins. Now, this has a whole wide range of use cases. So say, for example, you had a PCB, so a printed circuit board, and you wanted to be able to detect defects in that. Say, for example, you wanted to be able to look at a petri dish and be able to detect different things within a particular microscope slide. You could do that as well. So that'll be project number one. Project number two is going to be able to detect directions. So we're going to train a model to be able to detect our hand pointing up, left, right, and down. And then we're going to take that model, convert it to Tensorflow Js, and actually integrate it into a web app. So say, for example, you wanted to build up on that and build a real-time game and pass through detections using your hand or using object detection, you'd be able to do that. And then our third and final project is actually going to be Raspberry Pi object detection. So again, this one tends to be really, really popular. I have seen a bit of a performance drop off when you do pass it to Raspberry Pi, but we'll take a look at that. So we're going to be ideally trying to be able to detect sentiment from our face using our Raspberry Pi. So again, I'm going to show you how to do all of that. Alrighty, so there's 8 steps. We're going to go through it all. And again, take this step by step. So ideally what I'd recommend is go through each part, take a break, review what you've actually gone and done, make sure it's all working before going on to the next step. Take lots of notes. And again, if you've got any questions, hit me up in the comments below and join the Discord server. That's probably my best tip as well. So I'm going to include a link inside of the description as well as in the pinned comment to be able to join the Discord server. So again, a lot of the people following the tutorials that I put out on YouTube are on that Discord server as well as yours truly. So you'll be able to jump on in there and get some help if you need it. But I'll also show you how to sort of debug and walk through this tutorial. So that's our game plan, those 8 steps. Now, without further ado, let's kick things off and let's step into step 1, install and setup. Alrighty, install and setup. So the first thing that I'm going to sort of show you is where to get the code for these tutorials. So in this case, I've got 3 sets of code. One is more important than the others, but I'll show you each of those. So I've gone and built 3 different sets of GitHub repositories that you're going to be able to pick up and leverage to get up and running with object detection a whole heap faster. And if you've done any of my previous object detection tutorials, let's say, for example, the face mask detector or the sign language detector, what I've actually done is I've actually improved that code base. So I've actually made this flexible enough to work on a Windows machine, a Linux machine, work on Colab, a whole bunch of different environments. So it actually detects what environment you're trying to use and runs the appropriate code, sorts out the file paths, so on. So there's 3 different sets of code. So there's the TensorFlow Object Detection course code, there's the TensorFlow Object Detection app. So whenever I say TFOD, that's just TensorFlow Object Detection. Then there's the TensorFlow Object Detection Raspberry Pi code. So you're going to get 3 different sets of code. Now, in order to get to these, you just need to go to https://github.com/nickknockknack/TFOD course/TFOD app and /TFOD RPi. So if we actually take a look at those, so this is the course code. And again, you can see that we've actually got our baseline image. So here you can see that we're detecting live long and thumbs up. Now again, we're actually going to build this course, or we're actually going to build this object detection model first up. So it's going to be a gesture-based model. And the nice thing about each of these repositories is I've actually written steps rather than made a video tutorial on top of this, so that if you prefer just walking through a step-by-step guide, you can just walk through each one of these to be able to build up these models as well. And I've done this for the TensorFlow Object Detection course code, which is the main training code. I've also done it for the app code, so it shows you how to deploy the app. And I've also done it for the Raspberry Pi code. So it shows you what you need to install, what you need to clone to be able to get this up and running. So again, all of this code is going to be made available. So if you check the links in the description below, you'll be able to pick all this up. You'll be able to leverage it till your heart's content and be able to build a whole bunch of different object detection models. So those are the 3 sets of code that we're going to be able to leverage. So you'll see once we kick off or once we actually start, the first step that we're actually going to go through is clone this code. And again, we'll just be using git clone to be able to do that. Now, the next thing that we're going to be doing is we're going to be creating a virtual environment. So again, I'm going to explain a little bit of the code before we actually go ahead and do it, but I don't want to spend too much time on slides. So think of a virtual environment as a separate room in your house. So it's like creating a separate room in your house. Now, the reason that we're actually using a virtual environment is that it isolates all of the different Python and all of the different libraries, dependencies, and different things that you're actually going to need for your TensorFlow object detection model. Now, this makes sure that it doesn't conflict with all of the different libraries and dependencies that you've already got installed inside of your Python or Jupyter environment. So what we're going to do is we're going to create a new virtual environment. So think of it as creating a new room in your house, and we're going to install all of our object detection stuff inside of there. So it doesn't mess around with any of the other things, and it ensures that you get all of the main dependencies that you need and you don't get any dependency conflicts. Now, in order to do that, we're going to be using a library called venv. So this allows us to create a new Python environment. And again, we can name it whatever I want or whatever you want. Then what we're going to do is we're going to activate it. I'll talk about a little bit about that later. We'll upgrade our pip dependency. So this makes sure that we have the latest resolvers and all of the good stuff that we need. And then we're going to be installing IPyKernel. So IPyKernel is a really important dependency because it allows you to associate your virtual environment with your Jupyter notebooks. So ideally, we're going to be working inside of Jupyter notebooks. Now, we won't cover installing that. But again, if you want to see how to install that from scratch, I'll link to the other installation video where we do the Anaconda install and the Jupyter Notebook install. But more often than not, if you've done any data science or object detection tutorials before, you'll have Jupyter Notebooks installed. So this is going to cover all the stuff that you need to go from Jupyter Notebooks a little bit further and be able to build your object detection models. All right, creating a virtual environment. So think of it as a separate room inside of your house where you're going to install all of your object detection stuff, so that it doesn't screw up everything else. It's also like locking yourself in a room and getting stuff done, right? Keeping everything in one place. Now, there's a bunch of dependencies that you need to install whenever you're working with TensorFlow. Now, the first and foremost one is going to be the Visual C++ build tools. I'll show you where to install that. So it's really a just download and install, nothing too special there. So TensorFlow needs Visual C++ build tools in order to run. That's pretty straightforward. Now, again, I'll link to the other install tutorial where you can pick that up. So that one's pretty straightforward. Where most people tend to get hung up is installing these two though, CUDA and cuDNN. So CUDA and cuDNN give you GPU-based acceleration when training your TensorFlow object detection model. So the reason that you use a GPU is that it is exponentially faster to train an object detection model using a GPU versus just using your raw CPU and your raw memory. Now, if you don't have a GPU, don't worry about it. You can still go through this tutorial. It'll just take a little bit longer to train your model. Now, if you do have a GPU and you've gone through an object detection tutorial before and it wasn't actually activating or it wasn't actually being utilized, and I'll show you how to check that, then what it might have actually been, particularly if you're using TensorFlow, is that you might not have had the right CUDA and cuDNN installations available. But I'll show you how to actually see whether or not, or how to actually find an appropriate combination. Now, the reason that I'm talking about this is because there's consistently going to be new versions of TensorFlow coming out. So you might need to update your CUDA version or update your cuDNN version in order to be responsive to that actual change. So I'll show you where to do both of those or how to detect both of those. And let's actually take a look at that. So in terms of Visual Studio, so what you just need to do is go to Visual Studio Community, download Visual Studio. So this is going to download everything that you need. And then ideally what you want to do is just run this install. So this is going to install these C++ build tools. Now, again, if you want a full walkthrough, so really it's just a matter of downloading this and installing that. So it doesn't need a whole bunch of stuff. So I'm going to cancel that because I've already got it installed. So you just need to download that, install that, and that's going to give you your C++ build tools. But again, if you want to see a full walkthrough on how to install that, I'll include a link to that as well. Now, the next thing, which is more important, is CUDA and cuDNN. So this only applies if you've got a GPU and you want to use GPU accelerated training. Now, I'm not going to do this first up because I'm going to show you how to check your TensorFlow versions and then map to the appropriate CUDA and cuDNN libraries. Now, the reason that I say this is if you actually go to this link, so tensorflow.org/install/source, also this one down here. But again, links will be available in the description. If you actually scroll all the way to the bottom, it actually gives you the appropriate versions of TensorFlow and CUDA and cuDNN to use. So in this case, this is just CPU. So again, you can run this full object detection tutorial on your computer, even if you don't have a GPU. It'll work fine, it'll just be a little bit slower. But more importantly, these are the GPU combinations. So here, if you're using TensorFlow 2.4.0, you need to be using Python version 3.6 to 3.8. You need to have the GCC compiler 7.3.1, Bazel 3.1.0, and more importantly, CUDA and cuDNN. So here we've got, so TensorFlow 2.4.0 runs with CUDA 8 and CUDA, or cuDNN 8 and CUDA 11. So you need to make sure, this is so important, you need to make sure that the TensorFlow version matches these two CUDA and cuDNN versions up here. So if they don't match, it'll still run, it just won't leverage your GPU. And you'll probably be sitting there thinking, hey, I've got a GPU, why isn't this training faster? More often than not, it's because of that. And I'll actually show you how to check your TensorFlow version and how to get the appropriate CUDA and cuDNN versions once we've gone through the initial steps of our install. So this is the Linux Mac OS combo. If you go to the Windows one over the left-hand side here, so in this case, the install or the link is /install/source_Windows. Again, same style of thing. And again, it talks about the Visual C++ build tools over here. So again, it just tells you, go to Visual Studio, hit Visual Studio Downloads, select Read Distributable, download and install. And the reason that I'm sort of going through this is I'm sort of showing you where the information that I'm teaching you is coming from. So this gives you an idea as to where to go to get help. But again, you can always hit me up in the comments. So again, you got to install Visual C++ build tools through the downloads. Now, if you go down further towards the bottom, these are the combos for Windows. So again, if you're using TensorFlow, or if you're using TensorFlow GPU, you need to be using TensorFlow GPU 2.4.0 and CUDA 8 and 11. If you're using TensorFlow GPU 2.3.1, for example, then it's going to fall into this category. So you need to be using Python 3.5 to 3.8. You need to use the Microsoft Visual C++ build tools to 2019. So this is just talking about that compiler that we had right up here. So it sounds complicated, but really it's just talking about that visual, or this thing that we were just downloading. So that's fine. So you can use that. Oh, we've moved that. So Microsoft Visual Studio 2019, and you need Bazel, but again, that's normally pre-installed. And you need, so in this case, if you're using 2.3.0, you need CUDA, CUDA 7.6 and 10.1. So again, there's really specific combinations that you need to be using if you want to be training on your GPU. Cool. All right, so that talks a little bit about that, but we'll actually come back to that GPU install a little bit later. So I'll actually show you how to check your TensorFlow version, make sure that you've got the right version in your virtual environment. Think about it as the other room inside of your house, and then find the matching CUDA and cuDNN versions. Okay. Now, all of that might seem pretty complicated, so you're probably thinking, all right, Nick, what the hell am I going to do if I get errors? Because undoubtedly, you will get errors as part of this. It's always being updated. There's always changes. There's a couple of things. So the first thing that I'd recommend is if you're getting errors, by all means, do mention it in the comments below. But if you're getting errors during the installation steps or while you're actually running the notebook, I've actually put together an error guide. So if you go through to the TensorFlow Object Detection course GitHub repository, which is available at github.com/nickknocknack/TFOD course. Now, again, this link's going to be available in the description below. I've actually put together this error guide, and this is based on all the errors, all the questions that I saw people were asking me as part of the other object detection tutorials that I've got. So you can see here that, say, for example, you get an error which says no module named whatever that module name is. Well, more often than not, the solution to that is to go on ahead and install that module. So say, for example, I've actually got an example here. So if there's no module named TypeGuard, well, what you want to do is then go and install TypeGuard using pip install. Another one that's really, really common is the PyCoco tools one. So in this case, so say, for example, you get this error here. So let's zoom in on that so you can see it. So value error, numpy, nd, array size change may indicate binary incompatibility. Expected 88 from C header, got 80 from PyObject. Sometimes these errors aren't very descriptive. So you probably think, oh, well, that's a NumPy error, but actually it's a PyCoco tools error. Now, again, all of these errors and all of this error guide is going to be available inside of the GitHub repository. And my goal is to ideally be consistently updating this. So if there's new errors that pop up, or if there's new things that pop up that need a solution, I'm going to be consistently posting it in here. So I'll be cloning it, updating the error guide so that you've consistently got another place to turn. But again, the other place that you can turn if you need support is to jump onto the Discord server. Again, I'll include a link in the description below. There's a bunch of people that are already on there that are awesome. They're providing help to anybody that's actually going through these tutorials. Okay, so that is the next thing that I sort of wanted to show you. So that's the error guide and where to get help if you get stuck. Okay, so that's a lot of slides. Now what we want to do is actually get started with this thing and start building up our object detection model. So the first thing that we're going to do is, as I was saying, we're going to start up by creating our virtual environment. Now, in this case, I've actually got the steps to create the virtual environment inside of the Tensorflow Object Detection course code, which you can see down here. Now, the first step that we ideally want to do is we want to clone this Tensorflow Object Detection course repository, which contains our checkpoints, which we can get rid of that. I don't know why I included that. It includes our git ignore file, our image collection notebook, training, let's zoom in, a training and detection notebook, our error guide, which I just showed, as well as this README, which gives you all of the steps that you need to go through. So let's go on ahead and clone this repository. So I'm just going to copy this link and go to a new command prompt. So in this case, I've got a new command prompt because I'm on Windows. If you're on a Mac or a Linux machine, you'd just be opening up a terminal. And I'm going to do this side by side so you can see what we're doing. So I'm going to create a new folder inside of my D drive and inside of my YouTube folder. And I'm just going to call it, let's call it Tensorflow Object Detection. Cool. And then what we're going to do is go into that folder. So I'll go into CD YouTube, CD Tensorflow Object Detection. And then what we're going to do is clone that repository, as I was saying. So we'll type in git clone and then that link. So again, all of those links are going to be available inside of the description below. Let's just make this so it's a little bit easier to see what we're doing. All right, so we've written git clone and then https://github.com/nickknocknack/TFOD course. So this is going to give us all of that stuff that you saw inside of GitHub, right? So it's going to give us the notebooks and a bunch of other stuff. And it's actually going to create a new folder inside of this Tensorflow Object Detection repository, or inside of our Tensorflow Object Detection folder that we've already got inside of our File Explorer. So if we go on ahead and run that, that should clone down. And you can see it's cloning, we're receiving objects. So again, the speed at which this clones is going to be dependent on your internet. Mine over here sucks, so you can see I'm getting 2.39 megabits per second. In this case, that's now done. All right, cool. So we've now got our repository clone. So again, everything that you saw over here is now over here locally. So what we now want to do is start creating our environment. So in order to do that, as I was saying, we're going to use that VENV package, which we had over here. So we're effectively going to go through steps 2 and 3 now. So we're going to create our virtual environment and then we're going to activate it. So think of activating it as actually, we've actually stepped out of that. Think of activating it as actually stepping into that room. So I said creating a virtual environment is like creating a new room in your house. Well, activating it is actually like stepping into that room. So you're now inside of that environment where you're going to isolate your libraries. So we're first up going to create our new environment. And we can do that using this command here. So Python-m venv TFOD. Now, the TFOD, I'm just going to make this a little bit bigger. The TFOD at the end of that is actually the name of the environment that we're going to be creating. So if you wanted to name it something differently, you could. If you wanted to name it my special environment, you could. You can name it whatever you want. So in this case, I'm just going to clear this using CLS. If you're on a Mac, it's going to be clear. And we're going to do that. So Python-m venv TFOD. So what I've actually written here is we're using Python, we're passing the M flag, and then we're going to be using venv, which is the dependency that we're using. And then we're going to be creating a new environment called TFOD. So our virtual environment, think of it as our new room, is going to be called TFOD. So if I hit enter, what you should see is that we're now creating a new, we should have done it inside of there. Let's delete that. All right, that's my error. Again, there's going to be errors, stuff breaks. This is sort of what I want to show you, the realities of actually doing this. So we're going to delete this here. We're actually going to do it inside of this TFOD course folder. So we're going to cd into that. And we're actually going to repeat that command here. So you saw that when I created it initially, it created it outside of there. So we're going to go into this folder now and we'll create it in here. So let's do it again. So we'll type in Python -m venv TFOD. So now it should create in here. And the reason that I do this is I just like keeping everything isolated. So the main training code, I like having it in one section. The app code, I like having it in a separate section. And then the Raspberry Pi code, I like keeping that separate as well. Again, you can play around with this. You can have your environment elsewhere if you wanted to. I just keep them isolated so that I can see what is what. Okay, so you can now see that we've now got our TensorFlow Object Detection repository created. So if I make this a little bit bigger, this folder over here is our TensorFlow Object Detection virtual environment. So if we open this up, there's a bunch of stuff in here. So in this case, it's going to vary depending on whether or not you're doing this on a Mac or whether or not you're doing it on a Windows machine. If you're doing this on Colab or on a cloud instance, you don't need to create a virtual environment. So those are set up so that they all run on their own individual pods. So you don't need to go on ahead and do this. But if you're doing it locally, which I suggest you do, because that allows you to do real-time detection, more on that later, go on ahead and create a virtual environment. So the main thing that I tend to look for is inside of for Windows, if I go into libs, site packages, you can see that we've got a bunch of different libraries available there. So we've got pip, pip-19.03.dist-info, a bunch of different packages, right? Now, a really important thing is, right, so if I type in pip list, which normally shows me the different Python packages that I've got available, you're going to see a ton here, right? So I've got a whole heap of different libraries available right now. Now, the reason that you're seeing all of these here, but only a couple here, is because I actually haven't activated my environment yet. Now, this happens so often. You need to make sure that you activate your environment in order to see your isolated packages that you've actually got installed. So what we're going to do now is actually activate our environment. Now, the command that you use is going to differ depending on whether or not you're running on Linux or a Mac. So if it's on a Linux, what you're going to do is run source TFOD, or whatever the name of your virtual environment is, /bin/activate to be able to activate your environment. Now, if you're on Windows, I don't know why they made this different, but it is different. It's /TFOD, again, or the name of your environment, /scripts/activate. So in this case, I'm on a Windows machine, so we're going to be using the second command here. So we are going to effectively be going, so if I go back into our main folder, we'll go into TFOD, we'll go into scripts, and we're going to be running activate, which you can see over there. So there's an activate file and an activate batch file. So let's go on ahead and run that. So we're going to /TFOD, /scripts, /activate. And watch what happens once I actually run this, right? So right now, we don't actually have, we're not actually inside of our virtual environment. If I run this, you can now see that we've got this little thing over here. So this tells us what virtual environment we're actually in. So we're now inside of our TensorFlow Object Detection virtual environment. So again, we've now stepped into our new room. Now, if I type in pip list, you'll see that it's way shorter, right? So this actually represents the actual sets of libraries that we actually had available inside of there. So remember, all of these packages are here. We don't have all of these over here. Now, if you wanted to deactivate the environment later on, all you need to do is type in deactivate. This is going to step out of it, right? So you can see that the TFOD is now gone. In this case, we actually want to activate it, so let's do that. TFOD, scripts, activate. So we're now back in. So you can see that we're now there. All right, we're going to clear this, clean it up. The next thing that we need to do is install a couple of key dependencies. So the first one is we want to upgrade pip. So this is going to make sure that we update using the latest resolvers and that we've got the latest pip package. And in order to do that, we just need to run this command here. So Python -m pip install --upgrade pip. So let's do that. We're going to type in Python -m, what was it again? Pip install --upgrade pip. Pip install -upgrade pip. So this is going to upgrade our pip installer. And you can see it's uninstalled 19.0.3 and it's installed 21.0.1. And the thing that you'll notice is that as you're updating these packages, you can see them updated inside of our site packages folder as well. Now, this just makes your life a whole heap easier because you can actually see what's being installed in real time. Now, when it comes to actually installing TensorFlow, you'll actually see that this is really useful because sometimes you need to run through the install multiple times to make sure they're installed. But I've actually also got a verification script as well to make sure that we've got all the right packages to be able to go on ahead. Okay, so we've now gone and upgraded pip. So the next thing that we want to do is install IPyKernel. So IPyKernel allows us to associate our virtual environment with our Jupyter notebooks. So we're going to be mainly working with Jupyter notebooks. If you're installing Jupyter notebooks for the first time, I'd highly recommend go to Anaconda Python. So you can actually install Anaconda, and this is going to give you a bunch of Jupyter notebooks, Jupyter Labs to be able to get this up and running. If you don't have Jupyter notebooks installed already, I'd highly recommend just running through this. Reasonably straightforward to get up and installed. I've got a video on installing that separately that I can link to you as well. So let me know in the comments below if you want that. Also, let me know in the comments below if you like this sort of format, me sort of just walking through and giving you an idea as to how to actually go through this. Always welcome for feedback. If there's anything you do like or you don't like, by all means, do let me know. Okay, so where are we up to now? So we were installing IPyKernel. So let's do that. So again, IPyKernel allows us to associate our virtual environment to our Jupyter notebook. So first up, we need to install it. And then the second line here is actually going to allow us to associate it. Oh, a little bit of a typo there. That's fine. So let's go on ahead and install IPyKernel. So pip install IPyKernel. Let's make this a little bit bigger. And again, you can see that we're installing libraries over here. We can hide our navigation pane. So you can see that these are all being installed now, right? Now, if we type in pip list again, let's jump back here. You can see that we've now got additional packages. Now, the next thing that we want to do is actually install our virtual environment into Jupyter. So this is often where people come unstuck when using virtual environments with Jupyter for data science workloads. You need to install it into your Jupyter kernel notebook. So this is going to give you the ability to see that virtual environment or associated to your notebooks. So in order to do that, we're going to be running this command. So python -m IPyKernel install --user -name tf equals TFOD. So let's go on ahead and run that. So IPyKernel. All right. So python -m, what was it again? I already forgot. IPyKernel install --user -name equals TFOD. That should be right. So actually, let's clear this so we can actually see it a little bit better. What was it? So python -m install python -m IPyKernel install. My bad. -user -name equals TFOD. Okay, let's check that. Python -m IPyKernel install -user -name TFOD. Okay, this is all good. Now, I wanted to call this out. So this last bit here is effectively telling the IPyKernel package what the name of your virtual environment is. So if you change the name of your virtual environment, you need to make sure that you change this name here. So say, for example, when I created my virtual environment, so I wrote python -m venv my special environment. When I go to install that virtual environment into my Jupyter notebooks, I need to change that name here. So in that case, it will be my special virtual environment, whatever you called it. So in this case, if I hit run, that's going to now install it. So you can see installed kernel spec TFOD and blah, 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 blah. So now we've actually got that particular virtual environment available inside of our Jupyter notebook. Now, an easy way to validate that is just start up Jupyter notebooks. And if you create a new dummy notebook, or even if you just hit new, so you'll see that we actually have TFOD available there. So that is our virtual environment now made available. So now we can actually leverage that virtual environment when we work with our notebooks. Cool. All right. So that brings us to step numero 5. I don't know how to say 5 in Spanish, unfortunately, but step 5. All right. So we're now up to here where we're actually going to go on ahead and collect our images. So up until now, we've sort of done quite a fair bit. So we've gone through and set up our virtual environment, and that's our baseline setup now installed. Now, the next thing that we're going to be doing is, as I was saying, collecting our images. So let's go back, and we're now going to collect and label our images. So part 2 is collecting and labeling our images. So remember, cast your mind back. What I was saying is when we actually go and leverage deep learning models, we're going to be passing through data, aka images, and answers, aka our labels, to be able to train our object detection model. So collecting and labeling good images is really, really important. Now, in this case, to be able to collect and label our images, we're going to be leveraging this Jupyter notebook that you've got here, which is one.image collection, and we're going to be using a webcam. Really important thing to note is if you're doing this on your machine, you need to be able to have access to your webcam in order to be able to actually collect images using your webcam. Now, when it comes to labeling, we're going to be using a library called LabelImg. So if I actually go back, I can show you what that looks like. So it's LabelImg. And this allows you to label different images within an image. So in this case, it's really, really simple, and it's really sort of fit for purpose. Nothing crazy that actually is involved in actually doing this. So we're going to be using that as well, and I'll sort of walk you through setting that up. Okay. Now, in terms of best practices, there are a couple of things to note. So when you're labeling, keep in mind the case that you're actually passing through to your images. So you want to make sure that the names that you pass through when you're actually labeling them are the specific case that you want to render. So in this case, if I name this completely lowercase live long, when I go to actually train my model, the label that I pass through needs to be live long as well. So again, I'll talk about that a little bit later. Keep your labels as tight as possible. So don't be going, so in this case, I was labeling the live long sign. Don't create a big square around it, right? So you want to keep these labels as tight as possible in order to make sure that your model is able to detect specifically that object, right? This helps a lot when boosting performance. And then include pictures of objects at different angles and under different lighting conditions. So what I tend to do is I'll actually so if I'm doing gesture recognition, for example, let's get my hand in the photo. So I'll actually move my hand around. I'll take it at different angles, at different lighting positions, so that my model learns to generalize better. So ideally what you want your model to do is perform well, not only on your training data, but also in the real world. This is what is known as your model being generalized, right? So it works well in general. Now, in order to get a model that performs that well, you want to give it a whole bunch of different types of instances of the object that you're trying to detect. So say, for example, I was trying to detect pictures of my phone, right? If I took a photo of my phone, let's disable that. So if I took a photo of my phone just like this, in the real world, if I then went and flipped my phone, if it had never seen images of a phone that looks like this, right, with the different cameras, it'd be really difficult for it to detect that, right? So ideally you want a whole bunch of different angles. So if you're detecting fish, for example, you'd want to take pictures of the fish front on, side on, the other side, and the back, top, bottom. So your model has a chance to be able to see different angles for that particular object. Because if it doesn't, it's going to be really hard for it to know that that particular object is what it is. Another best practice is to start off with 10 to 20 pictures of each class. Now, I'm going to start off with way less than that because I'm going to show you what to do if you get sucky performance and how to add additional pictures, how to retrain. So we're going to start off with less. I think we're going to do 5 initially. Then we're going to rebuild and then redo this model. So ideally, we should get better performance later on. And we'll also do it with the green screen and without the green screen. So again, going to give it a chance to better generalize. So if we've got a green screen in the background, as I do right here, which you probably can't see right now because I've got chroma key on. But if I had the green screen up and I only give it images where I've got a green screen available, what would happen if I took the green screen down? Maybe it might not actually perform that well because it has never seen images of my hand without a green screen behind it. So ideally you want to give your image or you want to give your model the best chance possible to actually go on ahead and detect objects. Okay, so on that note, let's go on ahead and start collecting images and labeling images. So in order to do this, we're going to be using one of the Jupyter notebooks that we cloned down, which is this one here. So imagecollection.ipynb. So this is step 5. So we're now up to here. All right. So remember we started off our Jupyter notebook. So again, I'll cancel this so you can see it. So let's clear it. So in order to do this, I'm just going to start our Jupyter notebook. So by typing JUPYTER notebook. So this is going to start up our Jupyter notebook server that we're able to use. So if we hit enter now, That is now started, and you can see inside of here, we've got a bunch of stuff. So we've got our virtual environment, so TFOD, we've got that image collection notebook, so one.image space collection.ipymb. We've got our training and detection notebook, which we'll talk about more later, our error guide, and our README. So we are going to start off with our image collection component. All right, so if we select that, that's going to open up our notebook. And then we're just going to step through this particular file. So what we're going to do is we're going to step through it. So I'm going to hold Shift and Enter on my keyboard. This is going to allow me to step through each one of these cells. So Shift, Enter, and this first line here is going to install OpenCV. So this is a new dependency that we've actually got available. Now, a key thing to note is that when you're running this, what I want you to check is either over here in the top left-hand corner, the name of your kernel that you're using is the same as your virtual environment. So if it's not the same, that means that you're not currently working inside of your virtual environment. So you're not leveraging that pre-isolated environment that you went and created. And all of the stuff that you're going to be installing is on your local machine inside of your baseline virtual environment. So that will mean that it's not as controlled as possible. Another way to check that is if you hit kernel, change kernel, just make sure you've got the right one selected. So in this case, just to be safe, so I can hit TFOD again. And in this case, I'm already inside of that. So now when I go and install pip install OpenCV, I'm 100% sure that I'm actually installing inside of my virtual environment. And again, you can tell this based on the install command, right? So here you can see that it's actually installing inside of this TFOD lib side packages library. So again, installing in the right place. Really, really critical. So if you're getting errors where you're installing a library and then you got to use it and you're like, it's not picking up, sometimes it can be that. So say, for example, you install it on your command line and you don't have your virtual environment activated. Well, then it's going to be installing not inside your virtual environment. So when you do use it inside your Jupyter notebook, it won't be picking it up. Key thing to note, make sure this little bit over here is your virtual environment so that you are 100% sure that you're actually using it. So again, we're going to step through. So this next cell, so this first up cell is, let's zoom in on that. So exclamation mark pip install OpenCV -Python. So this is installing OpenCV into your virtual environment. OpenCV just stands for Open Computer Vision. So it's a really, really popular computer vision library, really, really good for working with the images or video. In this case, we're going to use it to access our webcam and collect a bunch of images. Then the next cell is actually importing some dependencies. So you can see here that we're now importing OpenCV. So import CV2 actually imports OpenCV. Slightly different naming convention. This is pretty normal. We're then importing UUID. So this is now giving us our unique identifier. So this will allow us to name our images uniquely so we don't have overlaps. We're then importing OS, which gives us our operating system. This is really good when you're working with file paths. So I've used OS a lot in both of these notebooks, particularly to ensure that we have file paths that are compliant with both Linux, Mac, and Windows so that you can sort of step around those. And we're also importing time. So we're going to use this when we actually collect our images to take a 2-second break between each image that we collect. So this will give us time to move to our different angles. So remember, really, really important to have images at different angles to help our model generalize. Okay. Then we're going to define the different images to collect. So in this case, we're going to collect 4 different objects. So in this case, this is going to be a multi-class object detection model. So we're going to be able to detect thumbs up, thumbs down, thank you, which is a sign language pose, and then live long. So we're going to give it a bunch of different types of images or a bunch of different types of objects to detect. So in this case, what we've actually got here is an array. So which is labels equals square brackets, and then we've just got a bunch of different strings. So if you wanted to have different objects to detect or different types of objects, this is where you change those labels. So in this case here, we've got thumbs up, thumbs down, thank you, and live long. Now, again, you could change this to your heart's content. Just make sure that whatever the label is named here is, actually, it's not so important here. It's important later on. When you actually go to label, make sure that you pay attention to the case. In our projects, we're actually going to change this up. So rather than doing thumbs up, thumbs down, live long, say, for example, with our little LEDs, we'd be doing bent and not bent, for example. In this case, we're pretty happy, so we can run that cell. And if we actually take a look at our labels, this is just a list. So if we actually type in type, You can see it's just a standard list. There's nothing super fancy going on there. It's just a place that we can hold our different labels in this case. And we've also got this line here, number of images. So this just represents how many images we are going to collect per class. So we're going to collect 5 images of thumbs up, 5 images of thumbs down, 5 images of thank you, and 5 images of live long. Now remember what I said, during the best practices, ideally you want to have 10 to 20 of these images just when you're getting started, right? So I'll talk about this in performance tuning as well. When you want to scale this up and produce a model which is way, way better, you want to use way more images than that. But to prototype and to get up and running, 10 to 20 images is ideal. I'm doing 5 on purpose here because we're going to performance tune later on. Okay, then the next thing that we're going to be doing is setting up our folders. So right now we don't actually have anything created inside of our folder directory, right? So let's just add our navigation pane again. So if I go into our TensorFlow Object Detection repository, I don't have any folders here, but I'm actually going to set up a little folder directory that's actually going to serve us really, really well when it comes to training and doing all of our other stuff. So this particular line here is just setting up our images path. So what we're doing is we're now going to create a new path, which is going to be called TensorFlow. And then inside of that, we'll create a folder called Workspace, folder inside of that called Images, and a folder inside of that called Collected Images. Probably doesn't make sense right now. Let me show you. So if I hit Shift Enter, it's going to set up our images path. Right? So for Windows, you're going to get a double backslash. If you print this out, rather, you can see that what it's actually doing is just navigating to TensorFlow, Workspace, Images, Collected Images. If you wanted a different file path, you could change this, but just bear in mind that the rest of the tutorial is going to follow that file path. And then what we're going to do is create those file paths. So first up, what this line is doing is checking whether or not the path exists. Then it's checking what type of operating system is being used. So in this case, os.name actually checks what type of operating system is being used. So if I actually type that out, so os.name, because I'm on a Windows machine, it's going to read out NT. You'll see later on when I do this on a Colab instance, because that's a Linux machine, it's actually going to say POSIX. So this gives you the ability to to run on both of those operating systems. So in this case, NT is going to be Windows, POSIX is going to be Linux. Now, that's all good. What we're going to do is run this cell, and this is actually going to create this folder directory or this folder path. So if I hit Shift Enter, you can see that that's run successfully. Now, if we go back, you can see, let's just make this a list so it's easy to see. We've now gone and created a new folder called TensorFlow. So that's now available there. And if I step in, what you'll actually see is that it's actually creating the whole file path. So TensorFlow Workspace, should zoom in on this by default. It's going to create TensorFlow Workspace Images Collected Images. So TensorFlow Workspace Images Collected Images. Now, what it also does at the same time is it creates a new folder per class. So it'll create a new one for thumbs up, new one for thumbs down, new one for thank you, and a new one for live long. If you change this, add different objects, add different labels, then it's going to create those folders as well when you run this particular cell here. So if you don't have these folders created, make sure that you've got your labels defined correctly and make sure that you run this cell. It'll create those folders for you. Now, the next thing that we're actually going to do is actually capture our images. So this cell over here is actually going to do all of this for us. So it's going to loop through all of our labels. It's then going to connect to our webcam. Now, this line is really, really important here. So this line connects to our webcam or capture device. So right now we're just doing it using our webcam, right? But later on when we go to do object detection using our microscope, I'm actually going to need to change this device number to be able to detect that particular microscope. Now, what might happen is this number that you see here, so right now I've got 0 in there. If you're working on a different machine, which undoubtedly you will be, this number or this video capture device might vary, right? So on my Mac, so on my other Mac machine, the number that I need to pass through into here in order to be able to connect to my webcam is number 2. Now, if you get errors, which undoubtedly it might happen, so if I actually go back into our error guide, so if you get an error that looks like this, so value error, images must have 3 or 4 dimensions, more often than not, that is because your webcam, you haven't got that webcam number correct. So if you see a gray box pop up and you're not getting any images back, again, it could be that as well. So sometimes you might need to either change that number or restart your notebook to be able to connect to your specific webcam. Now, in this case, I believe video capture device 1 is correct, so we should be good to go. So what's going to happen here is we're going to first up print out which label that we're collecting images for. So it's going to print out collecting images for, and then the label that it's looping through, because remember, it's going to loop through our labels up here. It's then going to give us a break for 5 seconds to enable us to get into position. So it's going to sleep for 5 seconds. And this is where that sleep library down here is coming in handy. And then it's going to loop through the number of images that we want to collect. So remember, we're going to collect 5 images in this case. If we changed this number up here from 5 to 10 or 15 or whatever, it's going to change the number of images that we actually collect. So it'll then print out collecting image for a specific label. It'll then capture the frame using our webcam. And then what it's going to do, this is really important. So it's going to create a new image and it's going to place that inside of this particular folder path. So it's going to place it inside of images path, which is, let's actually print this out so you'll see it. It's not going to work if I don't have an image. So it's going to put it inside, I'll change that now. It's going to paste it inside of images path. And then label. So in this case, say for example, we are up to thumbs up. It'd put it inside of thumbs up, which is over here. And then it'll name the actual file label dot and then a random number. So it's going to create this unique identifier .jpg. So all of our files will be JPEG. They'll be named the specific label plus the unique identifier, and they'll all be inside of their respective label folders. So we're going to need to move these around a little bit later, but that's fine for now. Then it's going to use the cv2.imwrite command to be able to write that down into file, and it'll actually show it to a screen. It'll then take a 2-second break again. And if at any point we need to escape out of it, we can hit the Q key on our keyboard to be able to get out of that. It'll then close everything down. If I zoom out of that now, let's go on ahead and run this. Are we zoomed in? No, we're not zoomed in. All right, cool. So if we run this, ideally what you should see is a little pop-up at the bottom of your screen, which indicates that it's now connected to OpenCV and it's actually rendering. So remember, you've got 5 seconds to get into position. So in this case, the path that we're going to go down is thumbs up, thumbs down, thank you, and then live long. So again, I'm going to make sure, so we might do this once, see where our webcam's position, and we might need to fix that up. So I'm just looking at where mine is now. Should be okay. Let's give it a crack. All right. So I'm just going to run that cell. Again, Shift Enter. Should see a little pop-up down the bottom. Looks like it's okay for now. You can see that's popped up now. And again, first position is going to be thumbs up. It's very dark. Let's get back into the center. Not the best images of thumbs up. We'll try it anyway and see what it looks like. Thumbs down. And the next one should be thank you, I believe. I'm going to switch to this position. So again, you get a little bit of a break between each of these images. So you've got time to move around, right? If you want to increase the break, you can just change that number. And again, I'm trying to get into slightly different positions each time. And then the last one, it should be live long. So all right, that looks good. Remember, right now we've only got our green screen images as well. So we might choose to drop the green screen and create new detections later on. If we get really, really poor performance, we'll test this out. Again, this is meant to be a live example, so you can see what some of the challenges that you might face and how to solve those. Alrighty, cool. So it looks like we've now got a bunch of images. So again, if we go into TensorFlow, Workspace Images, Collected Images, you can see that we've now got a bunch of images. So our live long positions, looking fine. And the way that I'm sort of judging these, the only thing I'm a little bit concerned about with these images is that right now they're all in the same format. So let's just enable preview. How do we do this again? Preview pane, yeah. So right now they're all sort of in the same position, right? So this is not good practice when it comes to building a generalized model. So what we might choose to do later on is move into different positions and ideally drop the green screen, add more images, train this up again. So in this case, that's our baseline, right? So, and again, when you're prototyping, a key thing in any data science project, I preach this all the time, prototype as fast as possible, because then you're going to work out whether or not what you're trying to do is feasible and whether or not it's possible. So say, for example, you're trying to detect, I don't know, say, for example, you were trying to detect bent LEDs and you're just doing it with a webcam. Well, you're going to need a really, really hyper accurate model, or one that's able to see really, really fine grained detail to be able to do this. So if you were to prototype really, really quickly with a mobile net model and just a webcam, you might see that you get absolutely sucky performance. Now, if you do this fast, at least you get to the end output to realize that, hey, maybe we need to try a different technique. Maybe we need a different sensor, aka a microscope. By doing this quickly and prototyping quickly, you're able to see and establish a baseline from which you can go on then and try to improve performance. In this case, we're going to give it a crack and see what it looks like. So we've got our live long images. Let's check thank you. These ones look a little bit better. Again, obstructed by the microphone a little bit. We'll see how that performs. It's looking good. Thumbs down. That looks all right. Again, so you can see that, right? So I'm giving my model a better chance to generalize by having a thumb position there and a thumb position there. That's looking better. And again, a few different ones, again, reasonably close together. Now, another idea here, right, is to do it with different hands. So in this case, I've just done it with this hand, but I could have chosen to do it with this hand, right? Going to give me a better chance to generalize that way. And thumbs up, that image is crap. So we're actually going to get rid. So this is another thing to note, right? So that sometimes you might need to delete images. So in this case, this one's really dark and it doesn't even contain an image of a thumbs up. So if you don't have the object included within that particular image, it's not going to be used for training as part of the Tensorflow Object Detection API. So we can actually just delete this image and delete this one because it kind of sucks. And I've got a feeling that after we train this model, our thumbs up detection is not going to be good. But let's give it a crack and see what it looks like. We can always performance tune later on. So keep in mind, our thumb is really, really close to the edge. This one, it's half cut off. This one, it's in front of our face. So again, we don't have a good run of example images there. So if we wanted to, we could actually just add more images in now, right? So rather than collecting images all the way again for all of these labels, what I'll do is I'll just delete or we'll add in a new array because I've got a feeling that those thumb images really aren't that good. And we'll just call it thumbs, what was it, up? I think it was thumbs up. So now if we take a look at our labels, so now we should be able to collect more images for thumbs up. So let's go on ahead. So I've just gone and added in a new variable. So if we wanted to go back to our normal labels, we could do that as well. Now, again, this is pretty common. So you might need to add or capture additional images or capture less images. In this case, I'm just going to capture a couple more images of thumbs up because we've only got 3 and all 3 of them kind of suck. So, and right, so like they're only like half detection. So this one barely even counts. You can only just see your thumb there. So ideally, we want to get a number of good images. So let's do this now. So what I'm going to do is I'm going to run this cell again and see how we go. So if I run that, ideally, so we're going to be trying to collect thumbs up. You should see a little pop-up again. All right, we've got our frame. It's looking better. All right, that looks a little bit better now. So if again, we go back into our folder, Tensorflow, workspace images, collected images, and thumbs up. So now we've got way more, right? So if we take a look at our latest ones, again, we've got a bunch of different eyes are closed there, great. So again, got a bunch of different images. We're giving it a better chance to generalize. And now we've got images for both hands as well, right? All right, so let's do that and see how we go. All right. So we've now gone through installing and importing our dependencies for image collection, defining the labels that we want to collect, as well as how to collect additional images for a particular class. And we've also gone and set up our folders and captured our images. Now, again, keep in mind, when you are doing this bit, you might need to change this number depending on your webcam capture device number. So it's fine to change it. If you have to change it, by all means do. Make sure that it works for you. Sometimes I try 0, 1, 2, 3. Some devices have virtual video capture devices. So you need to take those into account as well. Just again, you might need to try 5, 6, 7, 8, 9. Just make sure that you try a bunch of them. Ideally, you should see that pop-up appear exactly as I showed. Now we're going to get to our labeling. So as I was saying, we're going to be using LabelImg for this. So this particular package here. Now, if you want to take a look at this package, you can go to github.com/ I don't know how to pronounce that. TZUTALIN, Zootalin. Sorry if I butchered that name. Massive respect to you. It's an awesome package. All right. So we're going to be using LabelImg to be able to go and label our images. Now, when I talk about labeling, really we're just drawing boxes around the stuff that we're trying to detect. Now, also, another thing to keep in mind is you can label multiple objects in one image as well. So another thing to keep up your hand. Now, down the bottom here, there's a whole bunch of installation steps that you can actually go through. Now, what I've actually done is I've actually included this within the Jupyter Notebook. So rather than having to step out, install, do all of that stuff, we can actually just install it using our notebook. So first up, what we're going to install is PyQt5 and LXML. So if we run that, now remember we're inside of our virtual environment. So if we actually take a look at what we've got in here now, pip list. Now let's actually run this cell first. Cool, so that's now installed. And if we run pip list, you can see that we now have a whole bunch of other stuff installed. And if we look at the two libraries or dependencies that we just wanted to install, so PyQt5 and LXML, we now have LXML, which is there, and PyQt5, as well as all of its other dependencies. So we're good there. Right. Now, the next thing that we want to do is create a little home for our LabelImg file or LabelImg package to be saved. So what we're actually going to do is create a new folder called Tensorflow and then LabelImg. So it'll be inside of our Tensorflow folder and then a new folder called LabelImg. So it's effectively going to be, let's keep this open. I don't know why I keep closing that. So TFOD course, Tensorflow. So we're going to create a new directory here called LabelImg, and that's going to be where it gets stored. So if I run this cell, let's minimize this. And then if we now go on ahead and create this, what we're effectively going to be doing is first up creating a new directory using makedir or that makedir command there. So first up, we're actually going to check whether or not that file path exists. So if it does already exist, as in is installed, then it's not going to do anything. So if you get any errors, what you might want to do is actually just delete the LabelImg folder and run this cell again. Now in this case, we haven't run it, so we can run that. So it'll create a new directory called LabelImg, which you can see there. And then it's actually going to go on ahead and clone this thing that I was actually showing you. So this GitHub repository, it's going to clone that. So whenever I'm running these commands through a Jupyter Notebook, it tends to be not a little bit slow, but you don't actually see the progress. So right now it is running. So we've got our little star over there, so you can see it. So it is running. You're just not going to see it if you're running on a Windows machine, but it is cloning. So if we open that, doesn't look like there's anything there yet. Let's wait for that to clone. All right, so that is our LabelImg package now cloned. So if we actually open that up, you can see that we've now got that cloned into that folder. So we've got TFOD, Tensorflow, LabelImg, and inside of that, we've got effectively all of this stuff cloned into our local repository. Now, the next thing that we need to do is actually go on ahead and install LabelImg. So I believe that might be a typo there. So let's just copy that over here. Okay, and then what we're going to be doing, so again, we're running on a Windows machine, so we're going to be executing this path down here. So we're going to cd into that LabelImg folder. So if I actually show you that, LabelImg. So again, we're going to be going into this folder, so Tensorflow, LabelImg. Then we're going to be running this command here. So pyrcc5-o libs/resources.py resources.qrc. This is effectively the installation steps that are recommended from the main package. So if I actually go down here, so for Windows, we're going to be doing this. So pyrcc5-0 libs/resources.py resources.qrc, and then we'll open it up. So effectively, we're just running through the same installation steps that you would get from the actual repository itself. So if I go on ahead and run this now, should ideally run successfully. So it doesn't look like we've got any errors there. And then if we go on ahead and run this command, what should actually happen now is that it'll actually open up the LabelImg package. So the actual application will actually open up. So if I actually hit Shift Enter, you can see LabelImg is opening up. So we've now gone and installed it from scratch and actually opened up the LabelImg package. Now the fun bit comes, actually going on ahead and labeling our images. So what I'm going to do is I'm going to, over this left-hand side here, you can see that this button called Open Dir. I'm going to wave my cursor around it so you can see it. So I'm going to hit Open Directory or Open Dir, and then I'm going to navigate to my folder. So I'm going to go to YouTube, Tensorflow Object Detection, Tensorflow Object Detection course, TensorFlow, Workspace, Images, Collected Images. And remember, we've got a repository or a folder for each one of our different classes. So in this case here, what I'm going to do is step into Live Long first, hit Select Folder. And sometimes it won't actually open that folder. It'll just ask you to select that folder again. What you need to do is just hit Cancel. But as long as you've got the files down here, it means that you're able to label them. So I'm going to start out by labeling my first image. So if I double click onto that, that opens up our image. Now, just a couple of quick tips. So what you can do in order to label this image, so there's a shortcut, right? So all you need to do is hit W, and this is going to open up our little labeling thing over here. So you can see we've got our cursor. To label an image, what you then want to do is just select the first point that you want to label and then drag down and create the object. Now, what I tend to do is I tend to find the outermost points. So in this case, I'm going right to the top of my finger and right to the edge of my hand. Then what I'll do is I'll drag it so that I only encapsulate the components of my hand that I want. So you can see I'm going just to the edge of my, pointer finger and to the edge of my wrist. So I'm going to be as tight as possible with my detection or my label. And then, so remember when I kept on harping on about make sure that your label detections are tight. So that's what I meant by tight. And then make sure that you pay attention to what you actually name these labels. Because when we go to train, you're going to need to make sure that the names of the labels in your annotations, which is what we're doing right now, match the actual labels that you pass through to your model that you're training. So in this case, I'm going to label it live long, and I'm going to have a capital L and a capital L for live and a capital L for long. Now, when I go to set up my labels later on in my training step, I'm going to make sure I've got the exact same thing. If you don't, you're going to get an error, right? And that error is going to look like this. So in this case here, you can see it's when running generate TF record script, blah, 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 blah. And then you're going to get this key error here. But I'm actually going to show you what that looks like when we go to do it. So in this case, keep in mind, I've labeled it capital live, capital long. If I go and screw up when I go to train, it's fine. You can fix it. It's not hard. But you are going to get an error. So in this case, pay a lot of attention to the capitalization and the case of your labels. So I'm going to label it live long, hit OK, and then hit Control S to save it and save. That's my first image labeled. So we're going to go through and do the rest. So I can select my next image. And again, we're going to keep them tight. So I can do that. And say I screw up, right? And do that. I can still go in, drag this back and tighten up my detection. So I can do that, make it a bit tighter. And you can see that there's this little bit of my image over here that I haven't actually captured. So if I zoom in, you can see over there that I'm not capturing that. So we might pull that in. Now, maybe I'm being a little bit pedantic now, but that is my OCD kicking in. And it is best practice, right? So you want to make sure that you get this as accurate as possible. So we're going to save this. That's annotation 2 done. Now we're going to go to our next image and again, do the same thing. So we're just going to do this for all of our images. Now, the beauty of what we're doing right now, right, is that we could do this for whatever type of object that we wanted to save. So say, for example, we wanted to do, I saw a really, really cool video the other day of someone that used this to classify which way waves were breaking. I thought that was pretty awesome. You could do it for a whole range of different applications. So obviously we did sign language. That was a great use case. Super practical and super altruistic. And there's like a whole heap of capabilities. Like there's people out there that need this technology. So if you've got the capability to do it and you're watching this course, by all means, find something interesting and give it a crack. So I'm obviously going to give you some examples when we actually go to do our projects. But again, if you come up with a good idea, this exact same process that we're going through. Define your labels, collect your images, label them, and then we'll get through to the training later on. But you sort of get the idea. That's what we're going through. Okay, so we've now gone and labeled these images. Now, one thing that I want you to check as you're doing this is if you go into the images folder, and in this case, we've done live long, right? That you do have these annotations available, right? So in this case, I'm looking at this image here. I should have a matching annotation, and it's going to have the exact same name as your image file, but rather the extension is going to be XML. So if I actually take a look, let's go details. So in this case, I've got the image. Do we need date? We don't need date. So I've got my image over here, which is named whatever that is, .jpeg file, and then I've got the annotation which matches that image. Now, if I open up this annotation, let's take a look at what's actually included in here. So inside of my annotation, I've got obviously the fact that it's an XML file. So it starts off with annotation, then tells me what folder I'm in, what my file name is, the path to that file name. Now, this doesn't matter so much when it actually comes to training because we're going to move these around. The source, and again, the database doesn't matter here. The size is quite important because this defines how big our image is. So in this case, we've got width, height. Let's make this a bit bigger. You can see a bit better. We've got width, height, and depth. So in this case, it's a color image. So it's going to have R, G, and B. Whether or not it's segmented. So we're not segmenting at the moment. And then this is the bit that's really important. So you might have multiple objects in an image, in which case this will be repeated multiple times. So here we've got the name of our object. And again, we've got it capital live, capital long. So if you screw up and you wanted the names to be different, you could just come in and change these names as well. We've got pose, we're not using that. Truncated and difficult, we're not using that. And then we've got the bounding box. So again, we've got the different coordinates. So we've got the minimum X value and the minimum Y value. So effectively, we're just giving it 2 points. And we're giving it a point here and a point here. And the square that represents that box is going to be our bounding box. So that's really what it comes down to when it comes to labeling. So we're effectively creating these XML files. Okay, but right now we've only done our one class. So if we just wanted to detect live long, that's perfectly fine. You can go on ahead and jump off to training. If you only had one object to do, you could do that. In this case, keep in mind we had live long, we had thank you. So if we go and do that now, so I'm going to step into that folder and then hit select folder. Sometimes you got to hit cancel and then open up our image. So again, we're going to do the same thing. Now again, I'm a little concerned that we've got the mark there, but that's fine. Let's give it a crack. So in this case, I'm going to label to my knuckles and again to my wrist. So this one is going to be called thank you. Oh, almost had a typo there. Dangerous. So capital T and capital Y, hit OK. Then again, Control S to save. Then we'll go to our next one. So again, different angle. So this should ideally give us a better chance at generalizing. I'm going to save that. Save. Go to our next image. And again, mic there. We'll see what that does. Again, I'm just going to keep going through. So we're going to do the next one. Save. Next one. And again, looks like I've only got 2 angles there, sort of up and down. So one idea there, and I've screwed up my detection. So I'm just going to hit OK, and then I'm going to tighten that up. Save. Cool. So we can double check just by clicking through all of them. In this case, I can see all of my detections are saved and they're good. If you forget to save, what will happen? Actually, I'll show you in the next one. So in this case, we should be fine. So if we go and check our images again. And thank you. So again, remember, we've got all of our images and we've got their associated annotation files. So ideally, we should have a round number. So it should be even. So we've got 5 images and we've got 5 annotations. So we're good there. Cool. Alrighty. Now we're going to open up our next class. I want to show you what happens if we forget to save. So let's do thumbs down now. So double click. Right. So I'm going to label thumbs down, hit OK. If I then go and double click into my next one, when I come back to that image, my annotation isn't going to be saved. So you got to keep in mind that you need to save it, right? So you won't actually have that file created. So again, I'm going to just do thumbs down, change my label name. So it's going to be thumbs down, save. Now, if I step into my next image and come back, I'm going to have that annotation saved. So we'll do our next one. So sometimes you might notice you forget one. If you're doing a ton of these, again, you might, sometimes it happens, you forget to save. Now, some people have asked about how would we scale this up. So say we've got thousands of images. There's normally two ways that I recommend here. So you can either outsource this. Mechanical Turk is one way to go. Or if you go to like Upwork or Freelancer, that's another way. The other way is that there are newer tools these days that actually use a technique called auto labeling. So they'll actually train a lightweight object detection model to be able to detect the different objects within the images. So it's pretty cool, right? And then what it'll do, it'll ask you to label, say, for example, 10 or 20 or 15 images. And then you can run that auto labeling and it'll go and auto label all of the other images based on the lightweight model it's already trained. Now, again, those are pretty sophisticated, but if you'd like to see a video on that, by all means, do let me know. I'll see if I can spin something up. In this case, we're just going to use LabelImg. So again, you can see all of our images looking fine there. No issues. Okay, let's do our next directory now. So we've done thumbs down. Now we want to do thumbs up. And this was the one that we remember we had a lot of images for. So we went and collected more. So we are now doing thumbs down. I can't remember if I labeled that correctly now. So the other one we did label thumbs down, right? So if we open up our annotation, yep, thumbs down. Okay, so we're good. And thumbs down with capitals. Perfect. All right. So now we're going to do thumbs up. So let's label it. Again, same thing. Hit W to get that shortcut and open it up. This is going to be thumbs up. Save. Next image. This is a partial, so that's fine. Let's do it anyway. Again, just going to keep going through. So again, this can get a little tedious when you got a ton of images, but just sort of walk through. Normally I'll grab a coffee and I'll just grind through and label these objects. And again, prototype. So don't start out by labeling thousands of images because it might not be the right technique. So what I'd always recommend is do 10, 20, 5 if you really want to keep it super fast. Prototype, train, and then evaluate, right? So don't commit to building a huge object detection model before, don't commit to building the whole thing with thousands of images because you want to make sure that you're going down the right technique, you're getting the right levels of data, you're using the right types of sensors to be able to do this. So prototype first, going to make you a lot more efficient. Going to keep doing our thumbs up. And again, I'm going to adjust our label this time because I screwed up. So that looks a bit better. Save. And then we're going to do that. Thumbs up, save. And you can see, so I did that. Thumbs up might perform a little bit better now because we've now got images at a bunch of different angles. Tighten that one up and save it again. But keep in mind, we've only got a green screen in the background at the moment, so it'll be interesting to see what performance looks like. And if it sucks, we'll make it better. Okay, cool. Let's double check our annotations as per usual. So we're good, 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 good. All right, cool. So that looks all good. So we've now labeled all of our images. And if we check that, let's bring that back. So thumbs down now has all of our annotations. So if we go into live long, we're good there. Thank you. We are good there. Thumbs down, we're good there. Thumbs up, we're good there as well. Okay, cool. So we've now gone and completed all of our labeling. Now the next thing which you really need to do is we're now going to split this up into a training and testing partition. So when we get to our training step, we're going to train our images or train our model on a portion of images, and then we're going to separate part of it out, or we're going to use the other part of our images to actually test how it is. So the reason that we split this up is we want to train it on a segment of images that we're going to use for training, and then we want to test it on a set of images that it's never seen before. Look, the images might be similar, but we want to give it a chance to try it out and see what performance looks like on images that it hasn't explicitly seen before. So to do that, so you can see we've got step 6 here. So we've now done, let's quickly recap. So we've imported our dependencies, we've defined our images to collect, we've set up our folders, we've captured our images, and we've labeled. So we've done quite a fair bit. Now what we need to do is move them into a training and testing partition, which is step 6. So what I'm going to do is I'm going to go back into that folder. So inside of our images folder, so I'm going to hold there. And I'm going to create 2 new folders now. So I'm going to call one called train. and I'm going to call one called test. Now, the names of these folders is really important because inside of the training script, it's actually going to be looking for these training and testing folders, or the test and train folder explicitly. So you need to make sure that you create these folders, and you need to make sure that you have images and the associated annotation in it. So what I'm going to do now is I'm going to take a random portion of our images from each class. So we're going to take some from livelong, some from thank you, some from thumbs down, some from thumbs up, and we're going to put it into that training folder. So these are going to be the images that we use to train our object detection model. So if I step into livelong, I'm going to get everything, including the annotation. So maybe we'll leave one image for testing. So we're going to have effectively 1, 2, 3, 4 images and 1, 2, 3, 4 annotations. So I'm going to cut that, paste it into the training folder. And I'm going to do this for each class. So we're going to go into thank you. So 1, 2, 3, 4, 5, 6, 7, 8. So again, 4 images, 4 annotations. Again, paste it into the training folder. Now we're going to do it for thumbs down. And again, 1, 2, 3, 4, 5, 6, 7, 8. Got to grab that one. Going to go back in. And the reason why I'm being so explicit in making sure that we grab the annotation and the image is if you skip out and you don't have the annotation, or if you skip out and you don't have the image, it's going to screw up when you go to do the training step. So you need to make sure that you grab both the image and both the annotation. Really, really important. And we're going to do the last class. So I'm going to grab, let's leave 2 images for testing there. So I'm going to grab 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So we'll leave 2 images and 2 annotations for thumbs up, because remember, we add more images there. All right. And then we're going to paste those into our training folder. So now we should have an even number. So we've got 36, a little bit small down there, but we've got 36 images. So we've got the images and the annotation. So we're good for our training. Now we need to do the same thing for our testing. So we're just going to grab the rest, paste it into our test. Thank you. And again, you could automate this. You could write a little bit of Python script to randomly select your folders. If you do get around to it, let me know. I'd love to see the code. Paste it into test, but I found that just doing it manually isn't too bad, particularly if you only got a small segment of images. And we're going to grab our thumbs down, thumbs up, and then paste that into test, right? So ideally what you should end up with is an even number of images, both inside of your test folder and inside of your train folder. So if we take a look at our full file path, inside of our TFOD course folder, we should have TensorFlow, Workspace, Images, Test, and Test has images and annotations, and Train. And again, Train has images and annotations. So these images and annotations are going to be used to actually train our model. We're going to do this technique, or use a technique which converts these images and annotations to something called a TensorFlow record. And again, I've got scripts to help you do that. So we're going to convert those and then use those TensorFlow records to be able to actually train our model. Now, if we go back into our images folder, we can also just delete these folders as well now, because we don't need these. There's nothing in them. So inside of collected images, we can actually just delete that now. So again, all of our images and annotations are inside of test and train. So we're good to go. Now, inside of that image collection notebook, I've also got the code to compress these images to be able to push them up into Colab. But again, we're going to do that when we get to our Colab training. So again, hold on for that for now. You don't need to run these last 2 cells, which is everything under step 7, which says optional. Cool. All right. So that's image collection and labeling done. So we've gone and collected our images, captured our images, labeled them using LabelImg, and we've now gone and split them up into our training and testing partitions. So again, remember, last step was really, really important. You need to have a training and a testing folder, because this is what our training script is going to be looking for. So we've also adhered to some of those best practices. So we were case sensitive. We made sure we got our cases right. We kept our labels tight. And right now we've only done 5 images of each class except for thumbs up. So again, we might choose to add more later on. So we're good there. This brings us to step 3, training our models. So in part 3, we're actually going to start training our models. So we're specifically going to be using a model called a mobile net, which is a specific deep learning architecture, but you could use a bunch of different types of models, and we might actually do that in the performance tuning section as well. So when it comes to training a model using Tensorflow Object Detection, so there's a bunch of steps that you need to go through and a bunch of dependencies that you're going to be needing. Now, namely, because we are using TensorFlow Object Detection, one of the core dependencies is going to be TensorFlow. So we're actually going to go through, install all of our dependencies, set up our folder structures, and actually start training this model. Now, as part of this, we're also going to be evaluating our model. Now, I might come back to this a little bit later, but I wanted to talk about how to evaluate your models. Now, the nice thing about TensorFlow Object Detection is that you're able to calculate these evaluation metrics after you've actually gone and trained your model. Now, specifically, when you run your evaluation, you're going to get two key things. So you'll get precision, and normally you'll get a metric called MAP, which stands for mean average precision. And this basically tries to calculate what proportion of your detections were correct, right? So what it's actually doing is it's calculating the true positive, so how it's actually calculated is it's the number of true positive detections divided by the true positives and false positives. So effectively, it's the number of detections that it got right. So in this case here, you can see I've got this little matrix. So this is a true positive detection. So you can see this is the sign for hello, right? And it's accurately detected the sign hello. So it's a true positive. Now, on the other case, you might have a false positive. So it's gone and detected a label here which says hello, but that's not actually correct because it doesn't actually have that label there, or it doesn't actually have that object there. So even though it's gone and made a positive detection, it's a false positive because it's not actually correct. You've also got a true negative, which in this case, there's no object, so there's no hello in there. So say, for example, this is just a hello model. So there's no actual hello object in there. In that case, it's actually a true negative. Now, in this case, we've got a false negative. So there is a hello object in there, but it hasn't detected that as hello. So it's falsely rejected it, right? So what you're actually going to get when you calculate your evaluation metrics are precision and recall, which are calculated off the number of true positive, false positive, true negative, and false negative detections. So in this case, your precision metric is going to be true positive, which are the number of detections that have accurately detected the correct object, divided by the number of true positives and the false positives. So effectively, what that's giving you in layman's terms is what proportion of my detections were actually correct, right? So this is correct, this is bad. So ideally, you want this precision number to be as high as possible. A higher precision number is a better precision number. Likewise, a higher recall number is also a better number. So your recall is calculated as the number of true positives divided by the true positives and the false negatives, right? So this is basically capturing what proportion of my actual objects did I capture. So in this case, you can see that we might have captured this, but we didn't capture this. So really, it's trying to measure, hey, for the objects that were in the screen, what proportion of those did we actually get? So when we calculate our evaluation metrics later on, you'll actually be able to see these. You'll also see loss talked about a little bit. So it's a method of evaluating how well the model is performing against the data provided. So ideally, you want loss to be as low as possible, recall to be as high as possible, and precision to be as high as possible. But again, we'll talk about this when we get to that step. All right, so TensorFlow Model Zoo. So there's a whole heap of different types of model that you can actually go on ahead and train, right? Now, what you normally have to do is balance a trade-off. So you'll balance faster detection, so ideally being able to detect stuff really, really quickly versus lower accuracy. So the ones that tend to be faster tend to be less accurate, not all the time, but most of the time. The ones that are highly accurate tend to be slower, right? So if you have more sophisticated models, bigger architectures, it's going to take slower to actually make that detection. So if I actually show you, right? So if you actually go to Google and type in TensorFlow Model Zoo, and make sure you type in TF2, which stands for TensorFlow 2, there's a heap of different types of models, right? So these models are just different model names and different model architectures. So if I zoom in here, you'll see that we've got a model called CenterNet. We've got another model called Efficient DET. We've got an SSE MobileNet, which stands for Single Shot Detector MobileNet, Single Shot Detector ResNet. So each of these just represent different neural network architectures which are used for object detection. Now, you don't need to go into great amounts of detail as to how these are actually built up. What you do need to know as a practitioner, however, is that using different models is going to result in different levels of accuracy as well as different levels of speed. So say, for example, I wanted to use, so let's actually take a look at the model that we're going to be using. So we're actually using this one here. So SSD MobileNet V2 FPM Lite 320 by 320. So this is the model that we're actually going to be using. And if you actually take a look at that link there, so if I copy this link address, let's actually open up the notebook. Actually, we'll come back to that. So the link for this is actually going to be the link that we're actually using in our notebook. And I'll show you that in a sec. Now, this model has let's take a look here. So we've got two components. So we've got speed and we've got our mean average precision. Remember, we talked about precision here. In this case, we've got the average precision, which is represented over here on the COCO dataset. So this is just a standard dataset. So just think of these two columns as how fast the model is and how accurate the model is likely to be. So in this case, we've got a bit of a balanced model, right? So our SSD mobile net is going to run each frame in 22 milliseconds. So ideally, you want this number to be the lower, the better. And it's going to have a mean average precision of 22.2. So again, it's reasonably balanced. Now, remember when I said, so you're going to have a bit of a trade-off here. So in this case, and certain architectures can be fast and can be highly accurate as well. So just keep that in mind as well. So you might get a model that's really, really quick, but also really, really accurate. So we could use this one here, but say, for example, we wanted to get a model which is more accurate later on. Well, we might choose to go to this one. So SSD Mobile Net V2 FPNLite 640 by 640. So it is going to be slower. So it's going to take 39 milliseconds per frame. But you can see here that our mean average precision is 28.2. So again, there's a trade-off. So you might choose to use I guess you can sort of make a decision here. So if you need a model that's going to be deployed on a phone or on a Raspberry Pi, you ideally want to optimize for speed, right? Because a Raspberry Pi isn't going, without any acceleration, isn't going to be that isn't going to be able to perform that fast anyway. So you want to choose a model which is already really, really lightweight and it's going to be able to run. So in this case, this is why I tend to use this model a lot, unless I have a specific use case where I need a really, really accurate model. Now, again, a core difference between this model and this model is that this model is actually going to compress our image from 640 by 480, which we had from our webcam, to 320 by 320 when we actually pass it through. You don't actually need to do anything as part of this. It's actually going to use a technique called pre-processing to compress that down to 320 by 320. And then in post-processing, it's going to take the detections that it found and convert it back to your original resolution. So it'll actually do that for you. And this is one of the advantages of the Tensorflow Object Detection model, or API. You don't have to do that pre-processing and post-processing, which can be a pain sometimes. Another cool thing about it is it does a technique, or it uses a bunch of techniques called image augmentation. So it might darken your image, it might shift it, it might flip it, and it will do the same for the detection. So it does all of that for you. Certain models will have different levels of data augmentation or image augmentation, but just keep in mind the reason that you do those is to ideally get a better performing model. So ideally a more accurate model. Now, again, you can use a bunch of different types of models. There's one really, really slow one down here, which again runs in 301 milliseconds. But the reason that this particular model takes a lot longer is because this actually gives you a bunch of additional stuff as well. So this actually uses a mask, which in this case, this course covers object detection. The mask model, which you can see down here, actually does something called image segmentation as well. So rather than just detecting a box around my face, it can actually trace around my face and detect the specific shape of my face, not just a box. Now, again, because it is a lot more sophisticated, it's going to take a lot longer to run. So in this case, 301 milliseconds. So again, you've got a bit of a trade-off here as to which model you choose to use. Now, we're going to be using this one over here. So SSD, Mobile Net, V2, FPNLite, 320 by 320. But again, in performance tuning, we might choose to use a different model and see what that looks like. So that is Tensorflow Model Zoo. So whenever somebody asks you about Tensorflow Model Zoo, this is normally what they're talking about. Okay, so that is that. Now, sometimes you might not want to train locally on your machine. You rather use a cloud instance. So say, for example, you're not at home, you can't access your desktop. You might want to train something on Colab. Well, you can do that. But a key thing to note is that when you train on a cloud instance, sometimes it can be difficult to connect to different devices. So say, for example, you wanted to connect to your microscope or connect to your webcam. Sometimes that can be a little bit tricky. So that's just one thing to keep in mind. But again, we'll cover that a little bit later on when we get to that cloud section. So on that note, it's time to kick off our training. So again, we're going to jump back into our Jupyter notebook, which we had over here. And before we were operating inside of our image collection notebook, but this time we are now going to open up our training and detection notebook. So there's a bunch of stuff that we're going to be going through this, but we're going to go step by step. So all up, there are 13 steps altogether in this notebook, but we are going to go for our training section at least. We are going to go up to step 7, so evaluate our model. So we're going to effectively go through all of these steps. So by the end of this, we should have a trained object detection model that we can then begin to use in our detection section. So again, we're just going to step into our first cell and we're going to run it. So in this case, we're importing operating system as well. And then we're actually going to set up our pre-trained model variables. So in this case, we're defining what we want our custom model folder to be. So again, when we go to our performance tuning model, we might change this. We're setting up the name of our pre-trained model. So this is going to be the name of the file that we download from our Tensorflow Model Zoo, which is over here. So when we actually download this, where is it? Let me find it again. So this particular file here. So when we actually download it from here, what you'll actually see is the file that we get back is called ssd_mobilenet_v2 fpnlite 320 by 320 Coco 17 TPU-8. So again, this is something that I've just sort of pre-configured. So again, if you wanted to customize this, you could as well. And then what I've also got in here is the pre-trained model URL. So I was saying before that we've got our model URL. Now where I got this from is if I right-click on this and copy this link address, what you'll actually see. So I'm going into a lot more detail in this than I normally do. And I sort of wanted to show you how I build these up. So this link that we've got here is the same, right? So you can see that that's the exact same link. So what we're effectively doing is we're going to be downloading that model from the Tensorflow Model Zoo and using it in here, right? So we've got the name of the file. So if we wanted to replace this, we just need to make sure that we get the name of the new file right. So in this case, we can see that it's going to be ssd_mobilenet_v2 fpnlite 320 by 320 Coco 17 TPU-8.tar.gz. So again, if we got a different one, we could change this pre-trained model name, or we'd need to change this pre-trained model name and this pre-trained model URL. But you don't need to stress about this for now. You can just leave it. It's going to work. And then we're setting up a few different variables. So we're setting up our generate TF record script, which we'll come to later, and our label map name, which again, we'll come to later. So I'm actually going to run through this cell, this cell, this cell, and this cell. And what you'll actually notice now is that we've actually got a couple of things. So this over here is going to create our different paths. So if I actually type in paths, so this just makes it a whole heap easier to work with all of the stuff that we've got available within our working directory. So we're able to refer to each one of these reasonably easily. So say, for example, we wanted to get where our model is going to be. We could just type in paths, checkpoint path, and you can see that we're now going to have that folder there. Now, let me explain each one of these paths. So our workspace is going to be our high-level workspace. So let's open this up. So our workspace is going to be this, and inside of our workspace, we're going to have our annotations, which is where we're going to create our TF record files. More on that later. Our images was already there from when we collected our images. We also have our models folder and our my SSD mobnet folder, which represents these two lines over. Let's find it. So we've got our models folder, which is this, and which is our model path, and we've also got our checkpoint path, which is this as well. So if you actually take a look at checkpoint path, or if we type in model path first up, that is this folder here. So TensorFlow Workspace Models, we type in checkpoint path, that is this folder here. But again, you don't need to mess around with this. I'm sort of just giving you a bit of an explainer as to what each one of these are. So each one of these represents a different file path that we've got available there. So if you want to dig into these a little bit more, you can. We've also got a couple of variables inside of this files dictionary here. So if we type in files, you can see that we've got a file for our pipeline config, which we don't have created yet, our TF record script, and our label map. But again, more on those later. This script down here is actually creating all of our directories. So you can see before that we didn't have all of these directories created, right? So our script actually went and did that. So if we actually now step into our TensorFlow folder, we should now have 5 folders. So our LabelImg folder, our models folder, our protoc folder, again, more on that later, our scripts folder, and our workspace folder. And if you step into your workspace folder, you're going to have a bunch more available in there as well. Okay, that is our folder structure now set up. Now, the next thing that we're going to go on ahead and do is actually download our TensorFlow models from our Tensorflow Model Zoo, and we're also going to install TensorFlow Object Detection. Now, this tends to be where a lot of people get stuck. So we're actually going to take this step by step, and I'm going to show you what to look for and how to validate that you've actually got this successfully installed. So again, we're going to step into our first cell, which is this one over here, and we're going to hit Shift Enter. And this is going to install a package called wget. So this is just going to allow us to actually pull down our model from Tensorflow Model Zoo. And then what we're going to do is actually clone down the Tensorflow Object Detection repository. So if I copy this link here, let me actually show you that. So this is the Tensorflow model garden. Now, inside of here, there is a bunch of stuff that is available for TensorFlow, but specifically we're interested in object detection. And when people refer to the Tensorflow Object Detection API, this specific section, which is in research and object detection, is what they're talking about. So everything that's in here is what represents the Tensorflow Object Detection API. Now, again, you can see that there's a bunch of stuff that is available through here. There's a whole bunch of documentation on this as well. There's also a bunch of open source tutorials that are out there. But again, I've tended to find this to be a little bit tricky to actually get through. So again, this is why we're building up this course and why we're going to be going through it in great detail. So what we're actually going to go on ahead and do in that next line of code that we're about to run is we're actually going to clone everything that you see here. And we're going to clone it into this folder. So we're going to clone it into TensorFlow, if we start off inside of our root directory, so TensorFlow Object Detection course, we're going to clone this model garden, which is everything you see here, into TensorFlow and then models. So then what we're actually going to do is we're going to install it from there. So if I run this cell here, it's going to do exactly that. Now this may take a little bit of time to run depending on the speed of your internet. So let's go on ahead and run that. Okay, so that is our TensorFlow model garden now cloned. So you can see in here that we've got a whole bunch of stuff. So we've got community, official, orbit, research, so on and so forth. That is just mimicking this. Now again, keep in mind there's a lot of stuff in here that you're not going to need for this, but we're just cloning down the entire repository. So specifically, we're going to need inside of the research folder, inside of object detection, this is us right here. This is all the stuff that we're going to need to leverage the TensorFlow Object Detection Model API or the Tensorflow Object Detection API. Now keep in mind, this is TensorFlow 2. So this is the latest version of TensorFlow, not TensorFlow 1. Cool. Alrighty. So what are we going to do now? So we are going to then go on ahead and install it. So right now we've just cloned it. So if we take a look, let's minimize this. We've just cloned it into this repository. So again, remember inside of research, inside of object detection, this is all of the stuff that we're going to leverage. Now what we actually need to do is actually run through the install step. Now again, there's a bunch of stuff required to actually go on ahead and install this. So if you do get stuck or if you do run into issues, by all means, check the model guide. But I'm actually going to step you through how I actually go on ahead and install this stuff. So the next cell is actually going to, again, detect whether or not we're using Linux or whether or not we're installing Windows. And it's going to do three things. So first up, it's going to install Protoc. So Protoc, so a lot of the TensorFlow object detection stuff uses something called protocol buffers. So if you actually type in Protoc, so what we're actually going to do is we're going to set this up for our TensorFlow Object Detection API. So again, you don't need to do anything but run that cell. It's going to do it for you. Now, normally this can be a little bit tedious. So again, it's just going to run this cell and do it for us locally. So if we run this now, it's going to install Protoc. And then this line over here is actually going to go on ahead and install the official TensorFlow Object Detection API. Then what we'll do is we'll actually verify our installation. So this script down here, so let's actually clear our output so we can see that. So this cell down here is actually going to run our verification script. So this will tell us whether or not we've actually got the TensorFlow Object Detection API installed successfully. If it is installed successfully, you'll see it read as okay. So that will mean that we've successfully installed the Object Detection API and we can kick things off. If not, I'm going to show you how to work through it and how to get it installed appropriately. Okay, so what we're going to do now is we are going to run this cell over here. So this is going to install Protoc, set it up, and it's going to install the Object Detection API. So let's run this. Now again, this is going to take a little while to run. And ideally, if you're running inside of a notebook or Windows, you might not get the status updates. But the way to check if it's currently running is if you go into, remember we're inside of our virtual environment here. So again, make sure that that's enabled and you're running it inside of that particular notebook, inside of that environment. So what we're going to do is actually so I'll show you that. So if we go into our TFOD file now and inside of lib, site packages, you'll actually see that it's installing packages. So right now it's up to 10:30 or 11:30. So you can see it's installing a whole bunch of different libraries. So what you should ideally see is that this is continuously installing stuff. Now, it may say that it's successfully completed, but ideally what you want to do is until you get an OK from that verification script, it hasn't successfully installed, right? So this is going to be your golden Bible. So let's run the verification script. So you can see here that it's saying that there's no module named TensorFlow. So what we're going to do is run this next line down here, which actually installs TensorFlow for us. So what I did is I included some of the lines that I used to solve these errors. So by running our verification script, this is again a standard TensorFlow Object Detection script that allows us to verify our installation. So in this case, it's telling us, hey, even though we've gone and run that script, it doesn't look like we've got TensorFlow installed. So this next line down here is you might not need to run it. It might say, okay, and I'll show you what it looks like when it's successful. It might work all perfectly. If it doesn't, then in this case, we're going to install TensorFlow. So let's do that. And ideally, you should start to see TensorFlow installing on the right-hand side. Cool, so that should be TensorFlow installed, even though, so right now, keep in mind, so sometimes you can run into errors with this. So even though we ran TensorFlow installed, it doesn't look like it's installed TensorFlow. So I can't actually see the TensorFlow file or library there. So Tensorboard, Tensorboard plugin, TF models official, TF slim. So if we go and run this again, it's still going to tell us no module installed or no module named TensorFlow. So run it again. And again, it should ideally install the second time around. Don't ask me why. It just seems like sometimes it throws up, doesn't seem to want to run. So now it's installing a bunch of additional packages. You can see TensorFlow there. So ideally, this is looking a little bit better this time. So let's wait and see. So again, that verification script is your golden Bible, right? So like if you get the OK sign, then you should be good to go. So in this case, it looks like it's still installing. It's completed over here. Let's run our verification script again. That's looking a lot better this time. So it didn't run really fast. So ideally, it'll take a little bit of time. All right, so we've now got an error called no module named matplotlib. So this one, it looks like, again, I've got the script to run that. Now, again, this no module found error is pretty common. So this just means that you need to install a package. Now, I've got this again inside of the error guide. So if you get no module named whatever, you just need to go in ahead and install it. Sometimes you need to uninstall it and then reinstall it. If you need to uninstall, it's just pip uninstall and then whatever library you need to uninstall and then -yes, and then you install whichever one you want. So in this case here, I'm going to run this next cell, which does matplotlib and protobuf for us. Okay, that's looking good. So you can see again inside of our virtual environment. This is the advantage of having the virtual environment. You can actually see visually what libraries are installed. So that looks like it's gone and done that. Let's go and run this verification script again. All right, so no module named PIL. So let's go on ahead and install this. So this one is one that I didn't have pre-configured, right? So we can do that. So pip install PIL. I believe PIL is pillow, right? So again, if you get these types of errors, you can just Google them. So no module named pill just means you need to install pillow. So more often than not, people are going to tell you to install pillow. So pip install pillow, right? So let's go on ahead and run that. Cool, that looks like it's installed. Let's run that now. Again, checking our verification script. What are we getting now? No module named YAML. So this looks like it might not have, let's check out, so let's run pip list now. So have we actually installed TensorFlow? Got 2.4.1, that's looking good. Okay. All right, so let's install YAML now. No module named YAML. So let's see how we install that. To install YAML, we need to run, I believe it's PyYAML. Yep, so it looks like, so Python pip install PyYAML. So let's do that. Okay, so that looks like it's installed. You can see PyYAML there. So let's again run our verification script. I can hear my GPU spinning up right now, so maybe that looks like a good sign. So this is looking good, even though it's in red. All right, beautiful. So we're good now. If you get to the point where you run this successfully and right down the bottom, even though it's in red, I know it doesn't look that great. it should say OK. So if it says OK, then that means you have successfully installed the TensorFlow Object Detection library, right? So basically, this means that it's going to go and run all of its verification tests to make sure that it's actually working. And if it's run successfully, you should get OK down the bottom. Let me zoom in on that, because if you get to that point, that's a huge win, right? Now, you saw how I was solving those errors. So if you got no module X, just go and install that module. If you got no module Y, go and install that module. Sometimes you need to uninstall stuff and reinstall stuff. But again, if you get stuck, hit me up in the comments below, join the Discord server. But ideally, that's going to be the same pattern, right? So if it says no module X, you just go and install module X. And because you're inside of your virtual environment, it's going to be installing in the correct place. Now remember, our virtual environment is up here, so we're using TFOD. Need to make sure you're in there. So what did we have to go and do to get ours to run? So we installed TensorFlow again, we installed Matplotlib and Protobuf, and we installed Pillow. So remember, we installed pip install Pillow, and we also installed PyYAML. Now again, this might be different depending on your particular environment. You might need to install more stuff, less stuff. It might just run perfectly fine. But I wanted to show you a real life installation, because this is me installing from scratch, and you can start to see what it actually takes to install it. Okay. So it's not all sunshine and rainbows. That's, I guess, the core thing that I wanted to point out. So I'm not just doing it in smoke and mirrors. You can see that you might run into stuff, but more often than not, it's just a pip install that you need to do. Now, if we run import object detection, you might still see that you get an error here where it says no module named object detection. What you can do to solve this is just restart your kernel. So first up, let's clear all of our output from this so it's a little bit clearer. If I run import object detection again, still saying no module. So what I normally do here is I'll restart my notebook. So if I hit, let me show you. So if we go up to kernel, restart, and then I'll say restart, you can see it said kernel ready. Then what I'll do is I'll go up to here, zoom out, re-import these. You don't need to do all of this again. So we just need to run wget. And then if we go down here, you can see that it's now installed successfully. So sometimes you just need to restart your kernel to be able to import it into your notebook. And in that case, that's our object detection API now installed and available and ready for use. So we went and installed a bunch of stuff there. So if we run pip list, you can see that we have a heap of additional libraries now installed. Now, remember when I sort of said that if you install TensorFlow and you want to use your GPU, you got to install some additional stuff. Well, in this case here, we've got TensorFlow 2.4.1. So this is the equivalent of 2.4, or like falls into the 2.4.0. There is TensorFlow 2.5.0 available at the moment. So you just need to make sure that you find the appropriate CUDA and cuDNN version for that. Now, to do that, what I normally do is I'll go into Google and I'll just search for CUDA. Well, let's take a look at what version we need first. So again, we go to tensorflow.org/install/source Windows, because I'm on a Windows machine. We could just as easily go back to the Linux and Mac OS page and do that. In this case, we're on Windows. So if I scroll down, because I'm using 2.4.0, I need to have cuDNN 8 and CUDA 11 installed. Now, in this case, I've already got it installed, but I want to show you where to get it from. So if we go to CUDA 11, if you just go to Google and type in CUDA 11, you can see that CUDA Toolkit 11.0 is available. So if I select that, and then I choose my operating system, so in this case, I'm on a Windows, you can choose version, what version of Windows I'm on. So I'm on Windows 10, not server. And then you can choose which type of installer you want. So you can either choose a network install or a local install, which downloads everything. So if we choose network install and then hit download, I've already got this downloaded, so we don't need to wait there. So once you've got it downloaded, you should get a file called this. So you'll get a file, let me make that a little bit bigger. So it's called CUDA_11.02, and then in my case, it's Windows. So if you actually double click that, it'll walk you through the package installation. And in this case, it's going to install into my CUDA folder here. So if I hit OK, and then basically what I do is I just click, and go through that CUDA installation. There's nothing too crazy there. Right, so you just hit next, no issues. So it's going to install CUDA into your machine. So rather than sitting through this, I'm actually going to show you the next step. So once you've gone through and installed CUDA, so again, I've got the full install video where I show it from scratch. But basically, Going to double click CUDA, install it, walk through the installation. Then what you need to do, and this is the bit where it is a little bit more tricky. So once you've got CUDA, you then need to get the matching installation of cuDNN, which in this case here is going to be cuDNN 8.0. So again, to find that, and I'm showing you how to find it on Google rather than just giving you the direct links, because these are going to consistently change. So if we type in cuDNN, and remember we needed, what version did we need? We need 8. So I'm going to type in cuDNN 8 because again, these consistently change. And in this case, these are going to be available from the NVIDIA site, just as we got from CUDA as well. So we're going to go to NVIDIA cuDNN, and we're going to look. There should be cuDNN 8. Let's see what's available there. Right, so down here, we've got a link to GTC. Now we want to download cuDNN. Now, in order to do this, or in order to download cuDNN 8, you're going to need a NVIDIA developer account, but it's free. You just need to sign up. So I'm going to select download cuDNN, and then we need to log in. So this is why you need the developer program membership. So in this case, I can log in. And then log in. So do the captcha. So what do we do in trucks? And then it should allow you to actually go on ahead and download cuDNN. Now you do need both, but only if you're training on a GPU. If you don't have a GPU on your local machine, you don't need to go on ahead and do this. So in order to download it, you just need to hit I agree to the terms, and then you're looking for the version that you need. So in this case, there's 2 versions available here. So there's cuDNN v8 for CUDA 11, and there's cuDNN v8.1 for CUDA 10.2. So remember that we had, for our particular version of TensorFlow, which is 2.4.x, we need cuDNN 8 for CUDA 11. So in this case, we are going to get cuDNN, which I believe that's v8 1.1. So we actually need to go find a different version, right? So it's cuDNN 8.0. And let's find it. So in this case, we're going to go to the archive. All right, so this is looking better. So you can see here that we've got a bunch of 8 versions. So rather than having 8.1, again, these are going to consistently come out with new versions. So we need this one over here. So we've got CUDA 11, which is over there, and we've got cuDNN v8.05. So we can download this, just find the version for your machine. So in this case, we've got cuDNN library for Windows x86, so I can download that. And that's going to download. So in this case, again, I've already got this installed, so we can cancel that. So it's going to look a little something like this. So it looks like I got 11.2 here, but what do we need? cuDNN. Okay, I guess this one must have worked. All right, so it's going to look a little bit like this. So we've got cuDNN, and it's a zipped file. So what you want to do is extract it. And in this case, I'm just going to extract it here. And then what we're going to do is we're going to copy the cuDNN files into their respective folders inside of our CUDA installation location. That was probably a bit of a mouthful, but basically you're just copying and pasting stuff. Okay, so we've got our stuff extracted. So which one is it? It's this one here. So if I double click into it now, you can see inside of CUDA, I'm going to have a bin folder, which has a whole bunch of cuDNN stuff. An includes folder, which again has a bunch of cuDNN stuff, and a lib folder, which again has a bunch of cuDNN stuff. What we need to do is open this, or is copy those folders into our CUDA folder. So if I actually show you what mine looks like, so if we go and find NVIDIA, and I believe it's inside of this folder called NVIDIA GPU Computing Toolkit. So I've got CUDA, and I've got a bunch of versions pre-installed. Inside of my bin folder, I'd just copy these bin files. So I'd copy all of those over. Now I've already got them done, so I'm good to go. But you can see that I've already got these available here. So I've copied these cuDNN files into the bin file inside of my CUDA directory. Again, if I go back, I'll have to do it for my include file. So again, include, do the same thing. So I've got, they should be in here. So you can see that I've got all the cuDNN files. Just copy those into here. And again, likewise, you've got to do it for the lib x86, and again, we're just doing it back into here. So you can see I've got all of these cuDNN files. Again, I've just copied these over into the respective CUDA folder. So once that's done on your Windows machine, you just need to do one last thing and make sure that it's added to your path. So in this case, if I open up my properties, go to Advanced System Settings, Environment Variables, and then go to my path, you can see I've got my bin folder, or the path to my bin folder, the path to my libnvvp folder, and the path to my cupti folder. So there should be three. So this one, and this one. I don't know. Let's see if we can make that a bit bigger. There you go. So these three file paths are the ones that you're going to need added to your path on a Windows machine in order to enable this to work. So again, this is just pointing to this particular folder over here. So if I go in, let's make this a little bit easier to see. So we are pointing to our, so NVIDIA GPU, CUDA, and then see, so I'm pointing at V11, and then bin, and then you can see I'm pointing to, so my bin folder, which is this one, my VVP folder, which is this one, and then my CUPTI folder. So if I go back in, so it's under extras, CUPTI, and then libxx86, or that doesn't actually look like that one's been defined right. That's a bit better. lib64, cool. So that should be all good. But again, I'll show you how to check whether or not that's working when we actually go to train. So you'll be able to actually see whether or not it's picking up the appropriate version of CUDA. So that's sort of just an extra install step that you need to go through if you want to train on your GPU. If you don't have a GPU on your machine, should be good to go. Don't need to worry about that. But that is our installation done. Now, more often than not, that can be a bit of a nightmare process, but you can start to see that there is a flow to it. So go through, run through your install, test your verification script, and then just keep running through to make sure that you effectively get that OK symbol at the end when you run your verification script. So again, we can actually run this again. And ideally, what we should get is that OK symbol or that OK status right at the end. Even though it's in bright red, as long as you get the OK at the bottom, you should be good to go. So let's run this. And keep in mind, we restarted our kernel. So even though we restarted, we should still see that OK pop up. And again, looks like it's OK. So we're inside of our virtual environment. We've got our OK status popping up. We're good to go. All right, so we are now up to this cell down here. So this cell over here is actually going to download our model from the Tensorflow Model Zoo. So if we cast our minds back, our Tensorflow Model Zoo was this one over here. So remember, we've got a whole heap of models that we can already use for our training. Now, the reason that we do this is because one, we get a state-of-the-art architecture that we can use. And two, we're going to be leveraging a technique called transfer learning. Now, out of the box, we can actually use these models to do standard object detection. So this is detecting just generic objects. So a phone, a bottle, a towel, so on and so forth. What we're going to do is we're going to leverage what that machine learning model or what that deep learning model already knows to be able to transfer that knowledge over and detect custom objects. So in this case, we're going to be detecting our different hand poses, right? So the reason that we're using that architecture is mainly for those two reasons. Now, what we're going to do is we're going to run this cell. And again, it's checking which operating system we're in. It's then using wget to get it from our pre-trained model URL, which is what we defined up here. And I'll show how to do a more sophisticated or a different model once we get to our performance tuning section. So now that that is, so ideally what should happen is that this particular cell over here is going to clone down that model from Tensorflow Model Zoo. And it's going to paste it or put it inside of a specific folder. So if you go into Tensorflow, Workspace, pre-trained models, you can see that it's actually gone and cloned down that model into that specific folder. And this is why I defined the name of that folder earlier on, because we are actually going to be leveraging all of the stuff that it's in here. So inside of that folder, let's go back, you're going to have the cloned repository. So in this case, it's just copied down the compressed file. It's then untarred that file. So that is, let me just bring that over here. It's then untarred it, which is over here. And it's also moved that particular file into this workspace. So now you should ideally have all of this. So you've got a checkpoint folder, which contains all of the different checkpoints for your file. Think of this as the different saved components to your model or the pre-trained model. You've got a saved model.protobuf file and a variables file. So again, this is everything that you get when you actually freeze your model. And again, I'm going to show you how to do this later on for your own custom model as well. But just think of this as your pre-trained model that you're going to be able to leverage for your custom object detection. So that's good now. Now, the next thing that we want to do is create something called a label map. So a label map effectively represents a map of all your different labels. So remember, we had thumbs up, thumbs down, thank you, and live long. Now, I've already got these written here, right? So I've got thumbs up, thumbs down, thank you, and live long. So let's go on ahead and run this. This should run successfully. So no errors there. So if we go into our workspace, so this is going to be written into our files label map file, which was defined over here. So it's going to be inside of annotation path and then the label map name. And our annotation path is annotations, and then our label map is named label map or .pbtext. So if we open this up, you can see we've got an item for each one of our objects. So thumbs up, thumbs down, thank you, live long. Now, remember when I said the case was really, really important? This is why. So when we go, the next step that we're going to normally run through is actually creating our TF records. So what this actually does is it creates a file format, which is called a TF record, which is available to be used to actually go on ahead and train your object detection model. So if we go into these next two lines, so you can skip this one over here. So this is only used if you're training on it on Colab. So if we go and run this TF record script, which is there, this is going to run or clone a file from my GitHub, which is called generate TF record. So let me show you that. So it's going to clone this file, and this is the file that generates your TF records. Again, you don't need to go into a great amount of detail for what that actually does. Just know that it's converting your annotations and your images into a file format that it can use. So if I run this cell, it's going to clone it down. And then you should ideally have a file. So if you go into workspace, and then where is this? This is in TensorFlow, scripts. Should get that file. So generate TF record or generate _ TF record. So that's now available there. Now what we're going to do is run this file here. So I'm going to show you once running without errors, and then I'm going to screw up our label map to show you why the case is so important. So if I run this, oh, it looks like we've got another module error. So in this case, we've got a module error. So what do we do when we've got a module error? Just go on ahead and install that. So it looks like it's PyTZ. So let's check how to install that. So it looks like we just need to pip install PyTZ. So let's go on ahead and do that. So again, if you get any of those no module errors, you just need to install it. See if that runs now. Okay, that's looking like it's running successfully. So again, to solve that error, it was a no module error. So to solve that, we just install the module. And then when we run our TF record script, what it's actually going to do is go on ahead and create. So if we go into our TensorFlow workspace annotations file, we've now got a train and a test record. So these are what are going to be used to actually train our model. Now, if I screw up our label map, right? So say, for example, I take off the capital U from our thumbs up label. This is going to screw up that generation. So if I go and run our generate script again, watch this. So you can see that we've got this key error. So key error thumbs up, and then key error thumbs up. So this is because we have included the incorrect label. So it is case sensitive. So you need to make sure that the case is correct. So if I go and fix that up now and change our label name to thumbs up and rerun that again. So this should now run successfully. And again, no issues. Cool. Now, the next thing that we're going to do is pretty straightforward. So now what we're going to do is just go and copy our model config. So our model config is, so remember, there were a bunch of different types of, let's just close this and this and this. So there are a bunch of different types of models inside of our TensorFlow Model Zoo. Now, the pipeline config is what controls what your model actually looks like. So if I go into, let's start from the start. So TensorFlow, workspace, pre-trained models, SSD mobile net _v2 _fpnlite _320 by 320 _coco 17 _tpu8. This pipeline file over here is what defines the architecture of your model and what it actually looks like. Now, what we're going to do is we're going to customize this for our specific model, but this sort of gives you a baseline. So in here, you're going to have the number of classes. You're going to have that image resizer, which I was talking about. So remember, it resizes it to 320 by 320. Your feature extractor, One that I particularly like is post-processing, no, data augmentation. So you can see here that it actually does your data augmentation for you. This is important because I'll show you in some of the other models later on, you'll get a slightly different data augmentation architecture. This is just important to note that it gives you some pre-built data augmentation inside of your model. If you scroll down, you can see that you've got all of these path to be configured components. So we actually need to update these with our components for our model. So we need to update fine-tune checkpoint. We need to update our label map path, our input path, our label map path, and our input path. Our label map path is our label map.pb text, so that's what we created. And our input path, in this case, our train input reader or our train input path is going to be our train.record file, which is, let's go back, which is this file here. And our test input file, which is what's being referred to, or our eval input file, which is what's being referred to down here, is going to be our test file. But again, you don't need to worry about this. I just wanted to give you a little bit of additional background. Our code is going to do that for us. So if we go and step through, so first up, what we're going to do is copy that pipeline file from our pre-trained models folder. So we'll copy it from here into our my SSD mobnet folder. So if we run that, you can see that that's now being copied. And then the next sets of code are actually just going to do all of that configuration for us. So if we actually just step through all of that, right? So it's opened up our config file, it's gone and set all of our different file paths, and it's gone and saved it. So if I open up our customized one now, what you'll see is that it's gone and changed the number of classes. So this represents the number of different types of objects we're going to use. And if we scroll on down, let's close this. You can see that we've actually also gone and set up our different paths. So we've gone and set up our fine-tune checkpoint, our label map path, our input path, so on and so forth. So we've set that up, set that up, set that up. So this is now all configured and pretty much good to go for us to kick off training. So if we close this now, what we can actually do is actually start training our model. So we're now finally up to the good bit. So before we actually go and train our model, let's take a look at what we've done, because we have done quite a fair bit. So we set up all of our paths. We downloaded and installed the Tensorflow Object Detection API. So remember, we had to go through a number of iterations, but as long as your verification script says okay, we are good to go. We then went and downloaded our pre-trained model from the Tensorflow Model Zoo. We created our label map, and remember that is inside of our workspace, annotations, and then label map.pb text. So if I open that up, it's really just this. We then created our TF records, which again are our test and our train files. We copied our config to our training folder and then updated that. So again, that's all just code driven. You don't need to do anything there. Now we're up to the good bit, training our model. So in this case, what we're going to do is hit Shift Enter, and then print out our command. Now I'm going to run this outside of a notebook. So that's going to allow us to see our progress as our model is actually training. Now, if you run it inside of the notebook, the only disadvantage is that, particularly on a Windows machine, you're not going to see the status update in real time. So I'm going to copy this over here, and then I'm going to open up a new command prompt, then navigate to where I've got my root Tensorflow Object Detection course folder. So let's do that. And I'm going to go into TFOD course. All right, cool. So we want to be in this top level folder. So you should ideally see the TensorFlow folder. So let's clear that. Now, what we need to do again is remember we need to activate our environment. So to do that, we can do /TFOD, /scripts, /activate. Now, if we type that, so again, we're still inside of our TensorFlow folder. Now, what we can do is we can actually copy that command. So let me just explain that command a little bit. So the first thing is actually running our model training script. So what it's doing is it's using the model_main_tf2.py script. Now, again, I'm going to this into a little bit more detail than I usually would because I really want to explain to you how this actually works. So what it's actually doing is it's going into TensorFlow, models, research, object detection, and then it's running this script down here, model main_tf2. Probably a little bit small to see. So model main TF2 down there. that was probably obscured by me. So it's running that over there. So model main underscore TF2. So that is this component here. So it's running that. Then we're passing through a number of arguments. So first up, we're passing through our model directory. So this is where our pipeline.config file is. Remember, our pipeline config had all of our custom paths, had our number of our labels, and had all of our different details of the specific object that we're going to use. Then we are passing through our actual pipeline config, and we're also passing through the number of training steps that we want to go ahead and run through. So in this case, we should be good to go now. So we're going to copy this command, and we are going to paste it into that new command prompt. So let's clear that. And keep in mind, we've activated our virtual environment. So your virtual environment has to be activated. Otherwise, you're not going to be able to leverage all of that Tensorflow object detection stuff that you've gone ahead and installed. So if we paste that command in there now, the last parameter is the number of training steps. So you can increase this or decrease this. Ideally, I normally set it to 2000 for my first prototyping step. Then I'll go and clear out all my training, and then I'll set it to 10,000 when I come to do my actual training run. So let's go ahead and run that. And ideally, so you can see that it's successfully opened and looks like we've got an error there. Okay, this is good. Cool. So we've got this error here. So value error, numpy ND array size change may indicate binary incompatibility. Expected 88 from C header, got 80 from PyObject. So if we copy this, and again, go into our error guide and search for that, you can see that that particular error is solved by reinstalling PyCoco tool. So let's go on ahead and do this. So we can pip uninstall PyCoco tool. So let's copy that. Cool, so that's it uninstalled, and then we can reinstall it. Okay, so in spite of these, that looks fine. So it says it's successfully installed PyCoco tools again. So let's go on ahead and paste in our command again. So if we go back to our notebook, we can copy this. No module named TensorFlow add-on. So again, this is a no module error, so we should be able to pip install TensorFlow add-ons. Now let's try running our command. No module named Jin. All right, so these no module errors are specifically attached to the TensorFlow version. So let's just type in pip list first up. So even though we've got TensorFlow 2.4.1, TensorFlow estimator, so let's install Jin. So pip install Jin. Try our training command again. So let's search for that one. Looks like I've encountered that one again, and it looks like we need to downgrade. So let's do that. So let's pip install jin-config 0.1.1. So let's try that. Let's try this. Okay, that's looking good. So it looks like we sorted through those errors. And again, no module errors are normally just solved by installing the right library. If you can't find the right library, just take a look, Google around, see what people have done. More often than not, these are common errors. So in this case, we just needed to install or pip install jin-config. But now you can see that this is actually running. Or well, I know from experience that this is actually running now. So what you're going to see is first up, if you're running on a GPU, that your GPU memory is taken up. So you can see that, let me bring this over to this side. So you can see that I'm now using the full 8 gigs on my GPU. And ideally, in a couple of seconds, you should start to see our loss metrics showing up. Now, one of the things I actually just noticed is that we didn't actually have TensorFlow GPU installed. So it was taking a long time for that training to kick off, which was a little bit weird, to be honest. So normally it should take no more than 10 to 15 seconds to actually kick off. So what we're going to do is so I actually just installed TensorFlow. And then what we're going to do is make sure that we've got the right versions of TensorFlow and TensorFlow GPU installed. So we'll install pip install TensorFlow. And we add 2.4.1. And we're going to install TensorFlow GPU as well, because you need TensorFlow GPU to leverage the GPU. So we'll run TensorFlow dash GPU equals 2.4.1. So even though our verification script was fine, we do still need TensorFlow GPU. So before it was fine to run on CPU, to leverage the GPU, we need TensorFlow dash GPU. So let's go on ahead and install that. And give that a couple of moments to install. And ideally, we should see that we've got TensorFlow GPU installed. So if you kick off your training and you do have a GPU, you've set up CUDA and cuDNN, the next thing to check if it's not kicking off on your GPU or not starting to train relatively fast is whether or not you've got TensorFlow GPU installed. So then we're going to copy our command, and now you should see that our training kicks off a lot faster. Let's clear this, paste that in, and let's see how long this takes now. So if it takes a long time, double check that as well. So whether or not you've got TensorFlow GPU installed. So these are all pretty normal outputs. It's looking positive. So when it sort of gets to this line, and again, it might be a little bit different depending on what you're training on, so use fn underscore output underscore signature instead. So normally that means that it's sort of got to the next step. So ideally what you should see is the loss metrics appear after this. So let's wait and see. Sort of stalls, we'll restart it. No, there you go. All right, cool. So that looks like it's kicked it off. So you can see that now we're getting these metrics here. So basically, after every 100 steps, this is going to be printed out. So you'll get step 100 per time. So you'll get the time per step. So in this case, it's 0.82s or seconds. We've also got the loss. So in this case, our loss is 0.693. Now, if you cast your minds back to our evaluation step, what we're saying is that you want your loss to be as low as possible, your mean precision and your mean average precision, as well as your recall to be as high as possible. So in this case, we're going to let this run. So ideally, you're going to see this output after every 100 steps. So in this case, we've got our first 100 steps. And if we also take a look, you can see that we've got our checkpoints starting to generate here as well. So we're looking good for now. We're going to let that run and we'll see how we go. So ideally, remember we kicked off our training for 2,000 steps in our training command, which is right up here. So we had 2,000 training steps. So ideally, after 2,000 training steps, we should have our fully trained model. So let's let that run, and then we'll come back and take a look and do some detections. So that is our model fully trained. So you can see that we got up to step 2,000, and our final loss, let me bring this over to this side, and our final loss was 0.188. Now, if you also take a look inside of our My SSD MobNet, you can also see that we've got all of our checkpoints generated. So we've now effectively gone through and trained our model. Now what we can do is actually go and evaluate it. So remember how I was sort of saying you've got your mean precision metric. So you've got precision and recall. We can actually go and calculate these using the TensorFlow Object Detection library. So what we can do is run our evaluation script. So if we go and run our evaluation script model, so we've gone and done step 6. And again, our model is successfully trained, so it didn't take too long. What did it take? So 0.153 seconds per step. So again, it got pretty fast on the GPU. Now what we can go on ahead and do is evaluate it. So if we go to step 7, hit Shift-Enter, print out that command. Now we can actually run this one. We'll run it using our command prompt. So we'll copy that. So if we go and paste that command again, so we're making sure that we're inside of our virtual environment. We can go and paste this, hit enter, and this is actually going to go on ahead and calculate our performance metrics for the model that we've currently got in that folder. So again, it's going to go through all of these different lines, write out a bunch of stuff. And ideally what you should see towards the end of it is that you get this little table that gives you all of your performance metrics. And there you go. So you can see here that we're getting our average precision, our average recall. We should get some loss metrics as well. So they're down here. So you can see that we've got a bunch of loss metrics. But I'd pay most attention to these ones up here. So you can see here that our average precision at 0.5 to 0.95 IOU, so just pay attention to this, is 0.688. So again, it's not the highest precision, but it's not too bad. Our recall is about 70%. So again, not too bad given the fact that we only gave it, like 5 or 6 images per class. So again, not too bad, right? Now, what you can also do is you can also open up these same detection metrics as well as the loss metrics using Tensorboard. So if you haven't worked with Tensorboard before, basically it's an interactive monitoring tool that comes or that is open source through TensorFlow. So what we can do in order to use that, so we can just step out of this by hitting Control-C, is inside of our My SSD MobNet folder, you've got 2 folders which I haven't really talked about yet. So you've got this train folder that's generated when you kick off your model training, and you've also got this eval folder, which is generated once you go and run this evaluation script. So effectively, the script under 7, evaluate the model. So these 2 folders are going to be generated after training and after evaluation. Now, what you can actually do is you can actually step into these folders and spin up Tensorboard. So let's go on ahead and do this. So right now, we are in our root folder, so we can go into TensorFlow. And then we can go into Workspace. And then I believe CD Models. And then we want to go into our My SSD MobNet folder. This is probably going to be right down in the corner, CD My SSD MobNet. And now we're going to have this train folder and this eval folder. So if we go into, let's do train first, because train is going to get, if you open up Tensorboard inside of the train folder, you're going to get loss metrics. If you open it up inside of the eval folder, you're actually going to get your evaluation metrics. So let's do our train folder, so CD train. And then the command that you want to write in order to open up Tensorboard is Tensorboard. It's right down the bottom. Let's clear this first. Tensorboard --log dir equals dot. So this is going to open up Tensorboard in the current folder. So if we do that, and I've typed in Tensorboard wrong, this should open up Tensorboard, and Tensorboard's installed when you install TensorFlow. Then what you can do is you can go to this URL here, so localhost 6006. And this is going to open up Tensorboard. So through here, you can see all of your loss metrics. So you can see that over time, the loss is reduced. And remember, we want loss to be lower because a reduced loss indicates it's performing better on our training data. So in this case, you can see our classification loss, our localization loss, and our normalized loss. So you sort of want these to be in an inverse hockey stick trend. So starting up high and then dropping low. Now, this is all well and good, but you're probably more interested on the evaluation metrics. So again, you can sort of navigate through this. You can also see the images that we've gone and used. So our train images. And these are our different samples. You can adjust your brightness. And this is just viewing them at the moment as well, right? Cool. But what we actually want to do is take a look at our evaluation metrics. So if we step out of this, and if we, rather than being inside of our train folder, if we go back and go into our eval folder, so remember that is this folder over here, we can run Tensorboard again, and this is going to give us a slightly different view. So again, we're just going to run Tensorboard --log dir equals dot. So remember, this is important because it represents the current folder. And again, so it's going to open up Tensorboard. It'll start up. It's running at the same URL, so HTTP localhost 6006. So we can actually just refresh this. And you can see that this is giving us our evaluation metrics now. So you can see that our mean average precision is 6.876 down the bottom there. So it's a little bit hard to see. And now what is this metric over here? This is again our precision. You can close this. We've also got our recall, which is 70%. Again, these are the same metrics that you saw when we ran our evaluation script. Now, what we can also do is we can run this after every training run. So we'll actually be able to see what our performance looks like over time as well. So again, you've got the ability to do that. You can also view your loss as well here. So this gives you your testing loss on these particular sets of data. You can also view your images. So again, this sort of gives you an idea of our real-time performance. So again, you can see that this is what it's actually going to look like when it comes to actually go and detect our models. And it looks like it's detecting pretty accurately. So that is thumbs down. That is thank you. That is live long. This one looks like it's gone and had a little bit of an issue with thank you there, but thumbs up looks like it's performing all right. and eval side by side. All right, looks like I got a little crazy there as well. So, all right, so that looks all well and good. So that gives you an idea of how to train and evaluate your model as well. Now, on that note, we are now up to detecting objects. So first up, what we're going to do is we're going to detect our object or detect an object with an image. So this is particularly useful if you're detecting from a cloud provider that doesn't actually have access to a sensor like a webcam or in this case, a microscope. So we're going to detect using an image, but then we're also going to detect in real time. So we'll be able to throw up different symbols, so live long, thumbs up, so on and so forth, and we'll actually be able to see those detections in real time. Once that's done, the last thing that we're going to do is freeze our graph and then export. So let's go on ahead and perform our detections, and then we'll run through our last step, which is going ahead and freezing and exporting our graph. And then we've obviously got our projects and performance tuning as well. So let's step back. So again, using our same notebook, what we can do is we'll just kill off our Tensorboard instance, so this doesn't use up our GPU. So what we can now do is we can actually load our trained model from our checkpoint. So we've now gone through, let's quickly recap. So we've set up our paths under step 0. So we downloaded our pre-trained model and installed TensorFlow Object Detection. We created our label map, and remember, this is just a set of labels that represent our different objects that we want to detect. Created our TF records, copied our config and set that up. We then went and trained our model using the command prompt and evaluated as well. The next thing that we're going to do is load our model. So now, if you go into your pre-trained model folder or your trained model folder, which is the My SSD MobNet folder. So remember, if we go into TFOD, TensorFlow, Workspace, Models, My SSD MobNet, this is your custom model, right? So everything in here represents your trained custom model. So if you wanted to give this to someone else, you'd be giving them this folder because it contains your pipeline and all of your checkpoints. Now, the latest checkpoint that we can see here is checkpoint 3. So this is our most trained model. If you train for longer, you'd ideally get checkpoints with greater numbers as well. So what we're going to do is we're going to run that particular cell, so the import, and then we're going to change this line here, which you can see says checkpoint 5 to checkpoint 3, because that is our latest checkpoint. So we can run this and set it up. That's going to import our latest checkpoint. And then what we can do is actually detect from an image. So let's go on ahead and import that dependency under step 9, set up our category index, and then we'll grab an image. So let's go into our workspace, our images, and we'll grab a test image. So let's grab this one over here. So I'm just going to grab the name of that image, and I'm going to replace it over here. Right, so basically inside of this line here, so under step 9, we've got the third cell, which is image path equals os.path.join. We're basically just resetting the path to that image. So if I type out image path now, right, it's just the path to that particular test image that we had there. So if I go and take a look, so basically the full file path is TensorFlow Object Detection, TFOD course, TensorFlow Workspace Images Test, TensorFlow Workspace Images Test, and then that particular image. So we're good to go. So now what we can do is run this cell, and this is actually going to run object detection on that image and print out our results, which we should see here in a second. So let's give that a sec. And there you go. So you can see right down there, it's gone and accurately detected that that particular symbol is live long with a 98% confidence metric. So again, we could do this on a different image if we wanted to. So let's grab another one. Let's grab thank you. So if we grab that label, we'll grab that image name and replace this. Run this again. We can delete that now. So again, that's detected thank you successfully. Let's try another one. Thumbs up. So again, all I'm doing is I'm changing the part to that image. If you had your images somewhere else, you could do that as well. So it's accurately detected thumbs up, 86% confidence. So not the greatest on that one. Thumbs up was the one that we took new images of as well, wasn't it? So again, we could performance tune there. And let's do thumbs down. Okay, so not too bad. So 100% on thumbs down. So that gives you an idea of how to do it with images. Now, basically what we're doing here is we're loading the image into Python. We're creating it or converting it to a tensor and running our detection. So this line over here is actually using our detection function, which we imported. And then it's going ahead, making those detections and then visualizing it. So again, if you'd like to see me explain this in more detail or maybe even code it up from scratch, by all means, do leave a mention in the comments below. I'd love to hear your feedback. Okay, so those are our detections. So that's all great. Now, the next thing that we actually want to do is make some real-time detections from our webcam. So let's go on ahead and run this cell under step 10. Now, I'm going to not run this cell, which is pip uninstall opencv-python-headless-y. We'll come back to that in a second. And that's normally a resolution to a pretty common error. But let's go on ahead and run our real-time capture and see how we go. So it looks like it's running. Okay, so it looks like it's got our feed. So it's got live long, thumbs up, thumbs down. That's actually really, really good considering we only trained for 2,000 steps with not a whole heap of images. That's actually performing really well. So live long, thumbs up, thumbs down. Thank you. Let's see what it looks like with the green screen down, because remember, we didn't train with this. So live long, still performing well. Thumbs up, thumbs down. Thank you. What if we did a joint? So thumbs up. So thumbs up is not performing the best. What if we did live long? You can see there that because we maybe haven't done too many images trained on, so let's do thumbs up. So, all right. So again, so you can see that the performance isn't so good when we try to change it or use different hands. So, okay, maybe that's performing not too bad. So thumbs up isn't performing well with this particular hand. So again, we might add some additional images. We might add images of each hand. But again, that's performing reasonably well, right? And like this is dual hand right now. So it's not too bad. Thank you. It's performing okay. How about live long? So live long on this hand. Yeah, pretty cool. But that sort of gives you an idea of what's possible, right? So like really, really quickly, we've built an object detection model that's able to detect a bunch of stuff. So thumbs up is perfectly fine. What was it? The thumbs down? Okay, it's not so bad. Maybe it needs to be a little bit closer to the camera. But again, these are the things that you could additionally train for. So we could add more images of closer to the camera. We could add more images of this hand doing live long. Sort of gives you an idea of how you can performance tune and update your model to be able to perform better. Now, if you want to quit out of this, all you need to do is hit Q, and that's going to close it off. But again, that sort of gives you an idea of what's possible with real-time object detection. Alrighty, so we've now gone and also made detections using an image as well as using a webcam. Now you can also do this with an existing video feed or an existing video. If you'd like to see me do a video on that, by all means, mention it in the comments below. I'd love to hear your feedback. All right, so this brings us to freezing and conversion. So part 5, freezing and conversion. So now what we're going to do is freeze our graph. And again, as I was sort of saying, freezing your graph is the equivalent of saving a slice of your model, or effectively saving it down so that you can use it next time. So we're going to freeze our graph. We're also going to export it to Tensorflow Js, so if we wanted to use it later. And we're also going to export it to TFLite. And we'll eventually use this in our Raspberry Pi project. We'll use our TFJS export for our web app. Now, these are all reasonably straightforward. So I've just got step 10, 11, and 12. All you need to do is run through these and it's going to freeze your graph. So let's go ahead and run this. And I'm not going to copy this command outside of the notebook. It's probably just easier to run it here. And once you've frozen your graph, this is going to appear. Let's just make our mouse work. This is going to appear inside of our export folder. So ideally what you should get is inside of, if we go back to our root, so TensorFlow, Workspace, Models, MySSD MobNet. Inside of our export folder, we're going to have our frozen graph made available. So let's give that a second. So again, this might take a little bit of time to run. And so that looks like it's now complete. So let's just check. Doesn't look like any errors there. And you can see that you've now got your checkpoint, your saved model, assets, variables, and your saved model.protobuf file. Now, if you remember correctly, remember how I said that we were going to create a similar output to what we had for our pre-trained models? You can see that we're now doing the exact same thing. So we've now created our own slice of our own custom model, which looks almost identical to what we had from our pre-trained model. But now, again, this is based on our custom model. So again, we've got all of that available inside of our export folder. So we've got our checkpoint, we've got our save model, and we've got our pipeline config. And this will mimic exactly what we had for our custom one. So if I scroll down, again, so this is currently still pointing at our own file folders, but you can see that you've got all of the stuff that you custom built for your own model, right? So this is now available to be used elsewhere. So you could actually go and convert this, which is exactly what we're going to do. But again, you could pass this off to someone, they could pick this up and use it as well. Now, the next conversion that we're going to do is we're going to export this to TFJS. So if we go and run all the steps beneath step 11, so first up, it's going to install Tensorflow Js converter or the Tensorflow Js converter. And then again, it's going to create this command, print it out, and then it's going to run it. So ideally, this should create a model.json file and a number of bin folders. And I'm going to show you how to use this inside of our projects. But for now, we're just going to convert it and we'll be able to leverage it later on. So give that a couple of minutes and you should effectively have your converted Tensorflow JS model. And there you go. So you can see that we've now got our bin file. So we've got our different shards and we've got this model.json file, which is huge. So if you actually scroll through this, this represents our entire deep learning model in JSON format. Now, when we load this into our React app or into our TensorFlow JS app, which is in JavaScript, but again, I've written all that code for you. You just need to paste it in there. This effectively represents the full architecture and the weights and everything, which is actually pretty cool. Now, the last conversion that we want to do is conversion to TFLite. So again, same sort of deal, except this time, rather than our exports being export or TFJS export, we're going to export into TFLite export. So again, let's just go on ahead and run these commands. So the TFLite conversion takes two parts. So first up, we convert it to, what was it again? So we export it to a TFLite graph. And so we do it using this command, and then we go and actually run it using the TFLite converter. So this is, again, a slightly separate app. But again, you don't need to worry too much about this. It's actually just going to convert it and output it to exactly the output that you need to be able to go and leverage that. So let's let that run. And that brings us to the end of this end-to-end model. So you can see that we've now gone and converted, and it's still running the second part. So let's give that a sec. Perfect, and that looks like it's gone and effectively finished. So now, if you go into this TFLite export folder, double-click Saved Model, you've now got this folder called detect.tflite, and that is your TFLite export. So that about brings us to the end of our conversion. So we've now gone and frozen our graph, exported it to TFJS, and exported it to TFLite. And it also brings us to sort of the end of our full run through of actually working with Tensorflow Object Detection. So all up, what we did is we set up all of our stuff and installed all of the Tensorflow Object Detection dependencies. We set up our virtual environment, which is called TFOD. We imported our dependencies, defined our new images to collect, set up our folders, captured our images and labeled them. We then went and did all of our installs. We trained our model and then we evaluated it. Detected from an image, which you can see here. We also detected from our webcam, which you saw using the real-time webcam feed. We then went and froze our graph and then converted it to TFJS and converted it to TFLite. So that is a full end-to-end walkthrough of how to work with the Tensorflow Object Detection API. Now what we're going to do is get started with our performance tuning. So say your model doesn't actually perform that well. What do you go about doing? Well, this is really where performance tuning comes in. So normally there's three key things that I'll do to improve the performance of an existing model. So the first thing is adding more images of a low performing class to your training data set. So you saw that when we were doing thumbs up, thumbs down, live long, and thank you, we were sometimes getting not the greatest detections. Now, one of the easiest ways we can fix this is to take the green screen down and take images of both of our different positions using different hands. So this is going to give our model a better chance to generalize. So when people talk about a model generalizing, really it's being able to perform well in real world situations. The second thing that we can do is train our model for longer. So you saw that when we generated our training command, we had 2,000 steps. Now what we can do is we can actually clear out our training folder and bump that up a little bit. So say for example, we trained for 3,000 steps. This gives our model a better chance at reducing its loss, generalizing, and performing better overall. Now, the last thing that we can do is also change our model architecture. So we talked a little bit about the TensorFlow Model Zoo. So you saw that we were using the 320 by 320 model. So if we actually take a look at that, we were using this model over here. So SSD MobileNet V2 FPN-Lite 320 by 320, which had a speed of 22 milliseconds per frame and an average accuracy of 22.2. But we could also upgrade this and use a slightly more advanced model. Now, again, we're going to have that performance trade-off. So you might have a slower model, but again, it might make better detection. So say, for example, we were to use this model here, which in this case takes 39 milliseconds per frame, but also has a better accuracy metric. So we could do that as well. So what we're going to do is we're going to add some of these techniques to our existing model. So what we'll do is we'll add more images of our different classes. So in this case, we know that our thumbs up, thumbs down detections weren't working so well. So we'll add more images of those. And then what we'll also do is we'll train our model for longer. So we'll bump this up to 3000. And if we get time, we'll change our architecture and I'll show you what that looks like. So effectively, that's really just creating an entire new model. But the nice thing about the Jupyter Notebook that I've sort of set up is that you can plug in the new URL and this will allow you to create an entirely new model and build it using a new architecture. Alrighty, so first things first. So adding more images of our low performing classes to our training set. So we're just going to add more images of thumbs up, thumbs down with our green screen down. And we will see how our performance looks like. So if we go back to our notebook, so remember we've got our image collection notebook and our training and detection notebook. Let me just check we're zoomed in, we're good. So what we're going to do is rather than collect images of every single class, we're just going to collect some more images of our thumbs up and thumbs down. So we can get rid of thank you and live long. So that way we don't have to label a ton of stuff, right? So these were the classes that didn't seem to perform that well, particularly when we were doing it with different hands, right? So when we were switching, it wasn't actually performing that great. So what we'll do is we'll grab some more images of those and label them. Now we'll add, let's add 6. So we've got an even number. So we'll do 3 of each hand in each position. Okay. So again, we're going to import this. And again, make sure you're inside of your virtual environment. So you can see up here that we're inside of Tensorflow Object Detection, which is our virtual environment that we created. So what we'll do is we'll import OpenCV or import our dependencies. Then we'll update our label map. So before, let's just have a look. So before we had thumbs up, thumbs down, thank you, and live long. We are going to just remove the stuff that we don't need. So thank you and live long. So we can remove those. And we'll change the number of images that we want to collect. So rather than collecting 5, we're going to collect 6, so 3 of each. Run that. We can then take a look at our labels. So now we're just collecting thumbs up and thumbs down. And again, so when we actually output these particular images, they're going to be inside of our images part. So if I go into TensorFlow, Workspace, Images, and Collected Images, remember they're going to appear inside of these folders again. So live long, thank you, thumbs up, thumbs down. Now, it's not going to add additional images to live long and thank you, just thumbs up and thumbs down. So let's go on ahead and do that. So if we set up our folders, we've already got these folders created. So again, if we step through this, not going to break anything. And then what we can do is run our image capture. So now I changed this while I was doing some testing. So we're going to set that back to 0. And again, so what we're going to be doing is we're going to be capturing images in our different positions. So we'll step back and we'll take images. We might take the green screen down, or might not. We'll just evaluate and see how it goes. So what we'll do now is we'll hit Shift Enter, and ideally you should see the little Python pop up towards the bottom. So remember, it sleeps for a little while before it opens up. We're just going to have a thumbs up. Cool. Right. Now we'll do it with our other hand. Oh, that's off the screen. And then we're going to do thumbs down. So 3 on each again. So off the screen again. Looks like we had some sucky images there. So let's just go take a look at what we collected, because I've got a feeling some of those were going to be off the screen. So if we go to TensorFlow, workspace, images, and then collected images. So remember we collected thumbs down and thumbs up. So if we go to, looks like there's some images there left from my testing. So let me just delete those. So these look okay. So that's thumbs down, thumbs down. This one doesn't look so good. So let me just make that a little bit bigger. So you can see that we don't even have an object on the screen to detect. So we can delete that one, delete that one. This looks fine. This looks fine. Again, ideally, we could probably get better detections. And these are all of the same side, right? So it doesn't look like we've captured the other ones. I was probably a little bit too slow. So let's just, so that one I'm happy with. That one I'm happy with. That one's okay. Let's delete that one. And we're going to grab 3 more thumbs down, ideally with our other hand. Okay, so let's go to thumbs up. Again, more images from testing. Okay, and so again, that's a poor image. There's no class there. It's all right, it's a little bit dark. That's all right, it's a little bit dark. It's fine. That's fine as well, even though I look a little sleepy there, and that's okay. So 1, 2. All right, so we're gonna add in a couple more images, and then we'll just sort of evaluate what we actually want to keep. So let's do a couple more. So again, to do it again, all we just need to do is run this cell under 4 capture images, and this is just going to capture our images again. So if we run this again, so we'll do some more thumbs up. One, switch. Now it's going to be thumbs down. Keep going off the screen. Come on, Nick. Okay, let's have a look at what we've got now. So, all right, so we've got some more thumbs up. This is kind of good. So you can see that this is a little bit dark. So, I mean, that might be a good chance to give our model to general, or might give our model some additional data to generalize. So that's fine. That's okay. That's fine. That's fine. That's fine. It's looking better. Okay, so I think we're good there. So for thumbs up, so it looks like we're going to have, what is this? 11 new images. And if we go into thumbs down, let's take a look at what we've got. It's fine. Again, we're going to get rid of this one because that's off the screen. This one because that's off the screen. Okay, cool. So we've got a bunch of new images. Now, what we're going to do is we're going to go on ahead and label these again. So remember, when we went and labeled, all we need to do is go through our step 5, image labeling, and this is going to open up LabelImg to be able to label images. Now, because we've gone and installed all of this already, we don't actually need to run every single cell. So these ones up here, so pip install, pip list, these couple, these are just doing the installation. So everything, or all of these cells, which you can see here, these are really just doing the installation. All we need to run is this one. So this is actually going to open up LabelImg. So if you've already run through the installation, you're good. You don't need to go on ahead and install it. So if we just run this cell, we need to define our LabelImg path. So let's run this cell. So you can see here that it's saying the system cannot find the path specified. And that's because we're asking it to open up LabelImg path over there, but we haven't defined it yet, which is what this cell is doing. So if you run the LabelImg path, this should allow you to open it up. So if we open this now, our LabelImg platform should open. So you can see that that's now open. Now what we're going to do is, as per usual, we're just going to go on ahead and label our images. So again, W, and this is thumbs down. And remember, it's case sensitive, so thumbs down. And we need to save, go to the next one. Thumbs down, save. Thumbs down, save. You can see that we've now got varying images, right? So we've got both hands covered. So there's a better chance that the model will perform better. A lot of the time, this is trial and error. So you've got to evaluate and see what's going to make your model perform better. But normally this is the first step. So I'll go on ahead and I'll add more images of the classes, which I wasn't too happy with. This one is a bit of a shocker image, but we'll wait and see. Okay, and we'll do the next one. This thumbs down again. Cool. Then we'll open our next directory, which is thumbs up. And we'll go and do these ones in the same manner. And again, we're just changing the label name, paying attention as to whether or not it's case, or paying attention when it is case sensitive. Again, we can adjust these if we need to. And saving, we'll go to the next one. Save, go to the next one. Save, go to the next one. And just keep going through until you've got all of your images labeled. Now, again, this is something that you could start looking at auto labeling tools for. Obviously, it'd improve your efficiency. Also, pay attention if you do start using those tools as to what the performance of those auto labeled images are. Sometimes, even though you use an auto labeling tool, you still do need to go through and do a bit of a manual review. But again, something that could potentially improve how quickly you're able to label images. So I'm just going to finish the rest of these up. Save that. Do the next one. Okay, cool. So that is now done. Now remember, whenever we are labeling new images, we need to copy them into the training and test folder, so no real change there. So I'm going to copy the majority of these. So let's go. That looks like we've got a good mix there. So let's copy these, and we're going to put them into the training folder. And then we're going to go back to our collected images, go to thumbs up, do the same thing. And let's just grab these. And that looks okay. And remember, you need to grab the annotation as well as the image. So if you don't have both, then you're going to have a bad time. So we are going to grab, why do we still have a bunch of thumbs down? That's because we didn't cut, we copied. So we go to delete those, copy those last couple. And we're going to paste the rest inside of our testing folder. And remember, we did all of those. So we're going to paste the rest into our testing folder. All right, so now we've just added more images of our classes that we weren't too confident about. I thought we pasted those in there already. EF7, let's just cut those. Okay, we did. All right, so now if we go into our collected images folder, thumbs down, we already did those. And a thumbs up. Cool. All right, so that is now all well and good. So we've now gone and added more images to our testing folder and more images to our training folder. Now, if we are going to retrain, we're effectively going to be using our training and detection notebook again. Oh, we can also stop LabelImg. So if you just hit stop, that's going to close this off, and we can close that as well. All right, so now that we've got our images collected, the next thing that we need to do is go on ahead and train our model. Now, in order to do this, we are zoomed in quite a fair bit there. Let's just go to 125. So in order to do this, we're just going to go back to our training and detection notebook, and we're just really going to change one thing. So namely, I'm going to change this custom model name. So when we built our first baseline model, we actually named it my_SSD_mobnet. Now we're going to call it slightly different. So we're going to just add on _tuned. And this is going to give us a new folder. So again, if we step through this, it's going to create a new folder, which again, you can see there. So we've now got my_SSD_mobnet_tuned. So we've now got a separate folder that's going to contain our tuned model. Now we can keep going through this. And effectively, this is going to give us the ability to go on ahead and train a tuned model. Now we can skip this entire step entirely. So we don't need to download any new pre-trained models or reinstall Tensorflow Object Detection. We've done that. We've gone through that pain. That's now done and dusted. Our label map, we can run that again, but really we're doing this so we've got this label line available. And then we're going to create our TF records again. So we are going to now create new TF records. And again, we don't need to install this or pip install pytz again. We had that installed. We are, however, going to run this generation. So remember, this is going to create our test record and our train record. So if we run this, hopefully, fingers crossed, no issues. And this should give us our new TF records to be able to go on ahead and train with. So let's let that run. And it looks like we don't have any errors there. So we've successfully created our TF record file in TensorFlow Workspace Annotations Train Record and TensorFlow Workspace Annotations Test.record. So we're good to go now. Now, the next thing that we need to do is copy our pipeline config. So this is going to copy the pre-trained pipeline config into our new tune model. So if we run that inside of our My SSD MobNet tune folder, you've now got this pipeline file. We can hide this. We don't need a preview pane. Minimize that so it's a little bit easier to see. So we've got this pipeline config file. And then really we just need to make our updates as per usual. So this is really just filling in what's inside of this pipeline config. So if we take a look at this, remember right down the bottom, we need to configure all of these paths. But we've got our code here that's going to do it for us. So we're just going to step through. It's going to open up our pipeline config. And again, this is just the standard one. We can keep stepping through. So this section here is probably one of the most important. This is actually updating the pipeline config. So if we go and run that again, or run the next cell. Now when we open up this pipeline, you can see that we're now going to have all of our label map paths, so on and so forth defined. So that's all well and good. Now what we can do is run our training script. So again, this is all sort of pretty modular. So you can just sort of run through it and it should ideally work. Now, the one thing that we are going to change is the number of training steps. Because remember I said the things to try are adding more images and changing the length of training time. So we can bump that up and we'll increase that to 3000. And we can run that command. And again, try this out. So you might want to play around. You might want to train for longer, train for a shorter amount of time. The world's your oyster here. So again, a lot of it is experimental. So we're going to copy this and we're going to open up a new command prompt. And as per usual, we're going to go to where our virtual environment is and activate that. So let's go and do that. Okay, so that's where our virtual environment is. So you can see that we've got TFOD there. So we can activate that. So remember /TFOD scripts activate. So that's our virtual environment now activated. You can see it there. And then what we can do is paste in our training command. So let's go on ahead and run this. And ideally, we should have a train model come right about after. Okay, so after 3000 steps of training, we finally got our final trained model, which had a loss of 0.213. Now, keep in mind, we had more images. We had images at different angles. So ideally, what we want to do is run our evaluation script to see how our model's actually performing. So remember, our last model had I believe it was mean average precision of 0.7. So now we can see what our model or how our model is performing like this time. So to evaluate our model, remember, we just go through and run the code under step 7. So if we hit that and enter that, so this is going to give us our new evaluation code. So we can copy this over and paste it into our model or into our command prompt. So this should ideally run our evaluation pipeline. So it will take a little while, and ideally we should get some evaluation metrics generated. Okay, and you can see that we've now got our evaluation metrics calculated, and it looks like we have managed to improve our model. So you can see here that our average precision is now 0.834. So that's a bit of a reasonably large jump compared to what we had initially. So before this was about 0.7, and I believe average recall was 0.69 or something along those lines. So again, they were way lower. They were in the 7s and 6s, not the 84 to 84% range. So again, we have managed to improve our model and generate a better object detection model. So simply by adding more images, adding additional labels and different positions, we've ideally produced a model which should generalize better. Now, what we can actually do as well is, again, load this new model. Now, because we have trained for longer, we're going to have a new checkpoint. So if we create let me just show you this. So again, if we go back into our directory, YouTube, TensorFlow Object Detection, TFOD course, TensorFlow, Workspace, models. And remember, so this was our baseline model that we initially trained, and then we trained our tuned model. Now, if we open this up, you can see we're all the way up to checkpoint 4. So this is our latest model. So in order to load this, what we need to do is change the checkpoint that we're going to be loading. So rather than loading checkpoint 3, we need to load checkpoint 4. And then what we can do is we can actually go and run some detection. So rather than detecting from an image, let's just jump straight to real-time detection, which is effectively this cell here. And if we run that, that should effectively open up our webcam and give us the ability to make some real-time detection. So let's see how that actually performs. Okay, so we've got our detection window. Thumbs up, thumbs down, thumbs up, thumbs down. All right, so this is detecting live long. So let's move over a little bit. There you go. Way better, right? So that's, again, performing ridiculously quickly. So we did train for longer. We trained with more images. So really fast. So right now we're really, really quick. And this is switching really fast as long as my hands aren't below. And so that sort of gives you an idea as to how you can go about performance tuning. So again, you can see it's very, very quick. And we're doing pretty well there. Awesome. All right, cool. Now, the next thing that you can also do in order to performance tune is change the architecture. So if we cast our minds back, we sort of talked a little bit about adding more images and training for longer. Now, the next thing that you can also do is change the architecture. Now, in order to do this, you can all you really need to do with the particular code set that I've got is change the link that you actually want to use. So in this case, we're using, let me just zoom in. We are using this 320 by 320 model. But say, for example, we wanted to use this one over here. So again, there's some nuances if you want to tune them. But really, all it's a matter of doing is copying the link address and then going back over to our detection notebook and changing the pre-trained model URL. So if I actually run this, so you can see it's updated the URL for that specific model. And then what we need to do, so once we've got that, we just need to grab this name here. So you can see here that it's called SSD MobileNet V2 FPN Lite 640 by 640 Coco 17 underscore TPU dash 8. So we can copy that over and paste it here. So this is effectively going to give us the ability to go and grab a new pre-trained model. So when I run this, it's going to download a new pre-trained model and effectively walk us through the exact same steps. Now, I'm not going to go through this in a huge amount of detail, but if you'd like to see a more detailed video on using different architectures, by all means, do let me know. But it sort of gives you a feel for how you might go about this. So really, you grab the new model link, and then this cell over here is actually going to go on ahead and download that new pre-trained model. So then what will happen is inside of your pre-trained models folder, workspace, pre-trained models. So you'll get, so you can see that I've already downloaded a bunch of different ones. So it'll just download a new pre-trained model that you're able to use. So that about wraps up performance tuning. So we did a bunch of stuff there. We didn't really need to change our model architecture in order to get better performance. Really, it's about the image quality. So rubbish in is going to equal rubbish out. Quality in is going to equal quality out. So having different styles of images, different images of different qualities and different images at different angles, as well as training for longer, more often than not is going to be sufficient for producing a better model. So this brings us to our next part, training on Colab. So in order to train on Colab, you can go through pretty much the same steps. The core difference is that you need to have collected your images already in order to be able to do this. So let's go on ahead and jump onto Colab and we'll start doing that. So again, the core thing that I was saying is that in order to train on Colab, you do need to have your images pre-collected. It just makes your life pre-collected and pre-annotated. Just going to make your life a bunch easier. So let's go on ahead and do this. Now, the easiest way to get your images onto Colab is inside of our image collection notebook. Right down the bottom, I had this code cell, which allows you to compress your images and archive them. So if we actually run that cell, this is going to compress the images that we've got. So if we go into our images folder now, workspace images, you're now going to have this file called archive.tar.gz. So this is all of our images from our training and testing folder now compressed and archived. So what we can actually do is jump on over to Colab. So in this case, I've just gone to colab.research.google.com. And then I can actually bring in a GitHub file. So what we'll do is we'll grab in our main GitHub repository, which was, where are we? So TFOD course. We can paste that link in. And then we're really interested in our training and detection notebook. So let's grab that. And then the nice thing about this notebook that I've set up is that you can sort of just walk through this notebook. Now, if you don't want to have to deal with all of the installation steps and all of that stuff that we had to do to get us up and running, Colab sort of gives you a nice alternative to that. Core thing you need to do is go to your runtime and change your runtime type to GPU. In this case, it looks like it's already selected. So we can hit GPU and hit save. And then what we're going to do is step through our notebook. So we're going to hit Shift Enter and run anyway. And this is going to start importing and creating our folder structures. So again, by running the first 4 cells, we should have our folder structure created. You can see we do. So TensorFlow, Workspace, annotations, images. Now, the one thing that you will need to do is upload your files, so specifically your images. So if we select our images folder, what we're going to do is upload the images that we just compressed. So we're going to go into where our archive is. So TensorFlow Object Detection, TFOD course, TensorFlow, Workspace, images, and then remember we had this archive. So let's upload that. So we've now got our archive.tar.gz file there. What we'll do is we'll copy that into our images folder. And then when we actually go through the rest of this notebook, so let's just hit Shift Enter. So if we keep going through, so this is going to clone our TensorFlow models repo, which should give us our files in here once that's done. And then if we go to our next cell, so now we're installing TensorFlow Object Detection. So this will take a little while. And so keep in mind, this is installing all of our dependencies to be able to leverage TensorFlow Object Detection. So that's looking promising at the moment. Looks like it's all installed. We can run our verification script, see if that's all good. So this is looking promising at the moment. Doesn't look like we've got any errors. And again, whenever you're running the verification script, got to check that it says okay. So in this case, we've got the all clear. So that's looking fine. Test importing object detection, no issues there. So we're good to go, right? So what we can now do is bring in our pre-trained model. So again, pretty standard. So this is going to give us our pre-trained model over here. We can then create our label map, create our TF records. So again, this is going to create our TF record. So if we go into our annotations, we've now got our test record and our train record created. We can then go into our, so what we'll do is we'll copy our pipeline config through. So we're just stepping through this notebook. So it doesn't look like we've got any errors so far. Update our config. So this should give us our custom config inside of our models, MySystemMobNet folder. So you can see it there. And then we can train the model. Now, the nice thing about training in Colab is that we can just run through and execute that command in the cell. So you can see that now I'm running that command, and all things holding equal without errors, we should get our model training kick off. Now, again, the key thing in here is that you won't be able to perform real-time object detection using your webcam. You can still do it using the image, so we'll test that out. We'll see what that looks like. So that's looking like it's running there without issues. And then again, we just need to wait for our loss metrics to show up. So that gives us a good indication that it's running successfully, no issues. Okay, and that's our first loss metric appearing. So you can see there that we've got our step, 100 per step, and we've got our loss metrics appearing. So that's a good indication that all is successful and it's running in Colab. So we can let that run and we'll come back, evaluate that model. load it from a checkpoint, and then run our detection from an image. But again, from here, you can sort of keep stepping through. If you wanted to, once you get to the freezing and conversion step, you can grab, so you can actually zip up and export everything inside of this workspace folder. So I wrote the code down here. So you could, if you actually wanted to grab everything, you could zip up your entire My SSD MobNet folder, bring it back down to your desktop, and run it from there as well. But again, this looks like it's all running pretty successfully. If we check our My SSD MobNet folder, you can see that we've got our checkpoint appearing there. So we've got checkpoint 1. Cool. Let's let that run and we'll be right back. Okay, so that's our model finished training. So you can see we got up to step 2000 right down here with a final loss of 0.247. Now what we can do is we can evaluate our model as well. So again, we can run it in cell. And ideally what we should see is our mean average precision and our mean or our average recall as well. So ideally this will pop up once we've got that calculated. And all we're really doing here is running the code under step 7, so evaluate the model. So this will appear as soon as we've got those detection metrics or those accuracy and evaluation metrics calculated. So again, similar to what we did inside of our command prompt, but now you're doing it inside of the cell inside of Colab. So that's looking promising. It's found our checkpoint 3, and in a second, looks like we've got our detection metrics. So again, this is our model, and this is our non-tuned model, right? So remember, we trained our tuned model for longer. We ran that for 3,000 steps. This was only 2,000 steps. So you can see our average precision in this case is 0.71, and our average recall is 0.715. Now, what we can do is we can also detect our model using an image. So we can run through our cells to load up our model. In this case, our latest checkpoint is checkpoint 3. So all we need to do is change our checkpoint to checkpoint 3 in this line here, which is checkpoint.restore. So this is going to load up checkpoint 3 into our notebook so we can actually leverage that. So if we run that cell, we actually need to stop our evaluation first. And then we should be able to continue onwards. And detect from an image. So in this case, we're going to be detecting from an image. So what happened there is our evaluation script is going to keep running and keep looking for a new checkpoint. So we actually need to force stop that in order to continue on with our cells. So in this case, I just hit stop to get that to stop. Now what we can do is we can load from our checkpoint. So what we really just did there is we changed our checkpoint.restore file, and we made sure that we're pointing through to the latest checkpoint. So in this case, it's going to be checkpoint 3, which is what we've got over there. So if we run that, that's all looking good. And then we can detect from an image. So remember, our image name needs to be a valid image inside of our images folder. So if we open up images and then test, you can see that we've got, let's make sure that we've actually got this file. So we have livelong 02534422. So let's take a look to see whether or not we've got that. Well, easy yet, we can just copy the name of this file. So let's grab this one. And we don't need a new code cell, so let's just paste the name of the file there. And then we should need to run these 2 cells to bring it. So this is going to bring in our dependencies. It's going to load up our category index. Again, same as what we did in our baseline notebook. And then if we run this cell, ideally we should be able to see our detection. So this is going to run using our object detection model and try to make a detection using that particular image that we've got over there. Perfect, and you can see it has in fact detected livelong. So you can see that there, again, you can make this image a little bit bigger if you wanted to. We could try a different image, so let's try a thumbs down. So if we copy that file name, and we pasted that over here, again, we can make another detection. And this should be thumbs down, which in fact it has detected by the looks of it. So you can see it's a little bit sketchy there or a little bit small, but you can see that it has in fact detected our object. So that gives you an idea of how to train on Colab. Now, again, if you wanted to convert or export all of this, I've actually got the code to export it down here. So what we can do is run this cell, and it will zip up and export your files. And if you wanted to, you could load that into Google Drive as well and export it, bring it back down locally and run it locally if you wanted to. But keep in mind, if you want to run it locally, you do need to install the Object Detection API to have that available locally. So that about wraps up training on Colab and really wraps up our part 7 of this course. The next part that we're going to be going through are our projects. Now, there's specifically 3 projects that we're going to go through reasonably quickly. So this just sort of gives you an idea as to where you can potentially take this object detection technology further, or might give you some ideas as to where you can apply it in your real life. So the first project that we're going to take a look at is how we can use different types of sensors, so specifically a microscope to be able to use or perform object detection. So we'll give that a try. I have noticed that it does get very, very close to the object. So we'll wait and see and take a look at performance there. Then we'll take a look at building a web app. So again, we're able to leverage the existing code base. We're just able to repurpose it to be able to build up a Tensorflow Js app, and I'll show you where to get the code for that. And then last but not least, we'll export our model and be able to perform some Raspberry Pi sentiment. So we'll just be trying to detect one class there, so whether or not I'm happy or not. So in this case, we're going to be going through each of these 3 projects, but starting off with Microscope Defect Detection, then Web App Directions, and then last but not least, our Raspberry Pi sentiment. Okay, so we're going to jump back into our notebooks. We can close Colab for now and close that. And again, let's just restart our notebook. So we're going to shut these down. And again, all things start. So say, for example, we're starting off with our Microscope Defect Detection. Now, this particular microscope that I'm actually working with is a USB microscope. So you can see it there, right? And I'll link to this in the description below if you want to test this out or take a look at it yourself. So think of this as just another camera. So right now I'm using a webcam to be able to perform object detection, but we could just as easily use a different sensor. Say, for example, you had a better or high resolution webcam or a slightly different webcam. You could definitely use that as well. Now, we're specifically going to be trying to train a model to detect defects in these little LEDs here. They're really, really small, so it might be a little bit difficult for you to see. But so you can see that this is a green LED and it's got a bent pin. This one is still a green LED, but this one doesn't have a bent pin. Got a red one as well. And again, you could do this on other stuff. So if you had like a printed circuit board, you could try that out as well. So I'm going to plug in this USB microscope and take a look at what this looks like. So you need to get it into focus a little bit. So we're going to write some code to be able to see the output of this webcam first before we commit to actually collecting images. So what we're going to do now is, again, we're going to close down our notebooks and we're sort of going to start from scratch. So we're still going to be working within our environment that we've already created because we've gone to so much effort to set this up. We've got our virtual environment. We've got all of our dependencies installed. We're first up going to start out by opening up our image collection notebook. And we're just going to create a new section just before capture images. And we'll call this, 4.x. So I'm just going to create a new markdown section. And I'm going to say this is testing microscope positioning. Cool. And then we'll convert this to a markdown cell. And then we're going to import OpenCV as our dependency and sort of just leave it at that for now. So what we'll do, actually, we should probably put this up. Let's put it up here. So we'll make it 1.x. So what we're going to try to do is we're going to try to read from our USB microscope to be able to at least get a feed, and then we'll position it, try to get some zooms appropriately, and then see what this looks like. I've never tested this before, so I wanted to see whether or not it's possible, what our results look like, and what it looks like to do object detection with different types of sensors. Okay, so the first thing that we're going to do is we've imported our dependencies from our image collection notebook. Now we're going to try to read in a feed from this particular microscope. So in order to do that, we first up need to get a feed. So we're going to create a new variable called cap equals cv2.video capture. And we're going to try out sensor 0 first. So remember, this is no different to this line down here. So we're just grabbing a video capture from our capture device. Then we're going to include a while loop. So while cap is opened. So So this is checking that our capture device feed is still available. So when you actually set up this capture, right, you can type in cap.read, and this is going to read the feed from your microscope. So what we can then do is extract the two variables that we get from that. So we can type in ret, frame, which again is no different to what we're doing when we're capturing the images from our webcam, which we did for our different gestures. So in this case, we're going to be trying to detect two different classes. So either a bent pin or not a bent pin. But we ideally want to position our microscope appropriately first, because I played around with it yesterday and it is a little bit temperamental in terms of focusing. So let's position it first and get it in the right spot. So we're going to write ret, frame, cap.read, and then we need to show our feed. So to do that, we can type in cv2.imshow, and then we name the name of our frame. So we're going to call this microscope feed. And then we are going to display our frame. So our frame that we actually get back from here is actually just an image, right? It's an image from our microscope. So that should give us our feed. Then we can copy this little bit over here. So this is these 4 lines of code. Let me actually explain that in a sec. Right, so these 4 lines of code, so this basically is what gives us our ability to sort of quit out of our feed and close that little Python window. And then cap.release is just best practice. So this allows us to release our capture device and destroy any of our OpenCV windows. So ideally, you want to run this after you close any CV2 web capture. And sometimes you might get your sensor hung up. So say, for example, it won't detect images anymore or might sort of freeze up. Running those 2 lines normally resolves a bunch of those problems. So let's go on ahead and test this out. So in this case, let's just double check. So so we're getting our capture. So cap equals cv2.video capture, and we're testing out device 1, and we're looping through. So while the capture is opened, then grab or read the frame, show it back to us, and then if we try to break out of it, then break out of it. So let's run this and see what happens. Okay, so what are we getting there? So cv2.imshow. So let's try another capture device. Okay, that's looking more positive now. All right, so this looks good. So I had to change the video capture device. So this capture device 0 is probably my current webcam that I'm actually streaming on. So we might need to change that. Now, right now, this looks kind of weird. So we're not actually seeing anything from our microscope feed, but that's because I'm just got it currently pointed to a piece of paper. So if I move this around, right? Let's move it there. So you can currently see like one of the LEDs. So if we bring that into focus a little bit more, nope, the other way. All right, cool. So we've now got one of the LEDs actually appearing. So I can move this around and you can currently see that we've got that actually appearing. So we've got a bent pin there. So you can see that it's definitely broken, or it's obviously not going to work if we try to plug it in. We can try putting in another LED. So in this case, we've got one that actually is working. But right now, you can sort of see that we're sort of going down the same path, right? So rather than having a particular or doing gesture-based detection, this time we're actually just going to be using a slightly different feed, but we're still grabbing pictures from a camera. So in this case, we're sort of good. So I've got the position based on my sheet of paper. So I'm doing it on a white background to ideally allow us to see this a little bit better. So we actually want to collect some images of our the different pins and whether or not they're broken or not. So I'm just going to put it back into position, and it's rolling away from me. There we go. Let's bring that a little bit closer. There you go. Nope, it still wants to roll. Okay, so I'm going to hold it there. Stay. Okay, so what we need to do now is actually collect a bunch of images of our particular LED. So if I bring that back into frame, I should have kept it in position. But so right now, this is pins. The pins are fine. We need to collect a bunch of images of different styles of pins. So again, this is probably going to be a little bit finicky. We need to obviously get these right into position in order to get the photos appropriate. But we'll test this out. Okay, so we've got our webcam position appropriate, or our microscope positioned appropriately. So we can quit out of that using Q. And what we probably need to do for this particular project is collect images for 2 particular classes. So really a bent pin and a non-bent pin. So we're going to create 2 different image types. So bent pin and I don't know, what should we call the other one? OK pin? Actually, we'll call it defective and non-defective. Defective pin, non-defective pin. So we're going to only collect two different classes this time. So defective pin and non-defective pin. And we'll try with, I don't know, 5 images again, and we'll give that a crack. So this is going to create 2 new sets of images. And again, when we go through and run our setup folders, so we can delete this, that's left over. So this is going to create new folders for our new image classes. So if we go into our images, we've now got a folder for defective pin and non-defective pin. We can actually delete these old ones. So live long, thank you, thumbs up, thumbs down. We don't need those anymore. So those are now all cleaned up. Now, what we also probably need to do is clean up what's inside of our test folder because we don't need those anymore. We're doing a new project. And we are now going to collect our images for our defective pins and our non-defective pins. So we've got the folders created. We can now go to our capture and we're going to test out video capture device 1 because that's the device that we had to grab up here to be able to grab the images of our pins. So let's run this and see how we go. Okay, we're getting our frame. Bring it back. Okay, so I've got it. We probably need to run this again. So right now I've got we had a picture of a non-defective pin. So let's stop this and go back into our collected images. So these are the OK pins. So we want to delete those because those are fine. They are effectively non-defective, but we had those images in defective. So we're going to put the images of our defective pin there first up. Let's just double check we've got the feed right. Okay, so that's looking fine. Let's actually position it this way. Right, so that looks okay. I'm just making sure we can get it in the frame appropriately. Okay, that's looking good. So let's just try to bring it in a little bit more. That looks good. There's the trick. So I move the paper, not the actual pin. Okay. Mastery at last. Okay, so what we're going to do now is collect images of our defective pin. Let's just do one at a time so that we can actually pause. And I'm just going to do it for a red one. We won't bother with the green ones for now. Let's do our defective pin. Oh, we need to stop this cell as well. So if we just jump back into here, hit Q, that's going to close it down. Okay, so what we're going to do is collect images of this defective pin, and I'm just going to move it around slightly, and we can probably increase the time that we want to sleep between frames. So let's give us a little bit more time, so 3 seconds. So this line here, which you can see that reads time.sleep, this is how long we actually sleep between each image capture. So right now it's set to 3 seconds. So if we run this, let's wait for our frame to pop up. So right now it's positioned. So ideally we should be getting appropriate images already. Cool. All right. So we can move it slightly. Okay. So that's done. So we've got our images for our defective pin. Let's do our non-defective pin. And remember, we're not collecting a whole bunch of images here. So this will be interesting to see what performance looks like. Let's just position it again. So we'll run this cell up here. And we've added a new cell there. So that looks like a typo. So let's just run that again. Okay, so we want to position it down. Okay, so that's looking okay. All right, so let's try that. Okay, and then we can quit that by hitting Q, just holding the sheet of paper as we're collecting. And what we need to do now is type in, this is going to be a non-defective pin that we're collecting. So we can set that label, and then we can run this. So this is going to collect images of our non-defective pin, or non-defective LED. But again, you could do this on a whole bunch of different use cases, right? So I'm doing it on LEDs and specific components, and we're just going to move it slightly each time. Okay, cool. So let's take a look at our images. All right, so we've got some defective pins here. Let's show our preview pane. So we've got defective pins. And if we go into our non-defective pins, looks like we've got non-defective pins. Cool. So again, now what we're going to do is go through our same process. So we're going to label our images. So we've got all of this installed. We are going to run our labeling line, which is this one down here. So this will open up label image. So let's run that. And again, we need to set up our label image path, which is this. Really, we should bring this down here. And again, if you've got any feedback for the code or the notebooks, or if you want any clarification, hit me up in the comments below. Join the Discord server. I'm more than happy to have a chat. So let's open up, I'll set our label image path, open up label image, and get to labeling. So we're going to open our directory. We're going to go into where our images are. So in this case, it's again in our workspace, images folder, collected images, and defective pin. So we're going to hit W, and we'll just do, let's just do this bit. This bit? Yeah, let's do that. So we're going to say this is a defective pin. Right, and then we're going to save. Save. So again, I'm hitting W, and I'm just labeling each one of these. Now, if it wasn't so finicky, I probably would have done a bunch of different positions, but the microscope is super sensitive, so we'll wait and see what performance looks like on this. I'm just going to label it, hit save. All right, and then we're going to open up our other directory. So again, same process. We're just using a different sensor. And this is going to be pretty consistent with most of the projects. So then we're going to label these non-defective pin. Save, and pay attention to your labels as per usual, because it is important. And I've got a feeling our model won't be generalized as much as possible, because right now we've only got our pins in one direction. So we'll see what that looks like. But again, you can always go through the performance tuning steps to get this to perform better. And we sort of went through that. So you add in images of different angles at different positions under different lighting conditions. That should help out. Okay. So those are our images labeled. So if we go through, so you can see that they've all saved, and we've got 5 of each class. So we're good to go there. Now, as per usual, we're going to copy our images into our training and testing folders. So we're going to grab the majority. So we'll only leave one for testing for each class. And we're going to paste these into our training folder. If we go back into our images, collected images, non-defective pin, we'll leave one. And again, back into there. And then the last one, we're going to put that into our testing folder. So cool. All right, so we are all set up now. So we've got our training images or testing images and our training images. So we should be able to now go through, again, our training pipeline. What we will do, however, is we're going to probably create a new folder for our custom object detection model, in this case for our project. So we'll call it pin detection or something along those lines. And we will do that by opening up our training and detection Jupyter notebook. And so our last model that we had was my SSD MobNet tuned. In this case, we're going to call it Microscope. And we are going to leave everything pretty much the same. We want to revert this back to our other model. So this right now is our custom model. We don't want to use that. So let's grab the link to our existing one, which is going to be this one here. Copy link address, and I'm going to paste that there. Really, this is sort of just making sure that we're resetting back to usual. So we've already got this model downloaded, so we don't need to download it again. But we could if we wanted to. All right, so we're going to import our operating system, set this up. go through our paths, create our file paths, and create those actual directories. So now if we go in, you can see we've got a folder for our microscope model. And then we're going to go through the rest. So again, we can skip step 1. We don't need to do that because we've already set up Tensorflow Object Detection and we've already cloned our pre-trained model, which is what this cell does. What we do need to do, however, is update our label map. So if you cast your minds back, when we set up our images, so if we go into Workspace, Images, Train. So we need to make sure we get the appropriate label. So it's going to be defective pin. And it will be, what was the name of that? Sorry, I've got to open up the actual annotation. And non-defective pin. So we're going to update these labels here. So again, this whole code base is really, really general purpose. So you could do a bunch of stuff with it. So we're just going to rename our labels. So defective pin. And I'm doing this under step 2 label map. So this first line here, again, we probably talked about it a while ago, but this first line is what sets up our labels. Then this is what creates our label map, which is what Tensorflow Object Detection API needs to actually train. Then we're going to set up our next label, non-defective pin. So we'll do that. And now if we go and open up that actual label map, which will be inside of TensorFlow, Workspace Annotations. Let's open this. You can see we've now got one class for defective pin and one class for non-defective pin. So we're good to go there. Now what we want to do is, again, we are going to create our TF record. So we don't need to run this cell here. This is what unarchives our images inside of Colab because we're not running on Colab. We're good to go. Don't need to run that. This cell actually clones our generate TF record script. So we can bring that in. It's not really good because it already is there. It's not going to clone it again. So we've got a conditional statement there that's going to prevent that happening. What we do need to run is this cell here. So this cell here is what creates our TF records. And remember, our TF records are what allow us to actually train our model. It's what our Tensorflow Object Detection API uses. So if we run that, fingers crossed, we effectively create our TF records. So it looks like no issues there. And then again, we're going to copy our model config to our training folder. So remember, we created a new training folder called Microscope. So if we run that, we should be able to go into our Microscope folder, which is in Models, Microscope. And you can see that we've got our pipeline there. We just need to update our config. So again, so that's our baseline. We make our updates. If we reload it, this is a cool thing, right? So you can actually reload that config by running this cell here. So config_util.getConfigs from_pipeline file, and then we're specifically going to load that up. Another thing that I had a thought about is if you'd like to actually see me write this code from scratch, please do let me know. I think it'll be a huge tutorial, but if you think it'd be useful to be able to learn how to actually do this, I'd love to hear your thoughts on this as well. Maybe we'll do a live stream. So in this case, that's looking good. So we've reset our classes, and if we scroll down, we've reset our label map and where our test.record file is. Let's go on ahead and train our model. So again, we're going to generate our training script under step 6. Which gives us this here. And we probably don't need to train for 3,000 steps. Let's do our regular 2,000. So then we'll copy this into a new command prompt. And again, same folder. So we can stick inside of this folder here. So the YouTube Tensorflow Object Detection TFOD course folder, and we've got our environment activated. We should be able to paste this in and kick off our training. So we'll kick this off and we'll be right back as soon as that's done. Alrighty, so our microscope object detection model has now finished training. So ideally, the end goal for this is when we load this up, we should be able to detect a bent pin and effectively, or a defective pin and a non-defective pin. So I'm interested to see how this goes because I've never tried this. So this will be really, really interesting. So let's go on ahead and do this now. So we'll just make sure our GPU is fully released because sometimes it can throw up a whole bunch of issues if it's not. Now, inside of our microscope folder, you can see we're up to checkpoint 4. So this is a little bit further than usual. So what we'll do is we will load in checkpoint 4. So that's looking good. And so let me just quickly give a recap on this notebook. So step 0 sets up your path. Step 1, or ideally point 1, is what's going to download your pre-trained models from TensorFlow Model Zoo and install TensorFlow. Step 2 is where we create our label map, so our different labels. Step 3 creates our TensorFlow records. 4 copies our pre-trained model config into our custom model config folder or into our custom model folder. Step 5 updates that config, and then step 6 trains, which is where we copy our command. Step 7 goes and evaluates that model. So this is purely optional, step 7. Step 8 is where we actually initially load our checkpoint. So if you get more checkpoints than checkpoint 4, which is what I wanted to call this out, you can change this number to detect or use an older model or use a newer model. You sort of world's your oyster there. So, and then step 9 is detecting from an image. Step 10, detect from your webcam. And then step 10, 11, 12 are going to be your exporting and freezing. Step 13 is your zip and export. So again, I sort of wanted to drive that point home, that there's a logical sequence to this. So to run through step 8, what we're going to do is run this import cell, which you can see here. And then we'll load our checkpoint. So we've set it to checkpoint 4. And then we can detect from an image. So let's try detecting from an image first before we mess around with the actual microscope. So we're going to grab the name of an image from our test folder. So we'll grab this defective pin, and we're just going to grab the name of that image and then paste it in here. All right, so all I did was I grabbed this particular image, I grabbed the name of that particular file, and then I've overridden what's in this cell here. So this is basically pointing to where our image actually is. So I'm just updating that. Then what we can do is run that import, which we just did then, set up our category index. And if you take a look at this category index, probably haven't talked about it much. This is just another representation of a label map. So we can close that, can bring in our image, and then ideally, fingers crossed, this should be able to detect whether or not it's defective or not defective. So now we're actually running the cell to detect. Oh my God, it actually detected it. How cool is that? So you can see that it's actually detected the fact that it's a defective pin. Now this is probably a gimme because I mean, they're sort of in the same position, but that is really, really cool what's possible there. Because this opens up a whole wide range of opportunity, right? Like you can now use different types of sensors. You can scan over different types of things. Let's grab another image. So what was the other one inside a test? So non-defective pin. So let's see if that works. So we're just going to update the name of the image to non-defective pin, run it again. Oh, and it's detected non-defective pin with super confidence. The bigger test, however, is if we try doing this on real time and see how it actually performs. So video capture 0. I think we actually need to go to video capture 1. So let's test that and see if that opens up. That's looking like it's working. Pretty cool. So that's detecting a non-defective pin. Even if I switch it the other way, it's still going pretty okay. Sweet, right? And this is all coming through that little microscope that I showed you. What if we did a defective one? Let's bring it into frame. Look at that. Where are we? Nope. So this is sort of the concern that I had with having the defective pin in a particular position. So you can see that it's definitely not performing as well with the defective pin, but you sort of get the idea, right? What's possible there. Nope, is it going to pick it up? So it doesn't like the defective pin, at least from the images. Okay, so it's actually picking, wait, it's picking that up as non-defective. What if we did a different color? Wonder if it's the lighting as well. Oh, this is me just playing around with defective pins and stuff. Okay. Just trying to get this into the center. There we go. Okay, so it had a little... So what we can actually do here, this is actually a good time to actually show you something. So if I quit out of this detection frame here actually has a bunch of parameters that you can choose to tune. Now, the two that I'm going to get you to pay most attention to are these down here. So these two lines, max boxes to draw and minimum score threshold, define what level of quality detections you're actually going to show. So right now I've got it set to reasonably high, right? So I'm not going to show anything that has a detection accuracy of less than 80%. But in this case, we're not able to pick up the defective pin. So what we might do is we might relax this constraint a little bit and drop it to 40%, for example. So if we run that again, okay, so now you can see that we're obviously getting a whole bunch of detections. So this is sort of what happens, right? So there's a bit of a trade-off as to whether or not you're going to be able to or want to show everything versus not show everything. So in this case, you can see that we're getting 60%. So what we might do is not drop it down so much to 4. Let's drop it to 60 and try that again. Okay, so we're now not getting anything. All right, so you can see there that it's detecting defective pin reasonably well. It's interesting that it's not actually doing the bend. It's still detecting that it's a defective pin, but it's not doing the bend. Interesting. So this is the green one. Let's try the red one. And keep in mind, we didn't train on a green image, on a green pin. The LED's rolling away. And so that's a non-defective pin. Let's try another green one, which is a non-defective. And keep in mind, when we trained at an angle, right? So this is going to be obviously skewed. So when I put it at an angle, for whatever reason, it thinks that that's a non-defective pin straight away. But if we change it the other way, you can see that we're getting some lower accuracy detections for whatever. It's detecting my thumb as a defective pin. They're pretty cool, right? Like, so you can start to see what's possible with this. So if I bring that into frame again, it's detecting my fingers as non-defective. Pretty cool. So let's throw in a bunch of them. Defective, and these are all sort of overlapping, right? So let me spread them out a little. So we're getting non-defective on that red one, which is appropriate. What about if we went to this green one, saying that's defective? So that might be an indication that we need to train a little bit more on that. Right? Spin this around. Okay, so you can see at that angle, it's detecting that it's non-defective. So that might be an indication, again, that we need to give it a couple of different angles. Let's try it. That's saying it's a non-defective when really it should be defective. And you can reduce the number of boxes that you're also going to draw as well. So in this case, I'm drawing a bunch. You can change that parameter again. Oh, we're losing our pins. Let's move it around. Pretty cool, right? So that shows you what's possible with a bunch of other different types of sensors. So again, you could train this, you could performance tune, you could get it better. So that sort of summarizes project number 1, being able to use different types of sensors for our object detection. So just to quickly summarize what we did, we went through our image collection notebook, we repositioned our microscope, so we wrote this custom code here to be able to make sure that we get our microscope positioned appropriately. We then defined our images that we wanted to collect, set up our new folders, captured our images, and then we labeled using LabelImg again. So again, pretty standard process. So you're always going to capture your images, label your objects, then train. Now, in our training, we sort of went pretty standard here. We didn't do anything too crazy. We just created a new folder called Microscope. That means that all of our microscope stuff is going to be stored inside of a folder called Microscope. Now, again, for our new projects, we're going to just create a new folder, or for our next couple of projects, we're just going to create another folder and build up from that. That brings us to project number 2. So in this case, our next model is going to be a web app for direction. So what we're ideally going to try to do is build a object detection model that allows us to detect up, down, left, and right. Then what we'll do is we'll use a little bit more of the conversion code to export this out to Tensorflow Js. And I'm going to show you how to actually create a web app like what you can see on the screen. So that's actually running in a browser at the moment. So let's go back to our Jupyter notebook. And again, we're going to start as per usual. This is sort of what I wanted to drive home. So whenever regardless of what you're building, you're sort of going to be going through the same process. So you're going to collect your images, you're going to label, then you're going to do whatever exporting you want, or you're going to run real-time detection. So here we're going to go back into our image collection code. And again, we've already got our imports done. We don't need to retest, or actually we should probably retest to see, because I've gone and unplugged the microscope now and I've plugged in a webcam. So let's see if that's working. Okay, that doesn't look like it's happy. Let's try video capture device 1. Plugged it in, looks like it's okay. All right, cool. So that's our webcam. So I just had to change the video capture device. So we're back to video capture device 1. So if I move this way, it's fine. If I move this way, so it looks like I'm in front of the camera. So what we're going to do for this particular model is we're going to be detecting, let's get back in front of the mic, is we're going to be detecting up, down, left, right. So ideally, we should be able to detect those inside of our web app. Now, the beauty of doing this web app is that you could go and deploy this as your own website later on and have users be able to actually use that. So now this is going to take a little bit of JavaScript skill, but it's not a whole heap. And we're also going to need to upload some files. But again, I'm going to walk you through this. And all the code for this is actually available inside of the GitHub repository. So now what we're going to be doing is we'll be combining the code from our TensorFlow Object Detection course and the code from our TensorFlow Object Detection app GitHub repository to be able to load this up. So let's go ahead and do this. So I'm going to quit out of this. So we've got the right feed, and we're just going to change our video capture device back to 0 down here to make sure we've got the right camera. And then what we need to do is collect images of left, right, up, and down. So we're going to reset our label. So left, right, up, and down. Okay. So now rather than collecting thumbs up or thumbs down or live long or whatever, or even the defective and non-defective pins, we're going to be just defining direction. So left, right, up, and down. And we'll try with different hands and whatnot. So what we can now do is run this particular cell and we can test our labels. I don't know why I deleted that. And you can see that we've got our correct labels. So left, right, up, and down. Again, we're going to set up our folder. So if we go into our images, we again can delete everything that's in there. So if we go into TensorFlow, Workspace, Images, and Collected Images. So we've got defective and non-defective pin. So we can get rid of those. We don't need them anymore. And what we're going to do now is create our folders for left, right, up, and down. So if we do that and run through the steps under step 3, this should create our down, left, right, up, and down folders. And then what we can do is capture our images as per usual. So again, we probably don't need 3 seconds break, so we can change that. So again, we're just going to point in our different directions, capture our different images and labels. So let's go on ahead and kick things off. So we should be going left, right, up, and down. So let's do it. Again, we should get our little pop-up. So we're going to be going left first. I have to use my mouse with my left hand. Okay, so left. Then right. Again, move your hand around. I probably should have collected different images when I collected left. Right now it's covered, all my face is behind it, so I'm just going to move my hand around. And we should be up to up, right? So up. Probably do both hands to help generalize. And then down. And again, we'll try to use a different hand. Oh, that's a dual hand. Cool. All right. So those are our images collected. So we can go and check those out. So if we go into YouTube, TensorFlow Object Detection, TFOD course, TensorFlow, Workspace, Images, collected images. So we've now got images inside of down, left, right, and up. So that's looking good. Okay, now what we need to do is label as per usual. So again, we need to define our label image path, which we had already. And we need to open up LabelImg because keep in mind, we've already got it installed. So we're just going to open it up. So I'm going to go into my image path or image paths, and we're going to start labeling. So we're going to go into collected images and down, and then open those up. So that's down. And again, paying attention to the case on our images. Beautiful. Do the next one. Now again, if we get lackluster performance, we can always come back and performance tune as well. So we're going to do down on that one. Beautiful. All right, so that's down done. Let's grab the next one. So left. This probably needs to be flipped, but that's fine. Behind the mic, yeah, that'll be an interesting one. And we'll keep on going. So left, so down had okay images. Left, I'm a little concerned because they're all kind of in front of my face. So again, we might not get the best performance on here, but again, it's all about testing and training and trying it out. So left, then we'll go left again. Cool, so that's all of them done. We can check our labels. All right, so we're good there. Then we'll go into right. Let's do that. I'm going to change our label again, save. Right, save. The next one. Save that. Save that. And then last one over here. Okay, check our labels. Beautiful. Alrighty, last one up. And let's do it. Okay, and then last one. And keep in mind, we're only doing 5 images per object or per class at the moment, but you could definitely do more. I normally do 5, 10 to 20 when I'm just prototyping. And obviously, if I'm labeling 20 images in this tutorial, it's going to take quite a while. So 5 is fine, but play around, add more images, add less images. And remember, you can collect a varying number of images just by changing this line over here. So number underscore images. So right now I've got it set to 5. We could set it to 10, 20, 30, 40, 50, 100 if you really wanted to. Okay, so on that note, we have now gone and labeled our images. So if we go into our images folder again, and again, it's probably getting repetitive now, but it sort of gives you an idea of, again, the process is going to be the same. So we've got our images in down and our annotations for down and left, right, and then up. And so what we'll do is we'll clear out our test folder of our pin stuff. And now what we'll do is we'll go to our collected images. And again, we're going to do the same thing. So we're going to cut them out and paste them into a training and testing split. So we've done down. Let's do left. We're going to paste. So at the moment, I'm pasting 4 of the available images inside of the training folder. So what would that be? An 80-20 split. Play around if you want to include more or less. Again, sort of trial and error a little bit here. And data science, and specifically this being deep learning and data science, it is an iterative process. So you can go through an experiment. You don't need to get it perfectly right the first time. It's more than okay if you play around, try different things out. Okay, so we've got our images there. What we want to do now is go and grab the rest and throw it inside of test. So we're going to have 1 image per class in our test folder. I'm just going to keep doing this. And again, this is just copying and pasting, right? So you could potentially automate this if you use the OS library and just randomly choose which files to place into train and test. But in this case, I just find it easier to do it manually because then I've got a little bit more control over it. Okay, so where are we? So we've now got our images inside of test. So we've got 4 images. So left, so down, what is that? Left, right, and up. And again, inside of train, we've got a whole heap more. We're going to go through our standard process now. So we're going to go through back into our training folder. And again, we are going to stop LabelImg because you can see it's still running up there and we've got our little star. So we can stop that. Jump into our training and detection folder. And what we'll do is we'll just we can actually just clear all of our stuff here so we can make sure that we are importing. So we're going to import our operating system. We're going to change our folder name. So we're going to call this one directions. And then, so this will effectively, so remember we had our my SSD mobnet folder, my SSD mobnet tune folder. We also had our microscope folder. Now we're going to have one called directions. So if we run this and run this and this and this should create our new file paths. We're going to YouTube, Tensorflow Object Detection, TFOD, Tensorflow Workspace, where I have models. You can see we've now got a folder called directions, and this is going to be the current model that we build. And then again, we can skip step 1 because we've already set up our environment. We are in our virtual environment already, so we don't need to do anything magic there. What we do need to do, as per usual, is update our label map. So remember, we had left, right, up, and down, and they were all capitalized. So we're going to create those new labels. So left, right, and then we'll create 2 new items, up and down. And again, just double check. You need to make sure these IDs are unique as well. So this should be 3 and 4. Another good thing to note. So let me just quickly show you. So again, we want to check our images. So make sure that we've got the right case. So if we go into train, let's take a look at down. Again, that's capitalized. Let's look at left. Again, that's the actual image. Again, left is capitalized here, so you can see that. Let's do right. So I'm just double checking because obviously checking up front is going to save you a lot of time down the track when you're trying to debug errors if they do come up, and up is capitalized as well. So we're good there. We are good. So we've got left, right, up, and down. We've got unique identifiers for each one of them. So 1, 2, 3, and 4. I think we're good to go. So let's go and run this annotation, which is fine. So that's going to update our label map, create our TF record. So again, we can skip this cell because it's only for Colab. So we can import our new generate TF record script. Again, we've got it already, so it's going to skip it. We already had PyTZ installed, so we can actually delete that cell. We don't need that anymore. And then we can run our TF record generation. So again, ideally, this should successfully create our train record and our test record. We're going to copy our model config to our custom folder again, which will go into our directions folder. And then we're going to go on ahead and update our config. So if we re-import it in this cell, you can see that in fact, we've gone and updated. It looks like we've got the number of classes equals to 4. So again, this is updated. If we scroll on down, again, we are picking up our correct folders. This is all looking good. Okay, so again, now what we're going to do is train our model. So we're going to run our command to generate our training script. Again, print it out. We're going to copy this. We are going to create a new command prompt. And again, we've already got this one. So this was from our, what was this from? The defective, non-defective pin example or project. And we're going to run our training code. So if we paste that in, this should kick things off and it should kick off our training. So again, we'll be right back as soon as this is done. Okay, so that is our model train. So this is our directions model and eventually what we're going to be plugging into our web app. So you can see we went all the way up to step 2000 and ended up with a loss of 0.299. Now what we'll do is we'll test this out inside of our Jupyter Notebook as per usual. So again, let's take a look at our checkpoint. So if we go into our workspace, models, and then directions, so you can see we're now up to checkpoint 3. This is a key thing to take a look at, guys. So if you're training your model, don't always assume you're going to be at checkpoint 4 after 2,000 steps or checkpoint 3. It could vary. So you always want to make sure you pull down the one with the highest index. So ideally, in this case, it's going to be checkpoint 3. So there's checkpoint 1, 2, and 3. So we want checkpoint 3. In this case, that's exactly what we're going to do. So remember for our, our pin or defective pin detection, what we had, the latest model that we had was checkpoint 4. So we updated it to that there. But what we're going to do is we're going to do checkpoint.restore, and we're going to specifically pass through checkpoint 3 in this case. Then what we'll do is we'll import this as per usual. So all of our dependencies for step 8. Load up checkpoint 3. And again, we're going to skip right through to real-time detections because that's my favorite. We're going to make sure that we set our video capture device back to 0 because remember, video capture device 1 was for our microscope. Number 0 was for our webcam. So let's try this out. So in this case, I'm just going to hit run and we'll bump up our minimum score threshold back up to, let's say 90% and give that a run. So let's run that. We need to import CV2, which is part of this cell. We're probably going to need our category index, and we don't need our image path. So let's do that. Let's see. Hopefully we should get a little pop-up, and all things holding equal, we should get some real-time detections. So I can see my webcam's just activated. So sometimes it takes a little bit of time to start. Close Task Manager. Okay, so that's open. So up, looks like it's detecting appropriately. Down, looks like it only wanted, oh no, that's fine. So down, left, nope, that should be right. Okay, so we've got an issue with left and right. Oh, so right works well over there. But if I bring it here, so this is what I was saying. So remember when we were collecting our images, I said that having all of those images across my face might cause an issue. Because right now it's saying that both left and right over my face is left. But if I put right over here in the green, it's okay. So it's saying right, as long as it's not on my face, is going to be right. Now left over my face, okay. All right, so we might want to do a little bit more performance tuning on there, but you can sort of see how you might go about building your detection model. So what I'd actually do in order to solve this is I'd include more images of me purely pointing, what's this? This is left. So in this case, that left is fine. Left is okay if I do it over my face, and if I always did right over my shoulder, then I'd be okay. But in this case, if I did it like this, you can see it's maybe not performing as well. But you sort of get the idea, right? So you can go and performance tune this, make it better, improve that model accuracy. So we've got up working fine, down working fine. We can do it with that other hand. Okay, so other hand, we might need to add in a little bit more tuning there. So up is okay, down with that hand is not okay. But you can start to see this is how you might evaluate your model, and you'd add in additional images of the particular classes that aren't performing so well. So that's sort of how you go about that performance tuning. But it doesn't stop there for this particular model. We are going to take this one step further. So I'm going to quit out of this particular detection, and we are going to freeze our graph this time. So we're going to run through step 10 and freeze our graph. And so we'll go ahead and run that. And we're also going to run through everything in step 11 and convert to Tensorflow Js as well. So this should do two things. So inside of our export, once our frozen graph is done, we'll get an export here, and then we'll also get a Tensorflow Js export. And then what we're going to do is we're actually going to build up this app. So to do that, we've got to do a couple of key things. So namely, what we need to do is go to IBM Cloud. In this case, we're using IBM Cloud to host our model. And we specifically want to go to cloud.ibm.com/catalog. What we need is Cloud Object Store. And so I'm just going to log in. So what you'll need to do is, if you're doing this for the first time, you'll either need to log in or sign up. So sign up if you haven't signed up before. And you can just plug in your details. And again, this is all free. So you can run this for free at the moment based on your model. So what I'm going to do is I'm going to log in. And if you actually take a look at the steps inside of the GitHub repository, so github.com/knickknocknack/TFOD app, this is actually going to walk you through each of these steps. So if you maybe get a little bit lost as to where I'm going through, then by all means do check that out. But effectively, we're going to be following the steps that you can see there. Okay, so let's actually do this one step at a time. So let's make sure that our exports work. So it looks like our frozen graph has been generated. So let's take a look at that. So if we go to YouTube, TensorFlow Object Detection, TFOD course, TensorFlow, workspace models, and we look at directions. Inside of export, we've now got our frozen graph. And if we take a look at TFJS export, we've got that done as well. So we are in good shape. Now, let's go back to our TensorFlow Object Detection app component and see what we need to do. So first up, what it's saying is we need to clone this repository. So let's go on ahead and do that. And so if we copy this link here, and again, the link to this, all of this stuff is going to be available in the description below. So by all means, do check it out there. And if you need anything else, by all means, hit me up in the comments. So we are going to open up our new command prompt. And what I'm going to do now is I'm going to cd out of my TFOD course, which brings me here. Actually, we should just probably create a new command prompt for this. So we're going to go into D drive, cd YouTube, go into our TensorFlow Object Detection repository. Typing is a bit of a shocker. All right, so inside of that folder, we've got TensorFlow Object Detection course. And then if we go into that TensorFlow Object Detection course, that's our root repository for where we've been doing everything so far. So you can see, if I type in dir, if you're working on a Linux, I'm typing in dir, it's going to be ls if you're on a Linux machine. So that's all of our baseline root dependencies. So image collection and our training and detection Jupyter Notebook is in there. So we're going to jump back out of that. And what we're going to do is we're going to clone that repository that we were just looking at. So this one over here, which is the TensorFlow Object Detection React app. So this is using a JavaScript web development library called React, or web development architecture called React. And it's just a really good, pretty sort of stable library. It looks really similar to HTML, so if you've ever done any HTML. But you don't actually need to write anything. That's the beauty of this. So I've pre-written it all. You should be able to pick it up and go. So I'm going to clone this repository. What we'll do is type in git clone that. And then what I'm going to do is I'm going to go into that folder, so cd, and it's going to be called TFOD app. And then let's take a look at that. So we've got all of our stuff there. Then what we'll do is we'll open this up inside of a code editor. So I'm going to open it up in VS Code. So inside of here, there is a bunch of stuff that you can take a look at. So there's a cause config, more on that later, package.json. You don't really need to worry about too much of this apart from this line here inside of the app.js file. But I will come to that and sort of explain what we need to do. So let's go back to our walkthrough steps and do that. The next thing that we need to do is install Node. So Node.js is a server package or basically a server runtime that we can use for running our React app. So if you haven't got this installed, just go to nodejs.org. And again, the link is available inside of the GitHub repo. Download it and install it, and you should be good to go. Then the next thing that we want to do is install our app dependency. So under step 3, we're going to go on ahead and do that. So if we go back, what I'm going to do is I'm just going to open up a new terminal inside of VS Code. And what we're going to do here is we are going to type in the following command. So npm install. So think of npm as the package manager or the equivalent of pip, but for JavaScript in this case. There's a bunch of others or resource managers, but in this case, we're going to be using npm. So an npm comes when you install Node. So keep that in mind. You need to have Node installed in order for this to work. So we're going to type in npm install, and I'm just going to bring that up just to make sure my head isn't covering it, and hit enter. So this is going to install all of the dependencies for our React app that we're going to need. And this might take a little while, so let's let that run, and then we'll be right back. Okay, so those look like all of our dependencies are now installed, and you can tell based on the fact that we've now got this node modules file. Now, this is going to be using Tensorflow Js in the background, so it's all configured. You really just need to keep going through the different steps that we've got inside of our GitHub repo. So in this case, we've done steps 1, we've cloned the repo, we've installed Node. I've already got it installed, but again, I'm showing you sort of where to go to do that. the next thing that we need to do is actually create a new free object storage repository on IBM Cloud. So to do that, we're going to hit this link. We should do this in a separate link. So we'll open it in a new tab. And again, this is that place that I was sort of referring you to. So in this case, we can create a new cloud object storage and just hit light and then hit create. In this case, I've already got one created. So all you need to do is hit light and then hit create down here. And then what you can do is you can go ahead and open it up. So if I go and open up my instance, I'll show you what it looks like. So once you've got your cloud object storage repository made available, it's going to look a little bit like this. Now, what you want to do from here is create a bucket. So to do that, which is effectively what we are doing in step 5. So assume we've already gone and created that cloud object storage bucket. So what we'll do is we'll create a bucket now, which is step 5. So we'll hit create a bucket or create bucket. And then what we're going to do is just hit, I think we're going to hit customize your bucket. And we'll name our bucket. So what we're going to do is we're going to name this, pay attention to this name because you'll need it later on. So we're going to call it directions TFOD. That sounds good. Again, you can name it whatever you want. You just make sure you keep note of that particular name. And then we are going to select our location. So I'm going to choose AUCID, but you could choose a bunch of different regions to host this in. And then that's about it. Then we can skip all the way down to the bottom and hit create bucket. And so this will spin for a little while. And we should be good. Okay. So that is step 5 now, or half done. So we've created the bucket. We need to store the model.json file and the .bin files in the bucket. So these were the files that we created. Let me minimize this and this and this. So these were the files that were created when we went and ran our Tensorflow Js export. So this line over here is what went and created those particular files. Now, if you go into the folder called TFJS export, all of the files that you're going to need to upload are in there. So group 1 - shard 1 of 3, all of these. So you need to upload all of these into your bucket. To do this, we just go back to our bucket, hit upload, and then we can select this little region over here to actually upload our file. So we're going to click into that, go into our repository. So YouTube, Tensorflow Object Detection, TFOD course, TensorFlow workspace, and then where our models. And then we're going to go into our directions folder. And then we want our TFJS export. And we're just going to select all of that and hit open. And that's going to upload our folders. Then what we need to do to actually go on ahead and upload, got a feeling my head is going to be blocking that, so I'll move out of the way. We just need to hit upload. And that will upload our files into there. And then there's 2 things that we need to do in order to get this all good and running. Okay, so that's looking like it is working fine. So we can go on ahead and close that. Then what I want you to do is grab or select this model.json file. Oh, it hasn't been generated yet. So we'll come back to that. So we're then going to go on to our next step, which is enable a public access policy. So this is step 6 over here. So to do that, we can close this. And on the left-hand side, you're going to see this button over here called access policies. So we can select that. And what we're effectively doing is we're hosting our model here. So this is going to allow us to actually host our model and leverage it from pretty much anywhere in the world. So we need to do 2 specific things. We need to put our model in a bucket, and then we need to make it available to the World Wide Web so we can reach it from our app. So right now we've got it in our bucket, but right now we can't actually access it from our app. So we're going to enable public access. So once you've hit access policies, go on over to public access and then choose, so leave it as access group public access, and then leave the role as content reader and just hit create access policy. And then it's going to give you a warning because now it's going to be publicly available. Hit enable. And that is our access group policy created. So then what we want to do is actually go back and grab the URL to this particular model.json file. So now that you've created the public or enabled public access, you should be able to grab this object public URL over here. So I'm just going to copy that. And what we'll do is we'll go over into our app that we created, which is this over here. So what we clone down. And in order to use that particular line that I just got you to create, you just need to go inside of, so say this is your main app folder. What you're going to need to do is go into source, app.js, and if you go to line 17, or at the moment it's line 17, but if you just search for the line that says const net equals await tf load graph model. So this is actually going to load our React or load our Tensorflow JS model into our web app. So if I minimize this, it looks like that at the moment. That's an existing one I tested. So we're just going to paste our new link over there and hit save. So we're good for now. So there's going to be a few other things that we need to update to get this to run. Now, namely, we need to enable something called cross-origin resource sharing. So in order to do this, we need to run through a couple of key commands. And in order to actually do that, we need to have the IBM Cloud Object Store CLI installed. So to do that, you can type in Cloud Object Storage CLI installation. And this installation over here is going to walk you through how to actually get up and running. So you're going to need to install the IBM Cloud CLI first, and then the Cloud Object Storage CLI. So again, I've got a full-blown tutorial on how to install this, but if you run through the installation steps on here, it's going to walk you through how to do this. Now, if we go through, let's actually take a look. So if we go to IBM Cloud CLI install, so this is the first one. So we've got to do the IBM Cloud CLI install first up. So to do this, we can use a browser to access the official IBM Cloud CLI release GitHub repository and select the installer of your OS to begin the download. So let's select this. And you can see there's a bunch of different installers. So you can use Mac OS, Windows 64-bit, Windows 32-bit. So we'll do Windows 64. And you can see it's downloaded. Let's run this, hit yes. So it's going to perform an upgrade. So I've already got it installed, so it's just going to upgrade. So let's let it install. And so you need this for the next step. So this is actually going to be what allows us to, this is going to allow us to enable something called cross-origin resource sharing. But I'll explain this a little bit more in a second. And then what we want to do is install the IBM Cloud Object Storage CLI. So I'm going to show you how to do this. So you actually do this through the IBM Cloud CLI. And CLI just stands for command line interface. So it's basically, it allows you to run it through a command line, right? So to do this next step, what we need to do is run this command here. So I'm going to show you how to do this. So first up, what you need to do is log into IBM Cloud. So I'm just going to clear this. So to do that, you can just type in IBM Cloud, login. And by default, as soon as you hit login, it's going to ask you to pass through your email and your password. And these are going to be the same details that you passed through when you went and created your bucket. So when you created your bucket, right up here, I was sort of saying that you would have had to either hit login or sign up. When you hit sign up, you would have passed through your email and passed through your password. So the details that you put here are going to be the same details in this particular case. So you pass through your email and your password. So I'm going to go ahead and log in. Okay, so I've now gone ahead and logged in. So I just passed through my email and my password. I did it slightly different because I've got a different account, but that's fine. You just pass through your email and your password and you'd be able to log in. Now, what we need to do is install the IBM Cloud Storage CLI. So to do this, we just copy this command here and paste it. And so this is going to go on ahead and install that CLI. So we can just hit yes. And we should be good to go. Cool, so that's now done. So we can clear this to give us a little bit more space. And then if we go back to our Tensorflow Object Detection repository or Tensorflow Object Detection app repository, that is now step 7 done. So we installed the IBM Cloud CLI and we installed the Cloud Object Storage plugin. Now what we can do is we can just run this command here. So what you need to do is change one single thing, and that is the name of the bucket. So the full command is going to be, let me just zoom out a little, is going to be IBM Cloud COS, so Cloud Object Store. That's the Cloud Object Storage Service, which you saw over here. Bucket dash cause dash put dash dash bucket. So this is the name. In this case, my old bucket name was called live long because I was doing a live long detection. then --cause-configuration, and then we pass through the name of the configuration file. But I've already got that available for you, so you should be able to work with that reasonably easily. Not reasonably easily. You won't need to make any updates to that or write your own configuration. So I'm going to copy this and we're going to update this. I'll show you how to update it. So let's jump back into our app. So over here, just jump into the README for now. And I'm just going to paste this command. Let's just paste it in here. So what we need to do is namely replace this bucket name with the name of our bucket name. So if we go back, remember we created the name of our bucket. In this case, it was called directions TFOD. So we can copy this and then just replace that there. And then in order to run this command line, so you obviously need to be logged into the IBM Cloud CLI, which is what we just did. You need to be in the top level repository or the top level folder of our TFOD app. So in this case, we've actually got this file called cause-config. This is going to do what we need it, or this is effectively what's going to enable cause for us. Now, cause stands for cross-origin resource sharing. So it basically means that our web app can access a URL from somewhere else. So namely, you don't have this enabled because you don't want your web app to be accessing a whole bunch of stuff. And namely, we're locking down the buckets because we don't want them to be accessible from anywhere. But in this case, we do because we want our app to be able to get to it. So we're going to enable it, right? And then in order to do that, we're going to be running this command. So this is going to be going to our Cloud Object Storage Service. It's going to put our cause policy, which is what we've got in this cause config file. And this is part of the clone repository. So you don't need to create anything from here. All you really need to do is log into IBM Cloud and then just change, or whatever the name of the bucket that you created was, you need to replace that here. So in this case, it was live long before. We're going to paste in the name of our bucket, which is directions TFOD. So paste that there. And then what we're going to do is we're going to run this inside of our command line or terminal. So in this case, I'm running inside of Windows, so it's brought up a PowerShell terminal. But if you're doing this on a Mac, you might be doing it inside of a terminal, which is called terminal or bash terminal. So we're going to run that command. So let's just make sure we've got that cause config file. We do, so we should be good to go. So let's clear this, run that command. And it looks like no issues there. So it said, okay, successfully set cause configuration on bucket directions TFOD. So we are looking good now. Now, what we need to do is go through the rest of our steps. So step 9 is update the following line with the link to your model URL. So we've actually already done this, right? So remember, we went into app.js and we actually already pasted the name to our custom model.json file. And this is what we uploaded into our bucket over here. So this model.json file is our Tensorflow JS model, and it's going to be what allows us to run our web app using our model. So that step 9 is now done. Step 10 is update the label map inside of utilities.js with your labels. So what we can do is we can go into utilities.js over here. And all we really need to do is update this label map up there. So we need to update it for what names or what our labels actually are and the colors that we want them to represent. So in this case, we're going to go back to our Jupyter Notebook. And remember, our labels were right up here. So remember, we set up these labels. So left, right, up, down. So we're just going to do the exact same thing here. So if we go back into our app, so left, right, up, down, and save that. So you can add in more if you wanted to. So you can add in additional labels, you can add in additional colors, and you can update this based on your specific app. In this case, we're just updating it for our different directional models. And then make sure you hit save. So that should be it in terms of all the stuff that we need to do. So we've now gone and done step 10. Now step 11 is just starting the app. So to do that, we'll run npm start. Let's try this out. So again, make sure you're in the root directory, so TFOD app. And then what we can do is type in npm start, and all things holding equal, this should work. So let's wait and see. So this will automatically open up your browser to the link where our model is actually running, and it should access your webcam. Now it'll take a little while to start up and compile, but then you should be able to test it out. So let's give that a second, and then we'll take a look at our results. Okay, so it looks like our React app has started, and you can see that we've got our camera available. So if we take a look, it doesn't look like it is detecting. Now, if you get errors like this and you're not actually getting detections, I want to show you how to actually debug this. So in this particular app, from line 50 onwards, you're actually getting your detection. So this line here, so line 50, so const obj equals await net.execute async expanded, and you can see how I actually built this up. If you want to see the full tutorial for how I actually wrote this, again, I've got the code available, and I can more than happy to share that with you. If you're getting errors and it's not working, so this is the way that I sort of normally process through this. First up, what I'll do is I'll change the confidence metric. And in this case, we've got our confidence metric available through this line here on line 61. So let me just check. Yep, should be line 61. So we can change this number here. So right now it's set to 90%. Let's just jump out of that. So it's set to 90%. So we can change that and drop it down. So let's drop it to 40% and see if we get any detections. Nope. Okay, this is just me pointing at myself. Then the next thing to check is sometimes Tensorflow Js will change the order of objects from the converted model. So in this case, what we actually do is we expect the boxes to be the 4th item in the detection result array. We expect the classes to be the 5th item, and we expect the scores to be the 6th item, but it's not always the case. So if we actually type in console.log, this is the equivalent of print in Python. And if we type in await, and then if we go through each one of these objects in the object array, we can actually determine what is what. So if we type in object 0, this is going to print out the first object. So if we take a look at that, and let's just bring this side by side and hit inspect. So this is going to allow us to see what object is what. So you can see here that we've definitely got something in there, and it looks like it's an array, and each array has 5 values. So that is not our boxes. So let's try object 1. And so this is sort of how to work out where your objects actually are when you go to deploy this app. So what you're looking for, and this is a slightly different one, so it's not that one. Oh, actually it might be. So this looks like, so this is the non-normalized result. So right now you can see that we're getting our boxes, but they've got negatives in them. You don't want that one. So let's try object 2. And all I'm doing is I'm changing the number over here. So you can see I'm changing that. So let's take a look at this. So this is, okay, so this is our classes. So this is what we do need. So you can see here that we've got 1, 2, 3, 4. So this represents the different classes that are available for our particular app. So what I'm going to do is I'm going to change this line here. So line 55, which has our classes, we're going to change that to object 2, hit save. So now we've at least got our classes placed appropriately, and then we're going to go through our next value. So we want to check what's in object 3 or position 3 in our array or our results array. And what's this? So this looks like non-post-process box classes. So you can see here that these are very low numbers. So if we actually tried to use these for our boxes, well, I'll actually give you an example, right? So this is object 3. So if we set this to our boxes, let's take a look. So it's getting detections, but let's wait for it to run. But you can see that it's detecting all the classes in the top corner. So it's really, really small. So if you set that value to your boxes, it's not really going to work. So let's try object 4, see what that is. And so it looks like we've got 100. That's just the count of objects that have been detected. Let's try object 5. This is looking promising. Array 100. Okay, so this might actually, yeah, so this one is, or this particular set of arrays is our boxes. So it should look something like this. There should be a number between 0 and ideally 1. So I believe it's X. I can actually tell you correctly. So these values represent your Y value, your X value, your height, and your width. So in this case, you've got all of your box values. So this is what you'd expect your box value to look like. So it's a bunch of numbers between 0 and 1. So there shouldn't be any negative values in there. If it is, it's the, I believe it's the non-pre or non-post-process value. So you don't actually want those. So what we're going to do is we're going to set the value of the boxes array, so line 54, equal to 5. So let's just minimize this. right? So now we should be drawing our boxes correctly. Oh, and we've set our confidence metric really, really low. So let's bump that up because right now it's losing the plot. So we're going to set that back up to 90. So we're at least getting detections now. Have we saved that? Oh, we haven't changed our scores. So we've got to find where our scores are first as well. So let's go and change that for now. So let's zoom out a little bit there. Right now it's gone a little crazy. So let's see what object 6 is. This looks like it's just, all right, so it's not that. So this, I believe, is an index value. So we don't want that. Let's try object 7. Let's see what these values are. Okay, these are our confidence scores. So they should be a value between 0 and 1. So I believe they're already sorted as well. So the highest confidence is going to be the top value. So what we need to do is just set this number equal to 7. Let's do that, and we should have resolved it now. So again, you just got to work through it. And all right, so if we take a look, beautiful. So now we're working. So you might need to change this around depending on what the results of your object array come out as. So again, but that sort of shows you how to sort it through. So your boxes are going to be a value. You should have a number of arrays, and each one of those arrays are going to have 4 values between 0 and 1. So those represent your coordinates. Your classes are just going to be standard integers. So it's going to be 1, 2, 3, and 4, or the number of different objects that you've got in your model. And your scores are going to be the sorted array with the highest confidence value at the top. Now let's go ahead and test this out, right? So we've actually gone and done quite a fair bit here. So we can minimize this, expand it out, and if we take a look, we're accurately detecting up. We go down, we're getting down. It looks like it's okay. The coordinates might be a little bit off. That's a bit better. And then left, right, and left. So left over my face, but anywhere else it's detecting right. So, and then we're getting right over here. And again, reasonable confidence metrics. But that sort of shows you what's possible, right? Like you could do so much with this. You could build apps, you could build directional apps, you could do sentiment analysis via the web. Again, there's a whole bunch of ideas. So if you think of anything awesome, let me know. I'd love to hear your ideas. Now, you can also change the colors of the different labels. So in this case, you can just change it by changing the color attached to each different class. But on that note, that is project 2 wrapped up. So we've now gone and taken a raw object detection model. We collected our images, again, using our image collection script. We changed it from left, right, up, and down. And again, the performance on left and right wasn't the greatest, but remember, we took images right over our face, which isn't always that cool. We then went and trained our model using our regular training script. We then went and did a bunch of stuff as well, right? So we uploaded our model into IBM Cloud to be able to host it. We then set our cause values, so we're able to access it from our app. And then last but not least, we actually went and updated all of our app details. So remember, when you're updating in here, a couple of key things to do. So you need to go into your app.js file, update line 17. In this case, it's line 17, but just look for the line that says tf.loadGraph model. So you update that with your hosted model. Update your labels inside of the utilities.js file, and then you might need to play around with your object detection array. So you might need to change these values. But in this case, we are pretty much done. So for project number 2, so we've now got our real-time app up and running. It's able to detect up, down, left, and right. Pretty cool, right? And so what we'll do is if you want to stop that app, you can just jump in to VS Code and just hit Control-C, or it'll be Command-C on a Windows machine or on a Mac machine. So that is our app done. So you could do that with a whole bunch of different models. So it doesn't just need to be your directions model. We did it for the sign language video. So again, if you want to take a look at that video, by all means, I will link to that in the description below so you can take a look at that. But now we are up to project number 3. So Raspberry Pi sentiments. So we're going to keep this one relatively simple. So we might try 1 or 2 classes. So maybe happy and then like sad or something like that. So we'll so obviously running object detection models on a Raspberry Pi does have certain things that you sort of need to cater for. Obviously, I don't have a GPU on this particular one. It's just a Raspberry Pi. There's nothing fancy happening there, just a Raspberry Pi. Now you can get a GPU extender, like for example, Coral You can also get like Jetson Nanos or sort of Linux style devices like that to be able to run it. But we're going to use a standard Raspberry Pi box and test this out. Now, I've got it sitting right next to my webcam. So we're actually going to remote desktop into our Raspberry Pi to be able to work with it. And we should be able to run similar detections to what we've done already. In this case, we're just going to be doing it from scratch. Cool. All right. So what we're going to do is kick this off. And again, as we've done before, we're going to be doing it very much in the same manner. So we're going to be collecting our images, training our model. The key difference between this particular project and the last two is in the first one, we just used a straight up, we used a microscope to be able to make those detections. For the TFJS app, we converted to TFJS to be able to run it. Now for our Raspberry Pi model, we're actually going to be focused on converting this to TFLite. And we're going to be using our specific model in a TFLite format. So let's go on ahead and do this. Now, what we'll do is we'll first up open up our image collection notebook. So again, nothing crazy there. And this time, rather than having, so for our directions model, specifically our TFJS app, we had left, right, up, and down. Here we're going to have, let's just try happy and sad. So we're going to update those. So we're really just going to have two objects. Now, you could even try one object depending on performance and see what that looks like. So again, we're going to import our dependencies. There's no need. Let's actually test our webcam to make sure it's pointing at me appropriately. Let's wait for that to open up. Cool, that's all good. So we'll move over to here to collect our images, and maybe we'll do like happy and then like sad. So like sad is like our face covered. So we've got really clear and defined objects because again, the camera that I've got on the Raspberry Pi is not as good as the webcam that I'm using on my PC as well. Another thing to keep in mind. So let's go on ahead and do this. So we've got our labels and we're just going to collect images of happy and sad. We should probably clear out our existing images. So if we go into TensorFlow, workspace images, and then collected images. So remember we had the down, left, up, and right different images, so we can delete those. We don't need them anymore. Now what we're going to do is collect our images for our sentiment detector, so happy or sad. So first up, we need to create the paths, and this is what step 3 does. So that should have created our path. So you can see we've got happy and sad. Then what we're going to do is collect our images. So again, we're going to collect 5 images, but you could change this if you wanted to. So I'm going to get into position and collect them. So let's run this. And we'll wait for our little pop-up. Sorry, I'm a little away from the mic. Oh no, it's running. That's not happy. Right, and then I think we're up to sad. So sad will be covering our face. Sorry, you probably can't hear me. I'm trying to see through my fingers. All right, cool. All right, that should be all of our images collected. So let's go and take a look at what we've got. So inside of happy, we probably should, I love this photo. This is great. This is me just dumbstruck. Okay, so we're going to delete that one. And we're going to delete that one. This is okay. This is, no, we want me smiling in them. All right, cool. This is fine for sad. So sad is us covering our face. So we're going to do happy. And let's collect some more images of happy. So remember, we can just isolate what we want to do. So we want 3 more images of happy. So let's do that. So all I've done is I've just removed sad from our labels array or labels list if it's Python. And then we want 3 more images. So we've got an even number of happy and sad images. So let's run this and then run our capture again. And I'm going to try to be happy this time. I'm just wait. Okay, cool. So let's go and take a look at our images again. This one, yeah, all right, whatever. We'll count that as happy. That's fine. That's fine. That's fine. That's fine. Okay, cool. So we've got our images. Now, as you might have guessed it, we're going to go and label our images. So we need to define our label path as per usual, spin up label image, and let's go on ahead and do it. So we're going to go back into our images. So workspace, images, and then collected images, happy, and do our labeling. So we're going to say that this is me, happy. Save that. Save that. And again, I'm doing happy in caps. Okay, so pay attention to that because capitalization is super important, or case is super important for this. Now, again, for the majority of this course, I've been doing it with a green background, but you could obviously do it without a green background or a green screen. I have just been taking the photos with the green screen, but that's okay. It will still work without it because you saw that we took it down and we tested it without the green screen. Now, what we're going to do is switch into our SAD folder and do the same. So that's we've already done happy. Let's do SAD. So let's capture everything to there. So SAD Nick. All right, then we're going to do the next one. And we're good. And again, I'm just keeping going through. I'm making sure my detections or my labels are as close as possible to correct. SAD. And I'm saving each object again. So this makes sure that we're not going to all this effort and then forgetting to save. And adjust there. Perfect. Okay, cool. Let's check them. So that's fine. That's fine. That's fine. That's fine. That's fine. Okay, cool. So that's good. Let's just open up our happy directory because I wasn't sure if we saved all of those. Fine, fine, fine. There's also another thing to note, right? So you can go back and open up the directory of images if you wanted to go and update a label, for example. So say, for example, we wanted to do microphones. We could go and label the microphone and type in microphone. I don't want to do it because it's going to screw up. But in this case, we only want happy and sad for this. But say, for example, we wanted to edit it. Like I didn't capture my full chin. We can go and make that update and hit save to be able to go and overwrite. Oh, it looks like I've just gone and killed that off. Let's go and make sure that we've still got that. Yep, so we're all still good. But you sort of get the idea. So you can open up a folder, you can make those updates. Alrighty, now as per usual, we are going to go on ahead and move our annotations into our training and test folder. So I'm going to go back into our images folder. We're going to delete everything from our test folder and our train folder. So these were all of our directions. And we are going to go and grab our collected images. So happy. So we'll grab 4 and 4. Nope. Yep, so those. So again, remember you got to grab the annotation and the image. We're going to paste those into train. So this will be a what now? It'll be a 80% split again. So again, we've got one image left inside of our test folder. And then we'll do the same thing with SAD. Sorry if there's a little whining on the microphone. I've got the Raspberry Pi running already, so it is a little loud. I'm going to copy this, and then we're going to do our test images. Oh, that's not right. So these test images should actually be inside of train. So let's cut those, paste it into train. Cool, so we should have 8 images in train, and we should have 2 images in test. So we got to go get that other one. So let's grab this SAD one and let's paste that in. Okay, cool, we're good. So if we go into our test folder, we've got 2 images. And if we go into our train folder, we've got 8 images. Pretty cool that you can build a object detection model of just 8 images, right? So again, this is super powerful what we're doing here. So happy, I'm pretty sure we've already moved that. So we can actually go and delete our folders inside of collected images. We don't need those anymore. Okay, now the next thing that we need to do is go back into our training model. So we're going to go on ahead and train a new model. So this time we're going to call our model sentiment. And again, it's not a full-blown sentiment model. It's just a high-level object detection model, but you could obviously extend this out. And we are running. And again, make sure you're in your virtual environment. So we're going to go through all of our path steps. So we'll import our operating system, set up our new custom model name, set up our paths, files. We'll actually create the paths. So now if we go in to our workspace, models, you can see that we've got our sentiment folder already set up. Now, again, we don't need to do step number 1 because we did that right at the start. We set up our TensorFlow models, our Model Zoo, and we installed TensorFlow Object Detection. Now all we need to do is update this label map. So under step 2, so we're going to say, what was it? Happy and sad. Save that. And then we're going to hit Shift Enter to create our label map. So if we go and check that label map, if we go into Workspace, Annotations, let's open it up inside of VS Code. That's looking good. So we've got happy and sad. We're good to go there. And then we can create our TF records. And again, this step over here, we can skip that. That's the Colab step. We can run this and this cell, and this should ideally create our TF records without issue. Cool. So that's gone and created them. As per usual, we're going to copy our pre-trained model config to our custom model folder. So let's do that. Then we're going to update it using these steps. We can go and double check that it's gone and updated. So if we go into our sentiment folder and open up this pipeline as per usual, let's open it with one VS Code. Got the correct number of classes. And if we scroll all the way at the bottom, most importantly, we've gone and reset the fine-tune checkpoint, the label map path, input path, so on and so forth. So we're good to go. Cool. Now the next thing that we need to do is, as per usual, train our model. So we're going to generate our command. And then we are going to go on ahead and paste this into a command prompt. So again, as per usual, we need to make sure we have the virtual environment enabled, and we need to make sure we're in the top level directory. So again, from here, you should be able to see TensorFlow and TFOD. And then we're going to go on ahead, paste our training command, and then we'll let that run and we'll be right back. So I'm going to paste it in and we'll be right back. Cool. So it's kicking off. We'll be right back. Alrighty. So that is our sentiment modeled finished training. Now, full transparency, I did run into an error when I kicked off this training run. Now, it wasn't anything that we wrote in terms of code. It was because all of the VRAM available on my particular PC was taken up. Now, in order to solve that particular error, all I had to do was stop my Jupyter notebook, which was consuming all of the VRAM. So if I take a look, I want to actually show you this error because it is pretty common, particularly if you're working on a GPU machine. If you see this error anywhere, so QBLAS _status _alloc _failed, or anything along those lines, that normally means, or you can see there's a similar one down the bottom, so CUDNN _status _alloc failed. So again, that normally means that your GPU is completely consumed. So if you go and take a look inside of your task manager and your GPU memory is completely consumed and you try to run the training run, you're gonna have a bad time. So ideally what you wanna do is stop anything which might be using the GPU at any point in time and then kick off your training again. Now in this case, once I did that, so I went and ran the training command again. So you can see it sort of errored out and it stopped there. Went and ran the training run again and it ran successfully. So right down the bottom, again, there's lots of lines. So right down the bottom, you can see that we've got our loss metrics appearing. So step 2000 and our final loss was 0.212. And again, if we take a look inside of our model folder, specifically the sentiment folder, we've got all of our checkpoints generated now as well. Okay, now the next thing, so because I stopped this notebook, so I stopped notebook 2, so you can see that that's definitely not running now. So what we need to do is start that back up. So we'll close this one, open it back up, and then what we need to do is import operating system, import these paths, and then if we scroll on down, we need this labels array. This is important. And then if we go all the way down to step 8, you should be able to reload all of your stuff. Now again, double check what your latest checkpoint is. So in this case, it's checkpoint 3. So we're fine with checkpoint 3 there. So under step 8, we can import our model. So we're going to test it out before we go and push it out to our Raspberry Pi. So let's import that model. And again, I'm going to skip doing the image, but we could if you wanted to. We're going to jump straight through to real time to see what our sentiment looks like. So let's run this. And CV2 is not defined, so that's our error there, and that's just because we skipped importing CV2 up here. So if we rerun this, ideally we should get some detections. We can close our task manager, don't need that. So I've just seen my webcam start up, so I can see the little light on it. Looks like we've got an error here. So category index is not defined, so that's an easy fix. We just need to re-import this. So whenever you restart your notebook, there's going to be a few things that you've obviously got to import. So if we import our category index, try this again. And this might actually error now because I didn't release my captcha, but we'll wait and see. Oh, nope, we're good. All right, so it's saying happy, sad. How's it looking? Sad, happy. Pretty cool, right? So like that's a lightweight sentiment model. So it's chasing my head around. If I put my head down, so what's it actually take for it to go to sad? So if I bring my hands up, so it's starting to get closer to sad. If I go all the way. So if I cover my face, it's sad. If I unhide my face, it's happy. So again, you can sort of see that it's, with these models, you can pretty much build whatever you'd like. This is why I kind of love TensorFlow Object Detection, or love the TensorFlow Object Detection API. It's really reasonably quick to do once you've got it set up. You don't need to go and set up other stuff all the time. So what's it looking like? So it's still saying that's happy. We get in position. So that's saying sad. So again, you can play around with this, but I love that it's chasing my head around. It's so cool. All right, so in this case, so we're happy now, but we want to take it a little bit further and actually push this out to our Raspberry Pi. So we're going to quit out of this by hitting Q on our keyboard. We're then going to freeze our graph. So we're going to go through step 10. We don't need to go through the conversion to TFJS because we're not doing that this time. So we need to do everything under step 10 and everything under step 12 in order to get this to work. So what we're going to do is we're going to run through step 10 and freeze our graph. So if I run all of those steps, including the command, we'll run this one from the command or from our notebook. This should generate our export file, which is over here. And then once that's generated, we'll be able to run the TFLite conversion. So again, a lot of these scripts are sort of pre-configured. You can sort of pick them up and leverage them. So let's give that a sec. Now, while that's happening, let's take a look at the steps that we need to go through in order to build our Raspberry Pi detection. So again, the third and final GitHub repository that I've sort of made available and written up is the Tensorflow Object Detection walkthrough with Raspberry Pi. So again, all of the steps that you need to go through to get this up and running are in here. So first up, we're going to start by going through our Tensorflow Object Detection course to create our TFLite files. Then we'll clone this to our Raspberry Pi. So we can either clone it from our Raspberry Pi or download it to our PC and then copy it over from our remote desktop connection. So in terms of this remote desktop connection, I'm actually using something called XRDP, which allows you to remote desktop or remote into your Raspberry Pi. So it's actually pretty cool. So it makes life a whole lot easier. I can code on my Raspberry Pi from my local PC without having to actually go into the Raspberry Pi. But all the code is actually still executing from the Raspberry Pi. So once we've done that, we've just got to install a bunch of dependencies, copy our converted model over, and then run it. So let's go on ahead and do this. Okay, so we've now gone through and frozen our graph. So we can see that in here. So we've got our checkpoint, our saved model, and our pipeline file. Good to go there. Now what we need to do is convert it to TFLite. So this is all going to happen inside of the TFLite export folder. So let's go on ahead and run this, and we should see all of our results pop up. Let's just bring this over to the side here. Cool. So if we run everything under step 12, I don't know why I focused on putting that to the side. All right, so we're going to run everything under step 12. So TFLite script, this, and this. And ideally, this should generate our TFLite export. So what you're looking for is a file called detect.tflite. That's the core file that you're going to be able to leverage inside of our Raspberry Pi. Now, I've already got our Raspberry Pi remote desktoped into, so I'm already remoted into it, or hooked into it, if you want to say that. So we'll be able to jump into that and take a look at that as well. So let's give that a sec, and then we should be able to kick things off. Okay, so that's the first part of it done. In a second, you'll see, so you can see inside a TFLite export, we've got this saved model folder. And once the second command runs, you'll have detect.tflite made available. So you'll be able to pick that up and leverage it. Cool. So you can see we've now got detect.tflite. So it's a little bit small there. You can make it a bit bigger. It's that file over there. So if we take a look at our steps, what we've now done, and these are the steps for the TFOD RPi repository. So the Raspberry Pi code in this particular case. Now, what we're going to do is clone this repository. So I'm going to jump into my Raspberry Pi now. And right up here, you can see that I'm just remote desktoped into it. And I'm going to create a new file, or a new folder actually, and we're going to call this sentiment. And we're going to jump into that. So we're actually going to open this up inside of VS Code. So I've got VS Code installed on this Raspberry Pi. Cool, nothing in there yet. So we're going to open up a terminal, and this is a bash terminal, and we're going to type in git clone, and then paste that link. What link did we have there? Oh, we already had git clone, so we don't need to type in git clone. Let's clear this. Let's make this a bit bigger as well so we can see what we're doing. Right, so we're going to paste that command into here. So git clone and then the Tensorflow Object Detection repository. So you can see that we've now got that, or it's starting to come through. So in there, we've got a couple of things. So we've got the detect.py file, and this is the main file that we're actually going to use to run our detection. So all of our good stuff is actually in here. Then we've got an existing detect.TFLite model, so we can actually run this off the bat without actually having to do anything else. So in this case, it's just a simple basic hello model. Now, before we actually do that though, there's a couple of key dependencies that we need to install. Now, they're all listed in this README here. So if we actually bring these up, you can see that we've got a bunch of files that we actually need to install. So specifically, these are all required to be able to work with OpenCV. And then the last one is actually installing this Python TFLite runtime. So this is really, really important to have these dependencies available because it's going to mean the difference between your model running and not running. So what we'll do is we'll go through each one of these and we'll install them. So I've already got this configured, but it's all good. Let's go on ahead and do it. So we're just going to paste the first command. So let's copy this. So that's going to install OpenCV Python. Looks like it's already installed. Then we'll install so all of these are dependencies for OpenCV. So specifically, we need to install these as well in order for this to work. So I'm just going to copy these and install them. So it looks like package. All right, so we've got to go through all of the rest of these as well. So let's go on ahead and install these. My copy and paste doesn't seem to want to work, so we're going to have to do this manually. Cool, so that's the next one done. And again, I'm just going through each one of these packages that we need to install, and I'm going through and installing them. So we'll just copy and paste. And I sort of wanted to show it to you from scratch, because that at least you can sort of see how to actually get this up and running. This next one done. And it looks like a lot of these are already installed, so it's going through them reasonably quickly. It's not actually installing it. Cool, that's that. Okay, so those are all of these packages installed. So we've now done all of these, right? But we've got these couple of packages left to do. So let's go on ahead and do this one. Cool, and then this one. Awesome. Then you should normally do a generic update. So we'll do the update and we'll install our TFLite runtime. So this last one is the most important one, this one over here. So this is actually what's going to allow you to leverage the TFLite runtime without explicitly having to go and install the full Tensorflow Object Detection API. So once we've got this line done, we're pretty much home free. So let's let this run for a sec, and then we should be good to go once our update is done. Cool, that's done. Now we'll do the last one. So this is going to install our TFLite runtime. So as I was saying, this is the main package which allows you to leverage a TFLite model, and specifically our object detection model, within our Raspberry Pi. So we're going to copy this. And again, these are all available through the README. So don't fret if you haven't picked up exactly what the command is. That's fine. All going to be available through there. Cool, so that's already installed now. Now, rather than running our custom model first up, I want to show you how to leverage the model that's already in there so you can sort of get a feel for what this is going to look like. So to run this, let's just clear these commands. We just need to cd into that particular directory because right now, let's just type in ls. Right now, we've got this subfolder, right? So TFOD RPy. So we're going to cd into that. And then if we type in ls now, so we've got our main folders. So to run this, all we need to do is run python 3 detect.py. So let's go on ahead and run that. So python 3 detect.py. And all things holding equal, we should, okay, so we've got our detection box opening up. And this is just a straight up hello model. So you can see it's a little bit slow. And again, it's running on a Raspberry Pi, so it's not crazy fast. But you can sort of see that it's detecting hello, it's detecting my face. And again, it's not the most accurate model, but you sort of get a feel for what's possible here. All right, if I bring my hand a little bit closer and start to see that's making detections on our Raspberry Pi. Cool, right? Okay, so if we hit Q, we can close that as per usual. Now, what we want to do is we actually want to do this with our custom model. So in order to do that, we just need to go back into our where we actually saved our detect.tflite file, copy this, and paste it into this repository. So what I'm going to do is I'm just going to paste it down. And again, if you're doing this without RDPing into it, you could definitely transfer it, like save it up into Google Drive or a Box folder and bring that over. In this case, having RDP available makes it a lot faster. So we're going to copy and then replace it. So we'll overwrite. Cool, so that's good. And then what we need to do, the last thing that we need to do specifically is we need to update this labels.txt file. So really all we need to do here is update it for our custom labels. And remember, if you remember correctly, we had two custom labels. They were just happy and sad. I'm just double checking the order that we had them in. So remember we had happy as ID1 and sad as ID2. So let's go on ahead and do that. So we're just going to make happy the first object. And then sad the second object. So we'll hit save. Now, all things holding equal, if we run detect.py again, so python 3 detect.py, we should effectively be running our custom model now. So let's clear this. Let's try that. So in order to run this, we're just going to run python 3 detect.py. And again, we'll see if we get any detection. So again, we haven't trained for that long. So at the moment, it is a little bit slow. And again, we're going through RDP. So doesn't look like we're getting any detections, and that's indicated based on what you're seeing down here. So it looks like we've got a random one. Looks like they're reasonably low quality. So what we might want to do is drop our detection threshold. So if you go into detect.py, you can actually change this up. So actually in this line here, so on line 68, if you change this, so let's try dropping it to, I don't know, 20% for now. So by changing that, and then what we can do is rerun this. So rerun our command. So we're going to run python 3 detect.py again. So let's see if we get some detections now. So it's looking like we're getting detections already. Okay, so we're getting one big sad, we're getting happy. It's looking like there's a fake detection over there. So there we go, it's detecting me as happy and sad at the same time. But you sort of get the idea, right? So you could definitely train this for a lot longer. You're getting these false detections over here, which isn't that great. It was detecting sad. Let's have a look. So it doesn't look like it's that great at detecting sad. You sort of get the idea. So you can obviously train this for a lot longer, performance test it. We only trained it on 8 images as well. So obviously this camera on the Raspberry Pi is going to be different to what we trained on. So you're going to get different performance when you do crossover. So that's another thing to keep in mind. But if we go happy, you can see that it's definitely picking us up. There is a little bit of lag when going through RDP. So if we go to sad, let's see if we can at least get one sad detection. Move over a little. lots of happies, weirdly enough. Let's try dropping green screen. It's got one big sad, but right, so it's detecting sad, but it's somewhere up here, so it's not the best result. Oh, it's drawing a big box around me as being sad. Now if we smile. Again, so it's not the best generalized model, but it sort of shows you what's possible, right? So that gives you an idea of how you can go about making your detections on Raspberry Pi. So again, looks like it's pretty happy, detecting me as happy, maybe sad, not so much. So if we wanted to performance tune this, we could add in more images of me being sad. In that particular case, under different lighting conditions, I'd probably drop the lighting because the feed from the Raspberry Pi isn't as bright as the webcam I've got on my computer, but you can sort of see that there are ways to tune this and there's ways to go and deploy your model and a whole bunch of projects that you can sort of take away to go and build yourself.
Now, performance for the sentiment model was okay, but during editing, I couldn't help thinking that this could be so much better. So what I ended up doing is performing some additional performance tuning to ideally eke out a little bit of additional performance out of this model. My OCD was in overdrive, so I decided to let it run free and try to get this performing a little bit better. This is what happened.
So during editing, I couldn't help thinking that I really wanted to get better performance out of that sentiment model. So again, as we went through in step 6 or part 6 of this course, I went through our performance tuning steps. So I added more images of the performing classes that weren't performing so well. In this case, I added more of both our sad sentiment and our happy sentiment, and I ended up training our model for longer. I didn't really need to change the architecture, but if I hadn't had a performance boost, that would have been my next step. So let's take a look at what it is that I actually did. So first up, I added a number of additional images. So all up, you can see that I added about 20 additional images. And if we actually open these up, you can see I've got images at a number of different angles. So this boosts our chances of having a model that generalizes well. And I also took down the green screen to ideally see if that had any impact on whether or not our performance was going to boost or not boost. So if we keep taking a look, you can see I've got images at a whole bunch of different angles, and I also had some images of me looking happy as well. And you can see I'm moving my head around, and this gives our model a better chance of actually being able to detect our head with the green screen up, but also with the green screen down. So you can see a bunch of different angles. And again, I went about the same labeling steps. So all I did was I created new images, went and labeled them again. That was the first thing that I did. The second thing that I did is I went and trained our model for longer. So if I actually show you, I ended up I kicked off the training for 10,000 steps. So you can see 10,000 there, but I actually stopped this at about 5,600 steps. I was kind of getting impatient and wanted to just test it out. So I trained for an additional 5,600 steps. Now what that gave me is a brand new model. So I didn't retrain the existing model. I actually went and performance tuned and created a new model. So if you actually take a look, exactly as what we did during the performance tuning step. So if I went into workspace, models, you can see here that I've got a model called Sentiment 2, and my checkpoint went all the way up to checkpoint 6. So you can see that there, because I trained for longer, I had a checkpoint with a greater index. Again, I went through the same steps. I went and converted it to a frozen TFLite graph. I then went and converted it to a TFLite model, and then I brought this into my Raspberry Pi. So now, this particular detect.tflite model that we had here is the model that's been trained for 5,600 steps, and it's been trained on 20 additional images. Those were the core changes that I made here. Now, if we try running this model again, let's take a look at performance. So if I type in Python 3, let's bring that up a little bit, detect.py. You can see that we're detecting happy. We're not getting all of those false detections. So if I smile, we're good. Now let's test out sad, because remember sad wasn't working, right? So that was the key thing that we wanted to test out. So if I put my hands over my face now, you can see that we are detecting the fact that I'm sad. So again, it's a much better performing model. And if we take the green screen down, let's take a look at performance there as well. So right now it's performing well with the green screen up, but what about if we took the green screen down? So again, still detecting that we're happy. And if we try out sad again, so if I put my hands over my face, you can see that we're getting significantly better performance now. And so you can see the little label in the bottom corner, but again, performing way better. And all I really did was I added those additional images and I trained for 5,600 steps. So you can see the power of performance tuning. And again, just because you get not the best performance first time around, doesn't mean that you can't go and improve performance after that to be able to generate better results. So that really shows you the power of performance tuning in this particular case. Editing Nick out. Now, on that note, let's do a quick recap. So the last and final project that we did was sentiment analysis. So we went and collected our images using our standard image collection capability. We went and labeled our happy and sad detections. We then also went and created our updated label map and trained our model. But the core difference between this and the previous two projects is we obviously went and converted it to TFLite so that we had that capability there. We then went and RDP'd into our Raspberry Pi, saved the model, and ran our detect.py script to be able to detect if we're happy or not. So it looks like, again, you could performance tune this and you could make this a lot better with a lot more training, a lot more images. So you've got the possibility to go and make this better. And let me know if you do. I'd love to see if you build a better sentiment analysis app. It'd be great to see. I think it's something super useful. And on that note, that wraps up our third and final project. So we went and did the first project, which is our microscope detection, our second project, which is our directional model, and then our third and final project, which was our Raspberry Pi sentiment model. And also on that note, that about wraps up our object detection course. So hopefully you found this useful. And if you've got any feedback, comments, or need any help, by all means, hit me up in the comments below. Thanks, and that about wraps it up.
Thanks so much for tuning in, guys. Hopefully you enjoyed the full object detection course. Now, please do let me know if you have any problems at all. If you need a hand, by all means, hit me up in the comments below, but also join our Discord channel. So I'm really active on there. So if you've got any questions, need some help, or want to join the community, by all means, do jump on there. Thanks again for tuning in. Peace.